Welcome to episode 11 of the Junior PenTester training series, and in today's video we're going to be going through this concept of file inclusion. And it can be a little bit of a complicated concept. For this one, I'm going to take my time explaining things, so hopefully you'll get a good understanding of everything, and then we're going to go through all of the practical exercises together as well, so you can get the answers that you would need and really implement the strategies behind this concept as best as you can, as many times as you can, so that it really just kind of grabs a hold of your memory and it stays with you. File inclusion is also known as local file inclusion, also known as LFI, and then it's also known as remote file inclusion, RFI, as well as directory traversal. So all of these things essentially are kind of talking about the same thing. And this is all a part of the web hacking module that's inside of TryHackMe's Junior PenTester pathway. And for this one, we're going to go through, obviously, the introduction. We have a couple of virtual machines that we're going to review and use for the exercises. There's the path traversal concept that we're going to go through. There's LFI, local file inclusion. Local file inclusion continues, so there's two portions of it. And there's RFI, remote file inclusion. And then remediation, which is the resolution of these things, how to solve for these things, mitigate them so that it doesn't actually happen to you or your company. And then there's a challenge that's going to be issued to us at the very end of this. And we get multiple labs. I think there's like 6 or 7 labs that are included inside of this particular room for this video. So we're going to get a lot of practice with this specific concept. The room was created by TryHackMe, obviously. There's Security Nomad, L000G1C, and then strategic or strategy for whatever. It's kind of tough to read these specific things, but big shout out to all of these different creators. Let me make sure I scroll down enough so you can see their usernames. Big shout out to all those creators. If you're a part of the TryHackMe community, you can actually request them as friends and be a part of their community, be a part of their network, which is really cool. And if you wanted to get access to me as well, my username is Hephaestus. If you place the E's in Hephaestus with 3's, that would be my username, and you can find me and get access to me on TryHackMe. I can show you my profile real quick as well, just so you get access to it. There you go. That's Hephaestus, the guardian as it stands inside of TryHackMe. This is a paid only room, so you do need a paid membership with TryHackMe to be able to get access to this, but this room is very robust and there's a lot of experience that you can gain from doing all of the labs inside of this room, and I highly encourage you to get that. I get nothing from TryHackMe by promoting them. I just have found a lot of value from this specific platform, and a lot of universities and schools use this platform to train their students and give them real world experience about all of the theories and everything that is talked about in hacking without you actually getting a felony or getting arrested or any of that stuff. So it's very, very useful to gain experience, but it's also really useful to not get into legal trouble. So that being said, let's quickly review our community Hackaholics Anonymous, and then we'll jump into the file inclusion room. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. And each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us dive into file inclusion. File inclusion is a very, very important concept, especially in environments or web servers that actually have files that you can access or files that are used for the web application to function. So the things that fall under file inclusion, the techniques that fall under file inclusion, are LFI for local file inclusion, RFI for remote file inclusion, and directory traversal. So we're going to talk about those. We're going to talk about how to mitigate and remediate for them. And of course, there are going to be practicals that we're going to end up using, or labs that we're going to end up going through. So the way that this works, or the scenario in which these things would work, is when web applications are written to request access to files on a given system, and that includes images or static text and anything else that can be accessed via parameters. And parameters are query parameter strings that are attached to the URL that could be used to retrieve data or perform actions based on what the user provides as input. So this is what it looks like, okay? The protocol itself would be HTTP or HTTPS. That part's kind of irrelevant. The webapp.thm is the actual domain name. Then there's the file name, which is get.php in this case. And then everything that comes after the question mark is the query. And this is a parameter. So the file itself is a parameter, and each parameter gets an argument that comes after the equal sign. So you have the file name in this case, that is the start of this whole process. The query begins with the question mark, and then anything after the question mark is the query itself. The parameter is what's before the equal sign, and then the argument for the parameter is what's after the equal sign. Parameters can also be looked at as variables that store values. So the variable would be this, and the value would be this, right? But in the context of file inclusion, we refer to them as parameters, and each parameter gets an argument, okay? So far, this is essentially the structure of the URL, right? And this URL would technically retrieve the contents of this file for us, okay? So, reviewing again, there are queries that are attached to the URL that could be used to retrieve data or perform actions based on the user's input, and this would technically be our input. So it would perform whatever the action is based on the input that we give it. So, for example, queries in Google would be GET requests that are passing the user input into the search engine. So, for example, Google search, and then anything after that question mark is the query. And so it would search for TryHackMe being the query. So if you're not familiar with it, you can view how the web works. And it's a very, very basic room that's inside of TryHackMe, and it teaches us basically how the internet works, right? And so how queries are passed along and how data is retrieved, etc. And this is a part of the Cybersecurity 101 pathway. So if you haven't gone through CySec 101, which is available inside of this channel, so you can go to the CySec 101 playlist, and there are many videos, dozens of videos on there, but they set the foundations for you so that everything that we talk about in a room like this will actually make more sense. So we go through the how the web works and all of that stuff in the CySec 101 playlist, the Cybersecurity 101 playlist. So, okay, let's discuss a scenario where a user requests to access a file from a web server. The user sends a HTTP request to the web server that includes a file to display. If the user wants to access and display their CV within the web application, it could look like this. So you have the webapp.thm, right? That's the domain basically. And then there's the get.php, and then after the question mark is where the query begins. And so it's file equals user cv.pdf, and then they're retrieving the PDF of their user CV, where the file is the parameter and the user CV is the required file to access, also known as the argument. So this is what it looks like. So they send this query. The web server processes the query, and it starts at the var www app location. So web apps are typically served at this location unless they've been configured otherwise. And then it goes to retrieve first the get.php file. The get.php file is essentially the script that's going to look through the web server to pull this file for the user to use. So this PHP file is the information or the script that basically searches through the contents of the file system to pull that file for us, okay? And then we go and get into the CVs folder, and then from the CVs folder, we get the user CV file, and it's pulled and it's sent to the actual user, and they get to access it, okay? So this is something that's key for us to keep in mind, this var www app location. This is something key to keep in mind. And then the fact that we're using the get.php file to be able to pull the data throughout the rest of the file system, we'll also keep that in mind. But this is a key piece of information where it's served. The location where the web application is served is very important for us to keep in mind. Now, why do these things happen? Why do these vulnerabilities, the file inclusion vulnerabilities, happen? They are found and exploited in various programming languages for web apps like PHP, that is poorly written and implemented. So the main issue is input validation, in which the user inputs are not sanitized or validated, and then the user controls them, sends them to the web server, and then the web server processes them. So when that input is not validated, they can pass any input. The user can pass any input to the function, causing the vulnerability. The risk here is when an attacker can leverage file inclusion to leak data like code or credentials or other important files related to the web application or OS. Moreover, if the attacker can write files to the server by any other means, file inclusion might be used in tandem to gain remote code execution or remote command execution, which is a really big deal. If you can actually get remote execution or a remote connection, a reverse shell, so to speak, to the actual server, then you can basically navigate this entire file system as if it was your own computer. And then you can take your time and do whatever the hell you want. Instead of trying to access the files that are here through the URL, you're literally inside the file system and you can do whatever you want at that point. So that's an overview of what this whole thing is, what file inclusion is, why it is caused, and all of that stuff. For the purposes of this specific exercise, for this video, I'm going to be using a virtual machine, and we're going to just go through the real quick overview of that. And I'm going to be combining the target machine, which is the virtual machine, with the attack box that is provided by TryHackMe, which is a browser-based Linux machine that we're going to be using to essentially run all of the lab exercises. The virtual machine has to be accessed through this button, but the attack box is not necessarily something that you have to use. So you can actually connect to the TryHackMe network via OpenVPN. So assuming that you actually have a user profile with them and it's a paid profile, you would connect to OpenVPN. OpenVPN is available for the free profiles as well, but for this particular room, you need a paid profile. So you would first launch the virtual machine right here. You would connect to OpenVPN or through OpenVPN to the TryHackMe network. And once you've done that, you can actually use your own computer and your own web browser, so on and so forth. Or you can actually use the attack box. I always use the attack box because sometimes there are some dependencies that are already pre-installed in the attack box, and I don't need to install all of those things just for an exercise inside of TryHackMe. So I lean towards just using the attack box, but you're more than welcome to do whichever option is more convenient for you. This is the link that changes every single time that you click this start machine button. So this isn't going to be what you're going to get access to. But once you get to that location, this is what it looks like. So there are 6 labs here that are available for us, and then there's the playground tab. And these are the exercises that we're going to be running through the rest of this specific video. So assuming that you actually have access to TryHackMe, this would be the point to make sure that your virtual machine is already up and running, your attack box is already up and running, or you've already connected to OpenVPN to the TryHackMe network, and you are ready to go. So let's look at what it means to do path traversal. Path traversal is also known as directory traversal, and it's a security vulnerability that allows us to read operating system resources like files that are on the server or even running an application. The attacker, being us, will exploit this vulnerability by manipulating and abusing the web application's URL to locate and access files or directories that are stored outside of the application's root directory, okay? So path traversal vulnerabilities occur when the user's input is passed to a function like file get contents in the PHP language. It's important to note that the function is not the main contributor to the vulnerability. It just retrieves files. So that part of it is not that big of a deal. It's what happens when you pass parameters to this specific function that ends up causing the vulnerability. Poor input validation or filtering is the cause of the vulnerability, and you can use the file get contents to read the contents of a file. And a lot of this is available at this specific link, which I believe is the PHP's website. So this is actually php.net, and this is the specific page that gives us more information about file get contents and what this specific function entails and what runs in the background anytime that you call on this specific function. So it's available at php.net /manual/en function, or you can just Google PHP file get contents function, and then it'll get you to this page. So it depends on how you want to get here, but you can get here if you want to read more about it. So this is what it actually looks like in the, this is pretty much a repeat of what we did previously in that previous task when we looked at how a user got their CV. But this is what it looks like when you use path traversal to get access to something that you shouldn't have access to. So a web application stores the files inside of this location, the var www app location. And this is a Linux Unix type of a syntax, right? So this is a path directory, assuming that this specific web application has some kind of a Linux Unix type of application that's running on there. That's what the path looks like, okay? So if you wanted to get access to the CV, right, the user CV, you would actually be in this, and then you would end up in the CVs folder. So this is what we see here. So this is the root, right, www app and then CVs. And then from there, inside of CVs, there's the individual CV file, okay? So that's what that is. Now this www app location is inside of the variable location, the var location. So this piece that you see right here, this / is the root of the actual website. And then in the root, there is this, and then in this, there is this, and then this, and this, and so on and so forth. And in the root, there's also these other partitions or these other locations that can be accessed as well. The way that we traverse a path traversal, the way that we do that is through a combination of this right here. So .. // etc. This is what it's called. The .. / is also an AKA for path traversal in general. And every time that you do .. // you move up one location. So for example, if you are inside of this location, so let's go back to this piece right here. If we're inside of the app location, if we do one .. it'll take us to www. If we do another .. it'll take us to var. And then if we do another .. it'll take us to the root. So if you are in app, you can do one set of dots and you'll go into W. But if you're in app and if you do two sets of dots, so .. / ... it'll take you from app to var. Okay, so you're moving two positions. If you do .. it'll take you from app and it'll take you into the root folder, into the root location. So that's what path traversal is. And we've done this a lot in a lot of Linux tutorials that I have on this on this channel, and even inside of the stuff that we've done inside of the junior PenTester pathway. This specific concept of path traversal is something that comes organic and natural to Linux environments. So just to kind of show you what this looks like, because the attack box that I have is actually a Linux attack box. And so you can actually do this just to get a really good understanding of what it means to do path traversal. So you go inside of your terminal, right? And inside of my terminal currently as it stands, if I do pwd, that's my current location. So I'm in / root, right? And inside of this location, there is the desktop. So if I go into the desktop, now my location is root / desktop. And inside the desktop, there's also additional tools, and then there's the other tools. So if I go into tools, now my location is root desktop tools. So this is represented by one .. This is another one, and this is another one. So if I go from here and I do cd .. it'll take me to the desktop again. So you can see I moved one position and now I'm in the desktop position. So if I go back into tools and I do this, I do cd .. / now I'm taken back into the root location. So you see it goes from this and it goes one more and then it goes into the root location. So if we go into desktop / tools, which it works that way as well. You can literally go forward or backwards using just a separator of / to / as the separator. So if I go from here and I do 1, 2, and 3, then I end up in the root. So you see now I'm inside of the root location. And if we do ls here, we see a whole bunch of other things. And so to go back to where I need it to be to get my desktop and everything, I need to go back into the root users folder. So I can do that, and that's where I end up here, right? I can go to CD, and then what do we have? We should have the var location. You see how there's a var here? So I can go into the var location, and I'll end up inside the var location. And then if there's a www, which there actually is over here as well, I can go into that location. And then in here, there should be an app, which there isn't. It's actually HTML. So now we can be inside of the HTML, and there is the HTML index file. So we can actually look at this and see what's inside of it. And now we can see that this is essentially the contents of the index file, which is, index is another way of saying the home page of a specific thing. A specific website is usually housed at the index.html file. And so this is what it kind of looks like, right? This is the contents of the index.html file, which for our intensive purposes is irrelevant. But you can see that there is even a var www location inside of this virtual machine that I'm in. Now, it just so happens that there is no app location because there is no web application that we have access to or a web application that we're housing. So I just do that again, and now I end up in this location, and now I can go back to root, and now I'm inside the roots folder with the desktop and all of those things. So that's path traversal, right? It happens with this strategy here, these dot dots forward slash dot dot forward slash. That's what we do to do path traversal. So what we can do is we can combine that with the actual query, the actual parameter that's passed to the query itself, right? So let's zoom back in so we can finish this lecture portion of this. So we can see that by doing this, by doing from the get PHP and then feeding the file into it, when we do this, we can do the dot dot forward slash dot dot forward slash da 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 da, and then we can go into the etc location, which houses the password file, which gives us the contents of all of the usernames and all of those things. So from the root directory, it goes into etc, and then inside of etc, there's the password file. But in order for us to get to the root directory, because we start here, so in order for us to get to the root directory, we need to do all of these dot dots, and then they did an extra one just to make sure that we actually end up in the root. So technically, it could have been done with 3, but they did 4 just to make sure that we're there for sure. And then we do forward slash etc, then it takes us to the etc folder, and then password gives us the contents of the password file. So this specific query that has been submitted should retrieve the content of the password file's contents, right? So this is just the overall explanation of everything that I just gave you, right? So the attacker can actually send this specific query, and they should be able to retrieve those contents. So if there is no input validation, instead of accessing the PDF files at the CV's location, the web application will retrieve the file for the password location. So this is what it is, right? So actually, I think that's why they did the 4th one, because technically, instead of starting from this specific position, they're starting inside of CVs. So they have to leave CVs, then go into app, then go into www, then go into var, then go into the root, and then from there they can go into etc. So they're actually leaving the CV's location because that's where we technically started, okay? So from there, we would be able to get the contents of it, which is, this is what it looks like, right? So it goes from CVs to app to www to var, and then we're inside the root. And once we're inside the root, now we can go to etc, and then we can retrieve the contents of the etc password file, which is what you see right here. There's the root user, and then there's all these other users technically that are just system users, and what their binaries are located as, and etc, etc. So we just able to pull that information. So if the web application runs on a Windows server, we need to provide the Windows path. So if the attacker wants to run boot init, which is located in this particular location in the root here, in the C drive technically, then the attacker can try the following depending on the target OS version. So essentially this first part stays exactly the same, right? But depending on the version of the OS, you would do 1, 2, 3, 4 to get into boot init, or you would get to 1, 2, 3, 4, and you would go to Windows and then win init, and then you'd be able to apply it that way. So it doesn't really matter, right? The concept overall is the same. It's this specific piece that are here that is the path traversal concept. So this applies with Linux operating systems where we climb up directories until we get to the root directories, And in this case, the root directory is presented by a single dot. So if you are actually there, it would be single dot inside that root directory. So developers will add filters to limit access to only certain files or directories. These are some of the common OS files that we can see when we're testing. So etc issue contains a message or system identification to be printed before the login prompt. Etc profile controls system-wide default variables like export variables, file creation mask, terminal types, mail messages to indicate where the new mail has arrived. Proc version would be for process versions, so specifically the Linux kernel version. The etc password has all the registered users. etc shadow has the actual password hashes of those users. So this is kind of misleading because there's no password hashes in here. The shadow file is where the password hashes are stored. So you would need both of these technically. If you can get inside the shadow file, you would also get the names of the users, but usually this is much more guarded than this one is. So the shadow file typically is hidden behind higher level privileges more often than not. And more often than not, anybody like an average user can actually see all of the users on the profile or inside of that machine, but the average user should not be able to see all of the password hashes of those people. So the root bash history contains the history of the commands that we've given to our root user. Verilog D message contains the global system messages, including messages that are logged during system startup. Mail root is all the emails for the root user. Root SSH ID RSA is the SSH keys for a root or any known valid user on the server, which is for secure shell remote connections. Then we have log Apache access log, which is the access request for the Apache web server. And of course, boot init, which is for boot operations for the BIOS firmware. This one is a Windows location. So you can see by the C drive that this is the Windows location. So which function causes path traversal vulnerabilities? And it's the file get contents that we saw at the very, very beginning of this lecture right here. The file get contents is what allows us to get the contents of a file. It just is not the specific vulnerability itself. This is just a normal function of the specific PHP type scripts. It just so happens that if it's not configured properly, this can lead to a path traversal vulnerability, right? This can be the cause of a path traversal vulnerability, although the file get contents is not the actual vulnerability itself. It's a misconfiguration that ends up being the vulnerability. All right, let's talk about local file inclusion. Local file inclusion, also known as LFI, these are web applications that are due to the developer's lack of security awareness. So again, misconfiguration, right? So within PHP, functions like include, require, include once, and require once often contribute to vulnerable web applications. So what we're going to be doing is picking up on these PHPs, right? We're picking on the PHP syntax. And it's worth noting that LFI also occurs with other languages like ASP, JSP, or even Node.js applications. So it's not just limited to PHP. These exploits follow the same concepts as path traversal, right? So we need to understand what path traversal is to be able to do local file inclusion. So we're going to go through various LFI scenarios and how to actually exploit them. The first one is supposing that the web application has two languages and the user can select between English and AR. No idea what AR actually is. I want to say, Arabic. There we go. Load the Arabic language. So this is the portion of the script that gets the language, right? So include, and then it gets the language itself. It uses a get request via the URL parameter lang to include the file of the page. And the call can be done sending the following HTTP request, which is this piece right here. So we can see this right here. So this is the domain, right? Index.php, which is the home page typically. And then we pass a query to it using that. And the language is the en.php, which gives us the English version of the page. And then ar.php will give us the Arabic version of the page. And these files exist in the same directory, okay? So keep that piece in mind. So these two files, the language files, are existing inside of the same directory. Theoretically, we can access and display any readable file on the server from the code above if there isn't any input validation. So security misconfiguration, that's what that is right here. So if there's no input validation, theoretically, we should be able to access and display anything. So let's say that we want to read Etsy password, which contains sensitive information, as we already know. We can do the web app get and then do file equals Etsy password. Okay. Technically, right here, we have lang equals whatever. So we can now just do file equals whatever, right? And technically, we should be able to see it. It works because there isn't a directory specified in the include function, and there's no input validation. Okay, so this include function that we see right here, there's no directory that's been specified. Therefore, we can just say that we want this specific parameter with this specific argument to be loaded for us, and there's no input validation, so it'll just pull up the file that is Etsy password. So now what we can do is we can try to read the Etsy password and also answer question number 1 below, which I guess would be done on the test machine that we have, right? And the next one would be the developer decided to specify the directory, so it includes, and then inside of that we have the languages directory, and then same thing, we're just getting a get language. And now we can use the include function, call the pages in the languages directory via the lang parameter. If there's no input validation, we can also manipulate the URL by replacing lang input with other OS sensitive like Etsy password. Again, the payload will look something similar to that. So it would be, this part of it is going to be exactly the same. Lang will be this piece right here. And so we're going to go from languages, which is the first location. Then we're going to go into from lang. So this one will take us out of lang into app. This one will take us out of app into the www. And then this one will take us out of www into var. And then this one will take us into the root folder. And then from the root folder, we would go into Etsy, and then we would go into get the password file. So we can do this to be able to get access to the answers for these questions right here. So we'll try to read the files within the server and figure out the directory specified in the include function and answer question number 2, which, I mean, the directory, I guess, is the includes directory, but let's actually do the exercise itself to be able to get access to the information. So I'm just going to go ahead and do a quick little split view, and then I'm going to open this up in full screen because I think it would just be easier that way. And then we're going to load our website, which is at this IP address. So we'll just go over here. We're going to open this thing up right here. And inside of our browser, we're going to load the IP, and that will take us to our lab. So it's lab 1. I think all of them are for the lab 1 exercise, right? So we're going to do this to answer one question, and then this is going to be answer the second. Yeah, so give lab 1 a try. Oh, okay, then the next one is lab 2. Okay, so we're going to have lab 1 and lab 2. So in lab 1, this is where we end up at, and it says include a file name in the input below. So what we're trying to get access to is Etsy password. So what would be the request of the URI? So if I want to do, if I just do Etsy password, is that what we do here? And so the current path is this, and now it gives me the contents of the Etsy password. So there you go. That's basically it. That was like not hard to do at all. So this is the contents of the Etsy password file. So root user, daemon user, etc. The path is this. So this is where we currently are. So it took us from here, and it took us to the Etsy password location. So actually what we saw in our terminal was correct, right? So the var, so if I do, where am I? I'm in root is where I am, right? So if I do one more and we end up here, so if I do cd var, and that will take me here, and I do www, and that'll take me here, and I can do cd html, that's actually the path right here. This path is what we see right here. So that's actually the current path. So maybe our web server is being hosted from the virtual machine that we're in right now. So that's cool. So now it says, give it a try. What it would be the request of the URI. So in this particular case, it's this piece right here. So you see lab1.php, file equals Etsy password, okay? Now, this piece that you see has replaced the forward slashes with the URL encoded version of them. So this is actual URL encoding, right? Or 2F, this piece right here is URL encoding. So if I actually take this piece right here and, or not even that, right? So if I do, yeah, maybe that. So if I just do this, and if I do, I don't want to cut it. I shouldn't have cut it. I should have copied it. So if I go here, take that and we'll copy it. And if we go to CyberChef, then we can get URL decoding, right? So if I enter something that has been encoded, it should actually give me the decoded version. So I'll paste it over here, and then we can see that it's the same thing at the bottom right here. So that those parts haven't changed. That is still the percentage, and this is still the percentage. So what I want is I want to do URL decode, which is what you can see on the left-hand side right here. And we just drag that in the center as our recipe, right? And then right here, now we can see that the URL has actually been decoded. So the 2F portion that we see right here has actually been translated to the /. And the Etsy is exactly the same, password is exactly the same. So that's the full URI that they're asking for. And that's what we were able to find right here at the very top. So that's the answer to question number 1, okay? Question number 2 is for lab 2, and it says, what's the directory specified in the include function? So if I go back here, and let's actually load up lab 2, and so it says, include a file in the input below. So for example, welcome HTTP. So I guess I'll just do this, welcome.php. And this is the current path. So that will actually give us that. And so it says, what is it? So what is the directory specified in the include function? And we don't actually get to see that here. So what would be the directory specified here? So let's see what the hint says. It says try an input valid to, an invalid input. Okay, so let's see. So let's do, I don't know, Hank hacks. If I do that, there we go. So now it says include, and then includes Hank hacks, failed to open that stream. So that's it. So that's actually the location right there. So that's how we get the specific folder that would be pulling from for this particular page. So if you do an error or like an invalid input, it'll bring that in for you. If you do a proper input, it won't bring it. So includes is the directory that was specified in our include function. So pretty simple, straightforward. So let's go to the next one where we continue with LFI. For this particular task, we're going to be doing something for black box testing, which is when you don't have any information. You don't have access to the source code. Because in the last one, we actually got to check the code for the web app, and then we got to see where the locations were and how we can potentially exploit it. So in this one, we don't have the source code, right? So in this case, error messages are very significant in understanding how the data is passed and processed into the web application. So we have the following entry point, which is the domain, and then we have index.php, and then we have language is English. And so if we enter an invalid input like THM for the language, we get this error. So include languages, fail to open stream, no such file or directory in this specific location exists, right? So it tried to pull THM-4 and then index.php on 12. So you can see that this is actually being replaced or placed inside of this path right here, which is very useful for us to know. So the error message discloses significant information. By entering THM as an input, we can see that the include function looks like this, first of all. And if you look at the directory closely, we can see the function includes files in the languages directory, and it's adding .php at the end of the entry. Thus, the valid input would be something like index.php and then English, where the file that's located is english.php, okay? The error message also tells us what the path is, which is what we already saw. So in this particular case, if we do the // right, // as described in the previous tasks, we should be able to get our way to Etsy password. And we have to do it 1, 2, 3, 4, and we would end up in root, and then we can pull up Etsy password. So 1, 2, 3, 4 is what they did, and then they were able to pull up Etsy password. So if we do this, include languages, fail to open stream, no such file or directory in this particular case. Ooh, interesting. So now we can see that we also need to do, I think, one more. So it seems that we got to move out of the PHP directory, but still the include function reads from the PHP. At the end, it tells us that the developer specifies the file type to pass the include function. To bypass this scenario, we can use the null byte, which is this. Using null byte is an injection technique where URL encoded representations such as this or this in hexadecimal with user supplied data is used to terminate the string. So you could think of it as trying to trick the web app into disregarding whatever comes after the null byte. So if we do this, include languages, etc., and then do that, then it should remove this piece right here. So this is the full query right here, right? So this would be the equivalent of doing this, right? The full thing right that we can see right here, except what we've done is that we have now, so 1, 2, 3, 4, 5. So that's definitely right because we're coming out of languages as well. Previously, we also, previously they did 4 is what we saw right here. So now that we use 4 because we know the path, we still receive the error, right? So we are coming one more out. We need to come out one more. So they updated to having 5. That's one piece. But we also need to modify this as well to remove the .php from the end of it because this is now having .php added to it, right? Because that's kind of how it was formatted. So if we have this inside of the initial set of quotes right here, okay, and you can see that there's also it should be, I think, another set of parentheses at the end, but it doesn't have that. It just has this one right here. So anyways, we can see that we have now removed the .php and it's been replaced with a null byte. So that should be equivalent to this piece right here. And then that should get it. So, but it says it's fixed and it's not working with PHP 5.3.4 and above. So this has been a fixed vulnerability. So now what we can do is apply to lab 3 and try to read the files in etc password and answer the question number 1. Now the next one is when a developer decided to filter keywords to avoid disclosing sensitive information. etc password is being filtered. There are 2 possible methods to bypass this. First, by using null byte or the current directory trick at the end of the filtered keyword, which is this piece, and the exploit will be similar to running this, right? So this is what it would be doing. We could also use this to put the null byte at the end of it. So essentially we're just putting, for the language, we're putting this as the actual location. So instead of the language itself, we're just putting the location of the file that we're trying to get access to. So if we try this in the file system using this, it will get you back one step. We already saw that earlier, right? If you do this, it just stays in the same directory. So the 1 dot represents that current directory that you're in. So when you do that, you actually just stay. You don't move up one directory where the ... does. So if we try to do this, then the results will end up being this because we're now going one directory and we're going to end up in etc. But if we just do this, right, if we just put the 1 dot at the end of it, then we should just end up in the same directory and it should just give us access to the etc password, right? So we will apply this in lab 4. Now the 5th one is the following scenario. The developer starts to use input validation by filtering some keywords so we can see the error message. So if we try this thing right here, we'll get this error that this specific language's etc password failed to open the stream. No such file or directory in this specific location exists. Okay, so if we check the warning message, we can see that the web application replaces these ... dots with the empty string, and there are a couple of techniques that we can use. So I see. So now we can do the payload being the 2 ... dots and the 2 // because one of them is going to be replaced. So if they've been searching for that, right? So if they go ahead and try to pull that information, that's actually very clever. So they have replaced this piece, right? And so all of these have now just been replaced, which means that they caught on. And so they have filtered this so that it doesn't show up. So in order to bypass that, we can just include another set. So when this one gets filtered out, we still are left with these 2 dots and that last // and then same thing. So Why did it work? Because the PHP filter only matches and replaces the first subset string, and it doesn't do another pass, which will take this that we see right here. It'll take this top part and it'll get rid of these red elements, because that's what the PHP filter will do, and then it'll still leave us with another subset, which is very clever. So we're going to use that on lab 5 and try to get those. And then finally, we'll discuss the case where the developer forces the include to read from a defined directory. For example, if the web application asks to supply input that has to include a directory like this piece right here. So this is the root domain right here that we see. And then we're going to do lang equals languages / en.php. To exploit this, we need to include the directory in the payload. So for example, we need to actually include languages in the payload, and then go ahead and do 1, 2, 3, 4, 5 to come out of languages, then go to the previous one and the previous one and the previous one, and it will take us back to the root where we can actually get into Etsy. And then we will do that on lab 6 to find out what directory has to be present in the input field. So now, all of that being said, let's go back to the top and try all of these exercises. This is very, very exciting. There's a lot of stuff that we're going to end up doing. See, this is really good practice. I'm telling you, I love this kind of stuff. All right, so what we're going to do is we're going to do for the first one, we're going to do lab 3, and we're going to try the null byte trick. So let's go back home here, get into lab 3, and what we want to do, so I'm going to try welcome, and it's going to give me welcome to THM, and then I'm going to try hacks, and it's going to give me an error message, and it's going to say includes hacks does not exist, right? And so it's not inside of this location, the lab 3 PHP online 26, and includes path for this user lib php all of these things. So these are some nice hints for us. Okay, so what we're trying to do is we're trying to replace the whole spiel, because it's going to say what hacks.php is not available for us. So if I'm trying to pull the Etsy password, for example, so if I do Etsy /password, it should also do the same thing, where it says the /Etsy /password. Oh, also I also included the, I think, did I do? Yeah, I did / as well. So if I do no / at the beginning, then it'll take that away. So now it says includes this location does not exist. So if we do this, right? So if I do 1, 2, 3, 4, and then I do Etsy password, it'll still give me an error because it's still adding that .php to the end of it. So all of that is still giving us a little bit of an issue. So what we're going to do here is we're going to change all of this to include this piece at the very end, where we will do this whole spiel. So include languages, etc., etc. So what it's going to do is it's putting everything that I'm putting inside of this. So all I need to do is the last element, this last portion right here, because everything is going to go inside of that. So all I need to do is I need to pull, I believe, this piece right here. I think that should be the full thing that we're going to paste. And let's see if this actually gives us information. Okay, so I tried a variety of different things. So check it out. So this is the wrong way, right? So if we do this, it'll say, okay, it's still, you know, the input form will take us to includes, and then it'll still do all of these things, and then it still adds the .php at the end of it. And then what happens at the top is that we can also see this whole spiel as well. It's being URL encoded, and all of those issues end up becoming, they change the query that's being submitted. So after trying multiple variations and failing, essentially, the hint is what I read, and it said just put it inside of the URL itself. So what I did was I just went and took this specific piece right here, this location, where is it? Where is the, right here. So I took the actual query, everything after languages. I took this whole piece, and that's the piece that I used as my modification, as you can see, right? So file equals, and then all of that, and then you press enter, and then it actually reveals the contents of the .php file for us. So that was the final query that ended up working, which is lab3.php and then file, etc., etc. So the answer that we're looking for question number 1 is the actual query. What's the request look like? So it's lab3.php question mark file equals, and then we get the path traversal elements, which is 4 of them. So you do dot dot forward slash dot dot, and you just do that. Make sure you do it 4 times. And then we end up with etc password at the very end of this, which is the final query that we end up with. It just so happens that that's not what it looks like right here, right? So this is the actual thing that we need to, and I'm very curious if I did do this, if I didn't include the null byte at the end of it, and if I just did etc password, yeah, it still would give me an issue because it's going to do the .php at the end of it. So we actually do need to do the, and I have a, maybe it was the enter. Yeah, no. So you still do need to do those null bytes at the end of it in order for this to work. But then the answer itself does not include the null bytes. The answer itself is just the actual query that would end up giving our request, which it's not the answer, right? That shouldn't be the answer, because the full query that we had to use was actually the one that included the percentage 00 and this whole piece at the end. That was actually the full query, but for whatever reason that wasn't part of the answer. So you will most likely have to just take this whole thing, delete the null byte at the end, and just give them this for your final answer. Okay, so that was lab 3. So let's go into lab 4, and the question for section 4 was this piece right here where it says, to make it clear, if we try the concept using cd we'll give you back 1 step. So if you do cd dot, it says in the current directory. So if we try to get this, it results to be this. That's because moving 1 to root. Now if we try to do this, the result will actually be this. So that's basically it. So I'm just going to try to do the, first and foremost, I'm going to do etc password in the entry point right here, and file get contents etc password failed to open this, and it's not able to pull lab 4. Okay, so if that's what we have right here, so if I do this, I wonder if I just go right here, do that, that still won't work, which is fine. So let's see if we modify this a little bit. I'm just going to do all the modifications inside of the, oh, there we go. So you are not allowed to see source files. Okay, so now that actually is trying to get access to it for me, which is very handy. So that kind of puts me towards the location that we actually need to be. So that's good. So, okay, let's see what other modifications I can make here. Okay, so the only modification that I made was I just added that null byte at the end of it, and that's it. So instead of, because this part I also tried to change the file that we see right here, I tried to change that into lang, and that didn't show me anything. So it needs to stay at file. That part of it is pretty much the same. The only thing that I did was I just added this null byte at the end of it. And if we try this, the file system will give you back 1 step. So all of those things essentially worked, and we were able to get this final response right here where it actually gave us the access. So now we want this query, I'm guessing, right? Or what does the question ask for here? So it says which function is causing the directory traversal lab in 4? So the function itself. So let's do something incorrect again. So we'll do etc password, right? You're not allowed to access this. So if I do get file, I don't know. Okay, there's the function. So file get contents get file. That is the function that is actually trying to pull the data for us. So if we do etc password, and then if we do the null byte at the end, that still doesn't work because it, for whatever reason, is not passing through what it should be passing through for us. So the only way that we can actually make sure that we get it, we go up here and modify it right here, and we do etc password, and then we do the null byte at the end, and that actually ends up working, and it pulls the information for us. So it's the file get contents is the function, and the only way that we were able to find this answer is to provide an incorrect input so that it tells us what function is trying to pull the data. Now, lab 6, right? That's where we are. Yeah. Lab 3, lab 4, lab 6. I think this is supposed to be lab 5, but it took me to lab 6. How is that possible? So I guess let's try lab 6. I feel like, did it say lab 5? Or, yeah, it says try out lab 5 and try to read the answer to bypass the filter. So I think this is wrong. I think this is actually supposed to say lab 5 right here, not lab 6. So I'm going to go back to lab 5 to try to get that answer, because that feels like a typo right there. And so what we're trying to do here is this specific strategy of doing the double dots and the double slashes to try to get access to the information that we need. So if we do this, right, so let's try it. If we go over here and if we do // etc password, if I do that, it will go ahead and modify it, and it'll say includes etc password, all of that has been modified for us. So if we try to do the double dots, so 1 2 1 2 1 2 3 4 1 2 1 2 3 4 1 2 1 2 3 4 1 2 and then etc password, let's see if that works. That does work. Okay, so this one actually worked inside of this query right here by itself. So I didn't even need to go up here to modify anything up here. It just worked by naturally putting it in here and just doing the double etc passwords. So what's the question right here? So it says, try it and check it. What's the directory that has to be in the input field? What's the directory that has to be in the input field? I don't know, because this specific piece is actually not the answer, because that was the path traversal thing, right? So I think we do actually have to be, so let me do Hank. I think this does actually is not a part of that question that we were looking for, because it has nothing to do with this specific exercise. So we do have to go to part 6 to be able to get this one right here. So what's the directory that we need to do? So access denied, allowed files at THM profile folder only. So these are the only files that are allowed, which is THM profile. So this is actually lab 6, so my bad. So they told us to just try out lab 5 to bypass the filter, but there is no answer or question that we need to get an answer for with that exercise. So the last one will end up being this specific one, where the developer forces to read files from a defined directory. So in this case, to exploit this, we need to actually go look at the actual languages directory. So for us, it'll end up being THM profile. So we're going to be trying to pull things from THM profile, right? So THM profile, and then I will do whatever. Let me see if I can do that. So inside failed to open the stream, no such file or directory on this location. Okay, that's kind of bullshit, but all right. So what does it say? What are we trying to do? And read etc OS release. What's the version ID? So let's see if I do, I'll do, what was it again? So if I just press enter, it'll say THM profile. So if I do THM and I do profile, lowercase, and then I'll do / // / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / / // and then we'll do etc / what is it? OS release, OS-release. There we go. And we got the contents of the etc OS release file. So basically all we did was we just went to that specific location and then we worked one, we traversed up one. So this is the first one where we get out of this, and then the next one, and then the next one, and then the next one, and we end up in root, and then we get etc OS release, and the version of Ubuntu is 12.04.5, which is 12.04, which is basically the answer right here. And that's it. That's all we had to do for that one, for local file inclusion. Those were all of the labs, because there's actually, that was the 6th lab. So I wonder what the playground is. So include a file in the input form below. All right, whatever. Let's try to do, maybe the playground will have some questions for us in remote file inclusion. Remote file inclusion is a technique to include remote files into a vulnerable application. So it's similar to LFI, This occurs when improperly sanitizing user input, allowing an attacker to inject an external URL into the include function. And one requirement for that is for the allow URL fopen option to actually be turned on. So again, this is a security misconfiguration. So this is an option that can be on or off for the web server, and if it's on, then it allows us to actually put an external URL into the URL that we're submitting to the web server, and then now we can actually execute a remote file. So the risk of this is higher than LFI because our FI vulnerabilities allow us to gain remote command execution on the server. So a lot of these consequences, or some of the other consequences, would be sensitive information disclosed, cross-site scripting, denial of service, because we can then pull whatever we want essentially from this external URL, right? We could house something in our own drive, in our own web server, and then we can pull whatever that thing is into the target's website and then execute it willy-nilly. In order for this to work, the external server has to communicate with the actual application server to get a successful RFI attack, where the attack actually, or the attacker, which would be us, we host malicious files on our server, our external server. So the malicious file is injected into the include function via an HTTP request, and then the contents of that file are executed on the vulnerable application server. So this is kind of the visual in case you were curious, right? So step one, we submit this URI right here. So web app, and then there's get PHP, and then the file, all of this is normal. So let me zoom in a little bit. All of this piece up to the equal sign, this is pretty much normal. And then we put our own link. So this is the HTTP. This is our external file that we're housing on our server. And so we submit this, right? When we submit this, get PHP will then run, and it'll send it to the webapp.thm, which is the actual web application. And then the web application will get, right? So it'll submit a GET request because we're doing a GET request. So it'll submit a GET request, and then it'll get this file from my web server, my malicious web server. And that malicious web server is going to go ahead and get that command.txt file, and then it's going to send that file, because this is where it's sitting, right? It's sitting in this location, and then there it is. The hello THM is what it reads inside of the command.txt, whatever. So we're going to do that, and then that file from this location is going to be sent to the actual web server, and then the web server is just going to return it back. So injects the contents of that into the include function, and it actually executes it, and then it sends back the results into the get PHP page that we just went through, right? So that's what that process looks like. This is the flow, the example of the steps of a successful RFI attack. So if the attacker hosts a PHP file on their server instead of this cmd.txt, it actually prints whatever this message is right here. It could be anything, right? At that point, it could be any malicious script that ends up launching. So we inject a malicious URL, points to the attacker server, like this particular location. So this would be the full URL, as you just saw. If there's no validation, the malicious URL passes to the function. Next, the web app server will send a GET request to the malicious server, and then it'll get the file. The web app includes the remote file into the include function, and then it executes that file within the page, and the execution content will be sent to the attacker. In this case, it just prints hello THM. However, it could actually be anything, right? It could be a reverse shell. So this is where we're going to go to test this out, the playground.php, to try the RFI attack. So we showed how to include pages, do research on how to get remote command execution, and answer the question in the challenge section, which is going to be the piece right here. So there's going to be some kind of a how to get remote code execution, or remote command execution, which is basically another PHP type of a script that we can include in this element to be able to pull it off. So if I go here, I'm going to try to see if I can just launch this. If we go here and copy this, I don't think it'll be the full thing. I feel like it'll just be the last element of it where we submit that. So now this is what we sent right here. playground file equals this, etc., etc., etc. So yeah, it's not that whole piece. I need the file to just be this piece right here. So we're gonna copy that, and we're gonna send that right here. We'll just do that. Press enter. Let's see. That also did not work. So attacker.thmcmd.exe. That did not work. Include function could not resolve any kind of a name for playground PHP. So failed to open the stream operation, failed. Okay. So let's see. Oh, this is so silly. It's because I don't think there is a website that exists that is called attacker.thm. I think that's the issue. So that's probably what my issue is. The reason why this isn't working, I think, is because, yeah, this doesn't exist. So it says, including this, failed to open stream operation, failed in this, failed opening that specific for inclusion because of this on line 28. So, yeah, it's failed of opening that for inclusion, I think, mainly because the fact that there is literally that specific domain. I don't think that exists, and this isn't part of the passing of this room, so we don't need to go and actually execute that specifically. They taught us what we need to do, because when we get to the last portion, the challenge portion, we'll probably have to do some kind of a remote code execution, including some kind of a remote command execution script. So we got to do a research on this so that we can get the final answer in the challenge. But this specific location, the attacker.thm command, that doesn't exist in the actual World Wide Web. So that is the reason why that didn't work. I was trying to figure out, like, why isn't this working? But yeah, it doesn't exist. Anyways, okay, moving on. Let's go to remediation. This specific section leans more into security engineering and being on the defensive side of things. So you will most likely work with people on the defensive side, even if you want to specialize in pen testing and ethical hacking. Your whole job is to be able to relay the information to the people in the engineering side and in the defensive side so that they can remediate, right? They can go ahead and fix whatever the errors were and the vulnerabilities were that you were able to exploit. So this is where this concept kind of just kicks in a little bit, and just some key points on how to prevent these types of vulnerabilities, the file inclusion vulnerabilities, to be exploited. So first and foremost, like the biggest thing, this is kind of like a big line item with pretty much everything, right? So the creators of these operating systems and the web application frameworks, they usually find these glitches and these vulnerabilities and they patch them, and then they release an updated version. So the best thing that you can do, the first thing that you should do, is make sure everything is current, right? It's the most updated, the most recent version of the web application. That's the very first thing that you can do. The next one is to turn off PHP errors, right? So meaning when we do something, right, and it gives you these errors right here, these error messages, turn these off so that people don't see what functions are being called, what locations are trying to be accessed, so you don't leak the path of the application and any other potentially revealing information. So just turn off those errors. The next one would be a web application firewall, so WAF. And this is a good option to help mitigate web application attacks. So in case somebody tries to do something, they get blocked, right? Their IP address gets blocked and they can't continue to do the thing that they do. And then usually some really good web application firewalls will also create a blacklist of all of those IP addresses and then send it to the databases like VirusTotal and a bunch of different locations so that everybody is aware of this malicious IP address. And that way you feed into the data intelligence, right? The cyber threat intelligence community, and everybody also gets access to that, which is very handy. Disable some of the PHP features that allow file inclusion vulnerabilities. For example, allowing URL fopen. You don't need that. I don't think anybody really needs that on their web application, where you can actually put in a URL inside of the query, and then that ends up pulling whatever the information is from that malicious URL. Also allow URL include, which is again these things, right? So to open a file from an external location or to include the URL from an external location, unnecessary. If somebody's visiting your website, they don't need to pull information from another website. They're just visiting your website. So carefully analyze the web application and allow only protocols and PHP wrappers that are in need. This is a little bit more technical, but if you do understand what PHP wrappers are, or what the headers potentially may be, or anything that has to do with the protocols that are passed to your web application, all of these things could be analyzed. In the modern world, you can actually submit this information to your favorite AI tool, and then it will tell you which ones are good to keep and which ones are vulnerable. And when I first did this, the first time that I did Junior PenTester, there was no access to AI tools. And that was literally, 2 years ago. 2 years ago, when I started doing all of this, there were no AI tools for us to use. And now there's multiple, and they're all really awesome, and they all give you really good information about something. So you don't need to know PHP. You don't need to know source code or coding in general. You can just take the code, paste it into an AI tool, and say, what is vulnerable about this? And can I safely remove it without affecting the functionality of my web application? Never trust user input. Make sure to implement proper input validation against file inclusion. This is a security configuration. So essentially just making sure that anything that is input from the user is being validated on the back end by your server before it actually is submitted to the server for processing. And implement whitelisting for file names and locations, as well as blacklisting, which is very, very important. So Etsy passwords should be blacklisted. Etsy shadow should be blacklisted. Certain parts of your web server and your file system should not be accessible to anybody other than a specific IP address that has been whitelisted. So you have 2 or 3 IP addresses that are allowed to access the full file system. Apart from that, every other IP address is blacklisted, and every other IP address should not be able to access the certain sensitive files that are also blacklisted. So we are now ready to jump into the challenges. All right, so what we're going to be doing is there's a specific location where we actually go to get the rest of the challenges, and there's also the one for the playground. That's the last one right there. So what we have is to go to this specific location, challenges index PHP, and then find an entry point that could be via get, post, cookie, or HTTP header values. These are the steps for testing for LFI. Enter valid input to see how the website behaves. Enter invalid inputs, including special characters and common file names. Don't always trust what you supply in input forms. Use either a browser address or a bar tool like Burp Suite. And then look for errors while entering invalid input to disclose the current path of the web application. If there are no errors, trial and error might be your best option. Understand the input validation if there are any filters, and inject a valid entry to read sensitive files. Okay, so we can see that the entry point that could be via get, post, cookie, or HTTP header values. So these things are actually things that we did not experiment with so far. Valid input to see how it behaves. Invalid to see what potentially might be the responses. Don't always trust what we get. Use either a browser or browser address bar, or a tool like Burp Suite, which it's actually, I've used it before. There are multiple videos on this channel for Burp Suite, so we'll see how that can be useful. Look for errors. If there are no errors, trial and error, and then understand validation. Okay, fine. All right, so the first one is capture the flag at Etsy flag 1. So we are going to first go here. So let me just copy this so we can actually go to that location. So we'll go here first. And challenge 1 is to try input form is broken. You need to send post request with the file parameter. So if I do file equals Etsy flag 1, right? Is that what it is? So that's what we're trying to get for the first one, is Etsy flag 1. So if I do, let's do this again, file equals / Etsy flag 1, nothing, because we are sending a get request right now, and the file equals this. So if I go up here and do Etsy flag 1, what does that do? Nothing. It doesn't give us anything. Okay, so the one thing that we can do that's kind of the easiest in my opinion would be to use Burp Suite. You can also send post requests to this to try to make it work as well. But Burp Suite offers a graphical interface to make it a little bit easier for us to do. So what we can do in this particular case is just use the Burp Suite Community Edition, which is free, and we can start it. And the free edition allows us to have all of the options that we would actually need to pull off these exercises. You don't need to get the paid version. So if you're doing this on your own computer, you can still do this by just downloading the community edition of Burp Suite, and that should be perfectly fine. So let's see if we can do this. So first and foremost, I'm going to copy this just to, it has nothing to do with Burp Suite, but I want to also see if I can do this on the command line by just sending a post request. So let's see if we can do it by just doing a post request first. Okay, so the post request actually worked. So the content preview is this right here. So this is the actual flag. So you can actually do this via the command line by just doing a modified curl command to pull that data. And so this was the full command. So normally, if we did this, if we did the normal version of this where we would just do a get request, you just do curl without this piece right here. So this is, just so you know, this is the full command right here, just to get the post request. So we did curl, and the execution is post, and the data that's being passed is the data that we're trying to retrieve, which is the file equals etc flag1, and then we're just giving it to the URL right here, which is the full URL, IP address, challenges/challenge1 PHP. Okay, so that would be the post request, and then we press this, and then it sends the full thing. And so you have to kind of be able to decipher all of these things that are happening and to read through this. And then really the piece that kind of led me know that I was in the right section of all of this jargon was this piece where we see the include, which is the button. So if I go, if I come out here, we can see that we have the include button right here, right? So anything underneath the include portion would end up being what our results would have been. So if I go over here, excuse me, if I go over there and try to find that include portion, which is the button right here, anything below that would be our response. So now it says current path, and then it gives me file location, and then this is the actual path, right? var HTML, which is the red lines of text that usually comes up. And then it gives us file content preview of flag 1 is fixed input form, or whatever that is right here. It's obviously formatted all funky. And that's actually the answer. So the first time that I did this, I didn't do this using a curl command, and the curl command version is much faster than anything else. So if we just do curl by itself, and then we give it the http / and then we put the rest of this piece right here. So if I do all of this, right, if I do this whole thing, this would send a get request to the web server. So we put here, paste, and then we just got to make sure that it's wrapped in quotations to include that full thing. This, what you see right here, this is just a normal get request that's being sent using curl. And then it pull anything else up, and it says, oh, this was not available. So let me actually go ahead and do this, because it included HTTP twice, so I got to delete the second one. But it doesn't do anything, right? It just does a normal get request, and it just has the include button and nothing underneath the include button, which is what we see right here, because this is what we did most of the time. And it just says the form is broken, you need to send a post request. And so we just had to modify our request to be a post request, which is what you can do with curl like this, and send a post request. When you do that, you need to send data to be posted. So the piece that would be the end of our URL previously, so this piece right here, this whole piece that ends up being the end of the URL, the file etc flag, that ends up being the stuff that's passed into the data. So where is it? This is the piece. So xpost is the execution of the request. The data is that piece that goes inside of the quotations. And then after that, you just give the URL itself that you're trying to access, HTTP, the IP address, challenges, and then challenge1 PHP. So that was pretty much it. That's like the fastest way to do this. There is a way that we can also do this to modify our request using the burp suite proxy intercept, all of that stuff. So by default, when you go into burp suite, under proxy, intercept is going to be on. But what you need to do is you need to set up Foxy proxy, and for TryHackMe, it's always turned on, or it's at least always installed. This is just an extension, and then you can make sure that the burp extension is turned on. To be able to look at it, you can just, I think we can double click this, or maybe not. So I should be able to at least see it. Right, there we go. So if we go into options, it requires private browsing, etc. And then we can go under proxies and we can configure a proxy. And so if we go into here, this is all the information that you need to configure a proxy with Firefox. So all of this is covered inside of the Burp Suite training videos. I'm just kind of giving you a quick review. So we named it Burp. It's going to be HTTP. That's going to be the protocol. The host name is our local machine's IP address. So this is our loopback IP address, 127.0.0.1. And then the port is 8080. And we just leave that as that. And then so that is just a configuration that we have for Foxy Proxy. So now we can go ahead and just make sure that it's turned on, which once you click on it, it's turned on. So now I know Foxy Proxy is good. And I can go here, and now I can just do this, right? The query that I have is this right here. Go right there and just press enter. And what you'll see is that it hangs. So it's not going to fully complete the request because now this request has been forwarded to Burp Suite. And now we have the request here. Okay, so this is it. So now that we can see that there is a get request being made, etc., we can go ahead and just modify the request and then forward it. So from here, I'm just going to go here and I'm going to turn get into post, and then I'm going to do forward, and it should give me, where's my response? There's like a response section. Let's go find the response here. Okay, I reloaded it. I tried it again. And so usually as soon as I click inside of the address bar right here, these first two entries show up. And then when I press enter, this third entry shows up. And previously I would just manually change this piece right here. So I think I can just do this, and then we can do change request method, and I'll change it into post, and then there you go, the file portion, all of it also changes down here. So I think that was maybe the error that I had previously, was that the rest of the request wasn't changing. So when you highlight that and then right click and then do change request method, it also changes the rest of the contents of this for you. And so in this case, then I can go ahead and forward, and there you go. So there's the response that we just got in the background, which is the flag itself that we're looking for. So that was the way that we could do it with Burp Suite. So you just make sure that your proxy is turned on over there. You make sure that intercept is turned on under the proxy tab over here. When you go into here and you press enter, it will hang, and then it will send a request here. And so this is our new request down here. And now we can see that the URL at the top is very different, right? So when you actually double click this and you convert it into change the request method, it removes the file from the URL at the top and actually turns a file data point right here. Very similar to what we did with the curl command, where we actually had to specifically designate what the file was going to be. And then when it's modified like this, we can click forward, and then the response is generated in the background again, and the browser is no longer hanging. It's actually processed the request. So that's how we do that with Burp Suite, and then we also did it through the curl command. So that was the answer for question number 1. Question number 2 is at flag 2. So let's go over here, and we're going to go home on this location for our challenges. Oh, I need to make sure that I turn off the proxy right here. So let's disable the proxy and go over here, stop that, disable the proxy. All right, let's reload home. There we go. Now we can go to challenge 2. And so what does it say? It says refresh the page, please. So let's refresh the page, and welcome guest, only admins can access this page. Okay, So that tells us that we need to modify ourselves somehow to get access as an admin. So let me see here. There was something that we did in the video prior to this one, in the last video, where we were modifying cookies on the web page to try to get access to the data of the web page, right? So this is most likely the place that we have to actually go again. So if we go to network underneath, so I right clicked on the screen, I clicked on inspect right here, and then from here we're going to go ahead and refresh the page, and then we'll see what's posted, okay? The stuff that's sent under the network tab. So we'll see there's the get request, challenge, bootstrap, jQuery, script, etc. Okay, so these are all the informations that we have here. Nothing really of note. So if we go to cookies, THM guest is what's available right here. So we might be able to just change that into admin and submit that information to see if we can get any extra information. So that's under the script, jQuery. So I'm just going to open this one specifically, and it says your JS code is here. Okay, so that's definitely not the one that I'm going to be messing with, it seems. I can also go under storage to see the cookies as well. And so I can see that the value of the cookie over here is actually guessed. So the THM value is guessed, the domain and the path are these things right here. So underneath my cookies, I can just change the value, I would presume, or change the path, it seems. So what are we trying to do? We're trying to access the Etsy flag 2, right? That's what we're trying to access. Etsy flag 2. Or actually, that was 1. Where am I at? Right here. Yeah, Etsy flag 2. And it's a cookies thing. So we definitely know that we have to modify the cookies. So if we go to the value of this cookie, so let me see if I could do this. So if I do Etsy flag 2 and press enter, and then I think that's it, or no, hold on. So let me see. Okay, so I actually had to refresh the page just to see the results of it. And so it says welcome Etsy flag 2. So the value, I mean, it's pretty much the same, but what we can see right here is that in the includes, it's adding the .php at the end of it. So we can go over here and put that null byte at the end. That I think it's the %00, right? And we do that, and then let's go here and refresh the page again. And so Etsy flag 2. Oh, I see. I need to do a path traversal. That's what I got to do. So we are currently inside the includes folder, and we need to make sure that we also get out of the includes folder as well as get to the root. So we're going to do .. and we're going to do this 4 times. And so it'll be like that. It'll be 1, 2, 3, 4, and then / Etsy flag. And then you're going to do the null byte at the end. So let's do that. And oh, boom. Look at that. We got the value of it. So cookie is yummy is what the value is, which is what you can also see over here. So again, just as a reminder, so I'm going to refresh this. I've already modified the cookie. So that's a piece that we have to kind of keep in mind. So I'm going to go back to what my original cookie was. So storage right here and the value of the cookie. And I think we could have even done it right here. We're under network. If we refresh the page, it'll bring all of these things up. And under the script right here inside of cookies, there was this piece that originally said guest, right? So we could modify the guest value accordingly. However, when I double click this, usually it allows me to do it, but when I double clicked it, it just said your JS code is here, and then there was nothing else that I could modify, so it would have to be under storage. So when we go under storage, click on cookies, then go on the link, and then the value of this originally was guest, right? That's basically what it was. So if I refresh it, it'll say welcome guest, only admins can access this page. So we'll go here, and then we go ahead and modify this value to do the like some kind of incorrect thing so that we can actually see what it was, right? So if I do this, for example, and do that, we just want to see where we are inside of the file system. And so it says includes, which is the directory that we're in, and then /, and then we also see that it adds the .php at the end, so we know that we need to put a null byte to remove the .php at the end. So now that we know we're inside of includes, we know that we need to do this 4 times so that we have that. And now we're going to do etc flag 2, and then we got to do the %00 for the null byte to get rid of that .php at the end. Press enter so it saves it, and then we go and refresh it with our fresh cookie, and then we got the cookie is yummy flag. So boom, we got that. Nice. Flag 3. So let's go to challenge number 3 here. And let's see what we got in challenge number 3. So challenge number 3 says include a file in the input. Okay, so let's do welcome. And it says that welcome to THM. Okay, let's do Hank Hacks as the file name. Now it says that, okay, so it says hankhacks.php is in not available, and challenge. Okay, so that's where the location of this specific thing is. So we know that we're inside of this location. So basically we would need to traverse 3 times. And then we also see that it adds .php to the end of our name. So that's interesting. Okay, so what if I do the etc flag 3 now? If I do that, it removed the 3. So it added .php at the end of it, and it removed the 3. So there's like a filter that's going on over here that is actually modifying our query if we try to get the etc flag 3 part. That's interesting. So okay, so let's see. So let's go to, let's see what we can do here. We are going to change the request to a post request. I'm just gonna, since I already have the browser or the burp suite available here, I'm just gonna drop all of these things. Can I do control all here and drop all of them? Great. Intercept is on, so we know that we're going to retrieve, or we're trying to retrieve, file 3. So that's interesting. So let's turn on burp suite now and go here, or actually here, and we're going to do etc flag 3, and it actually removed the forward slashes too. So if you can see that right here, it also removed the forward slashes. So we go here, and then now we need to look at this request that has been made. And so the request that has been made, we're going to modify this, change it to a post. And then in the post, we see that we have etc flag 3 inside the file. Okay, so now we're going to forward it. And let's see what happened here. Okay, so it allowed for the forward slashes and the 3 and everything to be there, but now it is actually adding the .php at the end still. So we need to put a null byte at the end of that. So we're going to do this one more time, and we're going to capture it while we are inside of burp suite. We're going to send it. We're going to capture another request, which is right here. Now we have another request here, and we need to do the percentage at the end. Look, and there's also the etc flag 2 and everything that's inside of our cookie that I feel like I should also remove. But let's just modify this real quick and change it to a post. So we're going to change the request method to a post. Come down here, and it's flag 3 right here. And I need to do a %00. I wonder what the URL encoded version of %00 would be. So let's see. Oh, cool. So it was actually just %00. That's all it was. It was okay. That was a lot simpler than I thought it was. Okay, so I'm going to try this one more time just so you can see what's going on. So I'm going to do this. We could do /etc flag 3. Okay, press enter. It's going to get captured by burp suite in the background right here. So we're going to go to the background right here. We have our request, which is a get request. We're going to highlight that. We're going to do change request method, and it's going to change it into a post request. And then the file is going to be the flag 3 right here. And so now I need to do the %00 to add that null byte at the end. And I click forward, and we have the flag again. So, I mean, the flag loaded because it was already there, but it actually works. So that's literally all I did. Very, very simple, very easy to do. And that actually worked. So that was nice. So that's challenge number 3. So flag 3, post is working. There we go. Finally, gain remote code execution in this thing with RFI to execute the host name command. So we're going to go back to the playground, and we just need to get the host name command, and we need to create some kind of a PHP script to get the host name command. Now, I'm not that good at PHP, so if I want to execute a PHP, or if I want to create a PHP file that executes the host name command, right? That's basically what it is that I'm trying to do. Because if we go here, right? So if we go to our terminal and just type in host name, it'll give us our host name, which is the IP address, etc. So that's our host. So that's the command that we want to execute, and that's what we're trying to get, the host name command here. But we want to execute it through remote command execution in the playground location. So first, let's just go back to what the thing was right here. This, I think it was the root, right? This is where we go to get access to our challenges, our root stuff. Oh, I need to turn off my burp suite. So let's disable burp suite here and do that. And okay, so now we're here. Now we'll go to playground. Okay, so we're here now. And here is where we want to execute the file inclusion, or we need to do the remote code execution so that we can get the file. And we're doing the thing where we did, what was the thing where it was like the including of the URL, right? So remember we were doing remote file execution, and then there was this URL open option where you actually add something to the end of the URL. So for example, attacker, THM, etc. So what we need to do is we need to have a location that we actually put our script, right? So this is a very basic script. And then from here, once we've created a PHP script that can execute the host name command, we would then host it on our own machine as our server, so we can turn our own machine to a server, meaning this attack box that we have, we can actually turn it into a server. And it's very easy. I'll show you how to do it real quick. But once we've converted the attack box into a server so that we can serve that PHP script that will do the hostname command execution, then we just go ahead and bring it over here and include it inside of this, where the file name is going to equal the path to our server and the file itself. So the first thing for me to do is to just find out how to create a little PHP script that will execute the hostname command. So let me do that real quick. Okay, so there it is. Really basic, really simple. There's like a super complicated version of this as well, but basically you just want to print the value of this execution, and it's executing the hostname command. That's basically it. That's the script. So we're going to copy this right here, and we're going to go into our terminal first and foremost, and we're just going to create a file. So we'll just call it nano, and it'll be host, and I guess it needs to be a txt file. So we'll do that, and we're going to paste it in here, and there it is. So Control O, enter, Control X, because what they did over here, it was a txt file. So the command was a txt file, but inside of it was the PHP script. So there you go. So that's that's the host txt file that we had, which is literally 3 lines. So that's it. So if you want to just copy that for yourself, you can go ahead and copy that. So that's our file, okay? And it's inside our location. So there it is. And our print working directory is inside of the root location, is where everything is hosted for us. So now what we need to do is we need to convert our machine here to a web server, or some kind of a server where somebody can come and download this file, right? So that's basically what we want this application to do, is we want to connect to some kind of an IP address to download that host file. The way that we do this is using the Python script server. Or Python has an internal HTTP server that you can just launch. It's very easy to do, very simple to do. The attack box IP address for me is this thing, 10.10.33.62. But in case you're doing this on your own machine and you don't know what it is, it's ifconfig is when you launch it, and it will give you the address that you're looking for. So in this particular case, I want the inet version of my address, which is right here. So the ENS5, which is my interface. So the Docker is not the interface I'm concerned with. Loopback is not the interface, and it's not these ones at the bottom either. It's always usually it's some kind of ENS or something like this, where it's like the actual interface itself. And we're looking for the INET4 address, or the INET address, which is the 10.10.33.62. So now I know that's my IP address. So when I want to connect to my attack box, that would be the IP address that I would want to connect to. So now that I have that information, now I can create my server. So it's Python 3, then you do m http.server, enter, and that's it. And now it says serving HTTP. Let me actually, because I accidentally clicked on something else. So we do that, and then we press enter. Now it's a little bit cleaner. So now it says it's serving on port 8000. So anybody can download anything. The IP address, however, is not 0000. So it's actually that other IP address that we found, which was this one, basically. Where is it? It's this piece right here. So that's the actual IP address that we just found with ifconfig. So it would end up being at this location, except we just placed the zeros with our actual IP address, and then you do need to include that port number at the end. So now our machine has actually been turned into a server, and we can download files from it. So now we actually get an IP address and a location where our file is sitting. So if we were to go ahead and modify the query at the top right here, right? So if I want to get, what is it? I want this, right? I want Etsy flag 4. If I want to do that, we can see that, okay, Etsy flag 4 does not exist, da 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 da. So what I can see right here, though, is that the query has actually been modified accordingly. So I need to change this piece right here. Everything after the file equals is what I'm going to do to add my specific IP address. So it's that 1010, what was it? 3362. So it's 1010.33.62. And then the colon, and then the port, which is that 8000, that's where it's actually sitting, and then /, and then the name of the file, which is the host.txt. So now this would, ideally, it would pull what we want, right? And press enter. So it should actually, look at that, file content preview of this. So it actually went and connected to our IP address, or our server, and it pulled the information. So this is actually the host name, I guess, that is existing for this web server, for this server, this playground application server, not my machine, because you know I already ran the host name and it was a different host name. And to confirm that it actually worked, you can see it here. So 10.10.212.4, which is this piece right here, the actual web server right there, that connected to us, and it did a GET request, and it downloaded the host.txt file. So we know that that was actually successful as well. So this is actually the local file inclusion, virtual machine, THM. That's the full host name for that, which ends up being the answer to our very last question at the end right here, the LFI, VM, THM, etc., etc., etc. So just to review that, we created the script, very, very basic script using, I'm just going to close out of that. We created a very basic script, which is this host script that we had right here. And so the host.txt file just has a basic PHP script inside of it that says execute the hostname command when you're when you're executed. And then from there, we launched a Python server. And the way that we did that was just doing Python 3-m HTTP server. Then it turned our computer into a server, as you can see, serving on this location. And then we were able to go to this location on the web server and change the parameter at the very top right here to read file equals that, which is the location of my attack box on that port. And then I just pulled the host.txt file, and then I was able to get the answer. So I'm not going to say very easy, but pretty simple. I would say it's kind of like straightforward. It should be pretty simple to wrap your head around. Hopefully it was. Okay, so this was a monster of a room, and hopefully you got some good value out of it and you got a chance to try out a bunch of different exercises. I remember the first time that I did this, it was very challenging for me because it was a very, very new concept. Most of it didn't make sense to me, and I went through a lot of trial and error to try to figure out the answers to these questions. And I feel very happy that this time around I actually understood what the hell was going on, and I was able to make sense of everything and educate you. Hopefully it actually got a chance to transfer some information to you to make it a little bit easier for you to understand what is happening and what just went down inside of this room, because this is challenging. This was challenging. It was one of those things that for a lot of people, this is like a really, you go from like basic introductions, you go through some basic concepts, and all of a sudden it feels like you're thrown in the deep end. And this is kind of what it felt like for me the first time that I went through this. So it's not the easiest concept to wrap your head around, but hopefully this video made it a little bit easier for you to understand what just happened and what went down. So we went through the concept of path traversal. We went through what local file inclusion actually is, remote file inclusion, and we actually even did some challenges where we were able to pull information from our own web server that we created, and then how we were able to do path traversal to be able to pull the flags and all of those things. So I personally, it was valuable for me to even go through this a second time around. So hopefully this was also valuable for you, and you got a chance to learn from it and grow with it and even experiment and apply some of these theories behind the concepts of path traversal, file inclusion, etc. If you found value out of this video, I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out like this one. And of course, go discover all the rest of the videos that are available on this channel, because there's a lot of stuff that's here. And as we go deeper into the junior pen tester pathway, you're going to get more videos, obviously, on junior pen tester. And every Friday, there's the CompTIA Pentest Plus videos that come out as well, which is a more advanced introduction or a more advanced deep dive into the pen test conversation. But if you haven't gone through junior pen tester, that's going to be a little bit difficult to wrap your head around. And there's this piece right here. If you haven't gone through CySec 101, then you're going to have a hard time just going through junior pen tester. And if you're going to have a hard time going through SOC level 1 and SOC level 2 and security engineering and things like that. So this is a very, very important playlist. If you have not gone through CySec 101, I encourage you to do it. Then there's Linux Plus, Security Plus, Network Plus. Currently, we're building out CompTIA Pentest Plus. There's all the stuff that's available for Hackaholics Anonymous. And then once you're done with Cybersecurity 101, you're going to either go defensive or you're going to go offensive. And depending on the route that you choose, there will be different playlists that will be available for you. And if you choose to go defensive, then you have SOC level 1 and SOC level 2, as you can see right here. And then ultimately, you'll end up in security engineering. If you choose to go offensive, then you're going to go into the junior pen tester, which is where you are right now. And you will continue with this until you were done with this. And then after this is over, you would end up going into Pentest Plus. And then ultimately, we're going to do cybersecurity analyst, which is CYSA Plus. And then I will most likely just go from there, and we'll just go deep into the AI for cybersecurity, so we can learn how to train AI and create our own agents inside of cybersecurity and inside of pen testing and all of those things. So if you have any comments about the video that we did today, I'm sure that it could be probably overwhelming and it could be a little bit confusing. Hopefully the contents of the video made sense, and hopefully you don't have questions. But if you do have any questions, please let me know in the comment section below. And if you just want to say hi, drop it in the comment section below, all that good stuff. If not, then make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And that being said, I'm going to introduce you to Hackaholics Anonymous, and then we're going to wrap it up. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the comments section. If not, I hope I see you in the Discord chats. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Later. In episode 12 of the Junior PenTester training series, we are going to go through the introduction to server-side request forgery. And server-side request forgery, as the name implies, is when we submit forgery requests to the server, and if the server has not been configured properly, it will ideally return whatever information we are looking for or do what we want it to do. Typically, everything that we've done up until this point has been client-side requests, meaning the stuff that you do through your own web browser, and then those requests can be manipulated, and your web browser would be your client, right? And then it's sitting on your host, which would be your computer. But from here on, what we're trying to do is we're trying to manipulate the server itself, because technically you can submit something through the client and the client could actually accept it, but then when it gets to the server will actually go through it and it'll say, no, you know what, I'm not going to process this stuff because I've been configured properly, and so the server won't process that request for you. When we do SSRF, the server has not been configured properly, or at least we hope that it hasn't, and what we're trying to do is we're trying to manipulate the server to do what we want it to do. That's what SSRF, or server-side request forgery, actually is. Now, the path itself, or the video that we're going through today, obviously we're going to touch on what it actually is. I kind of gave you like a quick little bit of an overview, but we're going to touch on what it actually is. We're going to go through some examples of it. We're going to find a server-side request forgery. We're going to defeat some of those defenses that would be potentially in place on the server so that we can kind of maneuver and work our way around them. And then of course there's a practical exercise because we are officially in pen testing. Therefore, we have to practice all of these theories and concepts that we're going to be learning. This particular room was created by TryHackMe. I'm pretty sure it was created by a person, but we don't have an actual username that's been assigned to this particular room. And it is a subscriber-only room, meaning that it does require that you have some kind of a paid subscription to TryHackMe. I will say that it is very, very worth it. I sing their praises all the time, and it's not something that I get paid for whatsoever. I don't get any benefits to refer you to them. I just think that it's a really good platform. And if you want to learn hacking, you need a place to actually practice all of the hacking techniques and tactics without getting into trouble legally. And a place like TryHackMe would be the perfect place. So if you don't have a membership already, consider getting one. If not, you can just kind of follow along in this video with me, and you can try to do it against your own servers if you have one, or just try to take some really, really good notes so you can wrap your head around it. And then when we go through the practical, I'll try to explain that to you as best as I possibly can. That being said, quick word from our sponsor, Hackaholics Anonymous, and then we're going to jump into the video. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the introduction to server-side request forgery. In this video, we're going to learn what SSRF actually is, what kind of impact it can have, and some example attacks that we can discover, and what vulnerabilities we can discover, and how to circumvent the input rules. Then we may have a practice for us so that we can go ahead and get some good experience with all of these different newfound skills that we have with manipulating servers. So it should be exciting. So what it stands for is the server-side request forgery, as I've mentioned a few times. It's a vulnerability that allows a malicious user, being you and me, to cause the web server to make an additional or edited HTTP request to the resource of the attacker's choosing. And there are 2 types of this vulnerability. The first one is just a regular SSRF where the data is returned to our screen. The second is a blind SSRF where the actual thing occurs, where the vulnerability itself occurs, but no information is returned to our screen. So if it's successful, you don't really get a success message, or you don't get any information displayed on your screen. So you kind of have to find other ways to verify whether or not your attack was successful. So what is the impact with this? If we can actually successfully launch these attacks, you can get access to unauthorized areas, you can get access to customer or organizational data, the ability to scale to internal networks, and reveal authentication tokens and credentials. Just a few of the very high impact goals that you can accomplish if you are successful with an SSRF attack. So what does it stand for? It stands for the server-side request forgery. As opposed to a regular SSRF, what's the other type? That would be the blind SSRF, where we actually don't see success messages or anything like that. And that is what we have for the intro. So let's look at a couple of examples real quick. To go through the examples, we need to click this View Site button that's available over here. These are some of the key benefits that are available through a place like TryHackMe. So when you click that, it opens up in split screen, and then we get to look at this right here. So it says we're going to take you through some attacks and explain how they work. At the end of this, you'll have to figure out one for ourselves. So here we go. The first one shows us the attacker that has complete control over the page requested by the web server. The expected request is what the website.thm server is expecting to receive, with the section in red being the URL that the website will fetch for the information. The attacker can modify the area in red to a URL of their own choice. So this is what we have, right? So the website THM server is going to pull something, right? And it, I guess, is like a stock image or something like this. And so stock, and then everything after the question mark would end up being the parameter that we're requesting, right? So the URL would in this case be the parameter, and it would have a value. And this area in red is the stuff that, let's say, the legitimate returned item would come from the API of website.thm server, and then it would pull stock item ID number 123 is what it would pull for you. But this is also the thing that we can potentially manipulate, right? Everything after this initial parameter, because if you pay attention, there's also another question mark right here that gives a second parameter, which is the ID number equaling 123. But what we're doing is we're pulling this ID from the API of the website.thm servers, and then we are feeding it into the original domain that made that request, right? That's kind of what the expected request is supposed to look like. So the hacker in this particular case would request this, right? The website will then submit that request, and then the API server returns the data to the website instead of any kind of stock information, and then the website returns that data to the actual hacker. So it first goes from the website, then it gets sent to the API, and then the API server will actually submit that, send it back to the website, and then the website would display to the hacker ideally. So that's the first part of this. The next part is how the attacker can actually reach the API user page with only having control over the path by utilizing directory traversal, which is what we talked about a few videos ago when we were going through, I want to say it was EDOR, was the vulnerabilities that we were looking at. Let's see if it was actually EDOR. Authentication bypass. Yeah, I think it was EDOR. It was actually file inclusion. So it's actually the video right before this one was the one that we went through where we looked at a lot of those traversal attacks that we did. So we can do that in this attack as well. So we can combine two tactics technically. So when website.thm receives the ... is essentially going up one level inside of the file system. This is a message to move up a directory which removes the stock portion of the request and returns the final request into the API user portion. So this is what we see right here, right? So we have stock, right? And then the URL would end up being this. So that actually it's easier to see it this way. So stock is where we're currently sitting, is where we're at. And then within stock, we're going to request one of the stock images in a normal situation. But what has happened is we've replaced that with the ... So it would take us out of stock. It'll take us back into the root right here. And then usually when you're inside of the root of a file system, there should be a user folder that would be available. So we would do ... go up from the stock location to the root, and then from there we would do /user to ideally end up in the user folder, the user location inside of this specific web server. In that example, or in this particular example, the attacker can control the server subdomain to which the user is made. Take note of the payload ending in the ampersand x equals, being used to stop the remaining path from being appended to the end of the attacker's URL, and instead turns it into a parameter, which is the question mark x equals on the query string. So this is what we have right here, right? So we have this is the one that we're looking for in the malicious request, which it goes right here, right after the user, right? It would be ampersand x equals, and then and ID equals 123. So that would be submitted as a request. The website will then submit that request to the actual server. So it would be API website THM, etc. And then it would actually say question mark x equals, which is what the replacement of the ampersand x equals portion would be. And all of that feeds into, it's the subdomain basically. It's like the piece that comes right before the website.thm, because if you see it right here, it's website.thm stock server is what we see, but then that portion was fed before the website.thm, and then API stock item, and then ID 123. So this is converted into this, and the key element for that is this portion right here, the ampersand x equals, because the ampersand x equals, everything prior to that, API website da 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 da, is being placed right before the website.thm in the submitted request to the server. And then we have website.thm da da da, and then we have the and ID equals this. So hopefully it's not too confusing to understand. Feel free to pause the video at this point to just kind of look at the difference between these two elements. This is what is actually submitted to the server. The server will then convert this, right? So, or I should say it like this. This is what's submitted to the website. The website converts this into this and then submits it to the API server. Then the API server will actually return that data to the website, and the website will display it to the hacker. So we made this request to the website. The website converted this request to this request, and it did so based on these few elements, right? When you add this to the end of an image, what it does is that it stops the remaining path from being appended to the end of the attacker, and instead turns it into a parameter on the query string itself. And then it was placed at the beginning of the URL, which ends up acting as a subdomain. And then from there, it's submitted to the server. So now if we go back to the original request, the attacker can instead force the web server to request a server of the attacker's choice, right? So instead of requesting the normal server that it would actually request, we can give it a different URL to go and request. And so from there, we can capture the request headers that are sent to the attacker's specified domain. These headers could contain authentication credentials or API keys that are sent by the website.thm that would normally authenticate to api.website.thm. So website.thm/stock, all of this portion is normal, and everything after URL could be replaced with our own URL, what we want to be requested. So the request to the website would end up being this. Instead of it being API website, it would just be hacker domain, right? We could technically give it any domain because it's requesting a domain name. HTTP right here implies that this piece is another domain name that is being requested by the website. So we could just replace that with our own malicious domain. The website request itself will end up not working because that's not what is actually being submitted. We're submitting our own URL, right? So it would just go to our server. Instead of going to the API website server, it would go to our server, and then it would pull whatever the data is from hacker domain THM instead of pulling it from the API of the website. So it no longer actually will even connect to the API website server, the normal standard server, like the healthy server. It will go to our malicious server and pull whatever data may be sitting on that specific domain and then process it for us. That's kind of where the vulnerability lies. So using what we've learned so far, what we're just going to try to do is replace essentially this last portion right here, right? Because this is where the query, the parameter of the query technically starts. So we can change this last portion to read this portion. And I'm going to try to copy and paste this just to save us a little bit of time. And if it works, then what it will do is it'll pull that flag, the flag ID number 9 for us. Okay, there you go. The paste worked. All I did was I just replaced anything that came after the equal sign for the server. I replaced it with this domain that we have here. If we press enter, it says 404 ID not found. Okay, so let's see, maybe there's something else that I need to do. Okay, so the only changes that I really made in order to make this work is I first removed the HTTPS portion of this, and then I added those 3 characters, the ampersand x equals at the end of the query that we can see right here. So the server website, all of that, all of this pretty much stayed the same. The only thing was removed was this piece right here, and then I did the ampersand x9 or the ampersand x equals. I'm curious if it'll work if I still did the HTTPS. No, that part won't work. So we definitely have to do that part. And I'm curious if it will work if we don't do this at the end and it still doesn't work. So it's definitely a requirement to do both of those things. So you have to remove the HTTPS from the beginning, and then you do the ampersand x equals at the end. The rest of it stays exactly the same. So you just put server.website, etc. Put that, and then we will be able to get the flag it's here, which is the SSRF master, which we're definitely not. I am definitely not an SSRF master, but you know, they're stroking our ego for us just to make us feel a little bit better about our exercise. So that is the answer to the question, what's the flag from SSRF? That is the answer. So now we can move on to the various ways that we can find an SSRF vulnerability potentially. These types of vulnerabilities can be found in web applications in a lot of different ways, and these are the 4 common places that we can potentially look. So when you see a full URL that's used in a parameter in the address bar, that could be an indicator. So we just went through that exercise, right? Server equals the server website store, this piece right here. Everything after the server equals, and you see a URL that's inside of it, that's an indicator that you could potentially replace that with your own. Now, in this case, notice that this is an HTTP and it's not HTTPS. That part is very important because when we tried the HTTPS in the previous exercise, it didn't work. Now, I don't know if it's like that was a very, very controlled exercise that they were looking exactly for the value that we put in the URL. Maybe it does work in real life. I haven't tried server-side request forgery exercises too many times. I think this is actually one of my weakest areas, and it would be something that I would definitely be more interested in exploring and learning and practicing. So this is personally very interesting to me, and I would love to learn more about it myself. But what we saw, just assuming that it is a requirement for it to either be HTTP or to just remove this intro part because HTTPS may not work. That's kind of my current conclusion right now. Another one would be that there's a hidden field in a form. So if you look at the HTML or XML source code of a page, this is what it looks like, right? So this is what a form looks like that can be input. You can see that it's a post request that's being sent to the website, meaning we're sending data to the website, and the data that we're sending is the values that go inside of these fields right here. So your name is being printed onto the screen, and then there's an input field for name, and then we would put our name, and it would be stored inside of the client name variable. And then your email will give us an input field right here where there is a client email variable that will store our email address. And then if we want to send a message, this looks like it's like a ticket form that is being submitted to a website. So this is essentially, these are all of the things that we would see. Now, what we don't see is this piece right here. There's a hidden field where it says the server name or the server value itself has this that's being submitted with the form. Anytime that this form is submitted, it's being submitted to the server website store portion of this website, and all of this data is being submitted to this specific server inside of this form, right? So if you see a hidden field, that implies that you could potentially take advantage of that vulnerability. If there's a partial URL, like the host name itself, so we have website HTML form equals server API. That could be just the host name that is being sent, but it's a partial URL technically, because you see the URL itself, and then you have there's a server equals API. This just implies that we're submitting. I should have just left it. This implies that we are submitting a request to get access to the API of this server here, and perhaps only the path of the URL itself. So you can see form DST typically is destination, is where it's going, and then now it's going to the path, which is /forms folder. Inside of that, it's going to the contact, and so this is something that would also be housed on the web server. So these are all requests that are being sent to a server. It's just in different ways. This one is literally the link to these servers inside of the URL. This one is inside of a form on the page, and you can see that there's a hidden portion. So this element right here isn't going to be displayed on the screen when you're looking at it in regular view, not looking at source code, right? So when you see this right here, it's like, oh, okay, so that's probably what's going on. They're making a request to this server right here. This is another version of this. It's just a shortened or a partial URL, and we can see that it's being sent to the API server. And then there's the path of the URL that we can see is being fed into the destination variable, the destination parameter, and the argument is the /forms and contact. So these are easier to exploit. Some of them, I should say, are easier to exploit than other, and this is where a lot of the trial and error will be required to find a working payload. If working with blind SSRF, where no output is reflected, you will need to use an external HTTP logging tool to monitor requests like requestbin.com, your own HTTP server, or Burp Suite's collaborated client, which is very, very handy. Burp Suite is another one of these tools that you're going to end up seeing used very frequently, especially as we go through more and more pen testing exercises. There are many videos on this channel already that talk about Burp Suite, so this is all just very, very interesting stuff. Based on the simple observation, which of the following URLs is most likely to be vulnerable to SSRF? So this is basically the only question that we have right here. So out of these right here, which one do you think is the most vulnerable? So this one is a website, and it's just going to the index.php page, which is typically just the home page of a site. Anything that you can see with index, index.html, index.php, this typically implies that you're just going to land on the home page of the site. Website.thm, list products.php, and then you're asking for the category ID of 5325. Most likely not, because it doesn't seem like it's asking for anything from a specific server location. This one, HTTPS website, fetch file.php, and then there's a file name that's being sent, and it's a PDF, and the server is filestorage.cloud.thm, and port is 8001. So this is actually making a request from a server right here. We're going to filestorage.cloud.thm on port 8001, and we're trying to pull this specific file name from that location. And then we have website.thm, buy an item, item ID, price, etc. So this doesn't seem like one. This doesn't seem like one, and this doesn't seem like one. The one that actually looks like it's submitting a request to a server is option number 3, which is the correct answer. All right. Defeating the common SSRF defenses. More security-savvy developers aware of the risk of these vulnerabilities may implement checks in their applications to make sure that the requested resource meets specific rules. So this is where the configuration of the actual server itself will come in handy as far as defensive tactics are concerned, right? So if you're trying to take advantage of a server, if the security developer or the developer, right, was actually security savvy, they'll put in some checks, right? They'll put in some protocols in place to make sure you can't do request forgery. There are usually 2 approaches to this, either a deny list or an allow list, basically denying a certain list of requests or only allowing a certain list of requests. And that's basically what it is, right? It's like a deny list is where all the requests that are accepted apart from the resources that are specified in this list or matching a specific pattern. So you can allow anything except the stuff that's on this deny list. The web application may employ a deny list to protect sensitive endpoints, IP addresses, domains from being accessed by public while still allowing access to other locations. A specific endpoint to restrict access to is the local host, which may contain server performance data or further sensitive information. So domain names like localhost and 127.0.0.1, which is the standard IP address that belongs to the local host on every single computer. There has not been a single computer that I have done ifconfig or ipconfig on where the loopback address or the local host address was not 127.0.0.1. That's basically the IP address for the loopback or the local host. And it would appear on a deny list, right? So these things, the local host name and this specific IP address would be on the deny list so that if we wanted to access them, we shouldn't be able to access them. Now we can bypass a deny list by using alternative local host references, for example, 0 by itself, or 0.0.0.0, or quad 0, or 127.1, or 127.*****. There's also this piece right here, which I think is just kind of one of those general addresses that I've never seen before, so I haven't memorized this one. This is another one. Or any kind of subdomain that has a DNS record which resolves to the IP address of the local host, such as 001 nip.io, right? So in a cloud environment, it would be beneficial to block addresses to the IP address, this specific IP, which contains metadata for deployed cloud server, including possibly sensitive information. An attacker can bypass this by registering a subdomain on their own domain with a DNS record that points to that specific IP address. So these are very, very interesting ways that we can bypass these things, right? So unless the actual developer has blacklisted this, all of these, right? Or these IP addresses like this specific piece right here, unless all of those have been blacklisted, you could technically use those to bypass that initial portion of the deny list that wouldn't give you access to localhost and 127.0.0.1. And in a cloud environment, if we have this specific IP, which we can actually even Google this, right? So let's go and let's see. I don't want to do that. So let's look this up. I wonder if it's going to look it up in my computer or if it'll look it up online. Nope, it's not looking it up online. It's going to probably do a lookup on my actual computer, which is not what I'm trying to do here. I'm trying to see what it would look like if we searched for this. So if we go ahead and type it into the browser, it should just be blocked because it's now trying to go into that address. So we're definitely not going to get that request completed. If I put it in inside of Google and try to do a Google search, so let's stop this altogether. Let's actually go to google.com and then submit it as a request to google.com and see what happens. So it says, what is this IP address? And it's used in AWS, Azure, GCP, and other cloud computing to host instance metadata services. So this is actually an IP address that's a default IP address that's used in Amazon, Azure, Google Cloud, and other cloud computing platforms to host the metadata of an instance. So when you have an instance that's being launched in a cloud environment, that's basically launching, let's say, a Linux machine or launching a Windows machine. It hosts the metadata of those various instances, which are all connected to potential virtual machines or Dockers or anything like this that's being released. So in the context of AWS, for example, this IP is used as the endpoint for the instance metadata service, and the EC2 metadata service provides a way for EC2 instances to retrieve instance-specific information and configuration details. So if we can access that for a given website, then what will happen is that we will get configuration details for that virtual machine or for that instance, right? So it's very interesting to actually know about these default values. And there's all of these default values, and then there's just this IP address that, if you had not gone through this video, you probably would not have guessed that there's something like this that exists, right? So one of the things that are available through videos like this one are that you can find what to search for. A lot of times, you know that you have a certain goal, but you don't know where to start the search. And so in this particular case, if your goal is to find information about cloud environment instances, this is where the search would start, would be at this specific IP address, because it literally applies to Google Cloud, Amazon, Microsoft Azure, all that stuff. So all of that was the deny list, right? The allow list is where all the requests get denied, so everything gets denied unless they are actually on the allow list or they match a particular pattern, like a rule that a URL used in a parameter must begin with https website.thm. If it doesn't start with this, then it's not allowed, right? It's everything else is denied. So an attacker could quickly circumvent this by creating a subdomain on an attacker's subdomain name, so on their own domain name, such as website.thm.attackersdomain.thm, right? So if it starts with this, if that's the rule, and we figured out that that's one of the rules that we have because we looked at the configuration for the instance, you see what I'm saying? So once you figure out the configuration rules, you're like, oh, you know what? As long as I have something that's registered on my own computer, or excuse me, on my own website that has this as a subdomain, it's the website.thm, and then there's the .attackersdomain. So as long as it starts with this, then I should be able to get access. And technically you should, right? The application logic will now allow you, or allow that specific input, and let you control the internal HTTP request. There's something known as an open redirect. So if the above bypasses, the stuff that we just talked about, don't work, there's another trick that we can do. And the open redirect is an endpoint on the server where the website visitor gets automatically redirected to another website address. So for example, if we go to this, right, this piece right here, this endpoint was created to record the number of times visitors have clicked on this link for advertising marketing purposes. But imagine there was a potential vulnerability with stringent rules which only allowed URLs beginning with this, right? Then you could utilize the above feature to redirect the internal HTTP request to a domain of the attacker's choice, which is basically what we just talked about in the previous one. So if this is the rule right here, so it says anything that is done through this will go to this specific endpoint to record the number of times that visitors have actually clicked on this. And the potential vulnerability is because of the rule that says that only the allowed URLs that begin with this portion are allowed to be submitted. So again, we can go ahead and just add that as one of our subdomains, and then we'll be able to pull off the rest of it. So as long as this is included in our subdomain, everything after that could technically be our own stuff, and we should be able to get past it because this was just one of the rules that were submitted to the configuration of the server as an open redirect, because they just want to track how many times a click is being sent to this specific URL, for example. So what method can be used to bypass strict rules? That would be the open redirect. What IP address may contain sensitive data in cloud environments? That was the 169 address that we found. What type of list is used to permit only certain input? So that would be the allow list, which forces you to deny everything else. And what type is used to stop certain input? And that would be the deny list, which then allows everything else, right? So those are the types of request forgery mitigation tactics that we can actually go through defeating the various SSRF defenses. So all of that being said, let's actually do a practical exercise here. Okay, so here is the scenario. We have two endpoints during a content discovery exercise against the Acme IT support website. The first one is /private, which gives us an error message explaining that the contents cannot be viewed from our IP. The second is a new version of the customer account page at customers new account page with a new feature allowing customers to choose an avatar for their account. By clicking start machine, I've already done that. It'll launch that, and then we'll be able to get access to this. The IP address portion of this changes every time you do start machine. I've also launched the attack box so that we can use the internal connection between the attack box and this IP to actually open it in our browser. If you don't want to use the attack box, you can always connect to the TryHackMe server via OpenVPN and then just use your own computer, and then you'll be able to load this. If you do this outside of that, outside of your own, or outside of the attack box without connecting to the TryHackMe server via OpenVPN, it won't load. So this is what Oh, actually loaded. Oh my God. So maybe I guess it's because I'm already connected via attack box. Maybe that's why it's working. That's so odd. I didn't think that it would even load. Oh my gosh, that's crazy. All right. So then follow the instructions. I'm legit shocked. Like I'm shook right now that this actually loaded. That's so funny. Maybe I didn't even need to open the attack box. Maybe it would just work without the attack box. I guess, whatever. First, create a customer account and sign in. Once you've signed in, visit this specific location to view the new avatar selection feature. By viewing the page source of the avatar form, you'll see the avatar form field value contains the path to the image, and the background image style can confirm this in the div element. So if we actually go look at the source code, we'll see under the class for avatar image that there's background image, and then there's a URL assets avatar 1 PNG. So if you choose the avatar and then click update avatar, you'll see the form change, and above it displays your current avatar. So for example, if we change it, it should change it to something else, right? Background image, URL, data image, PNG, base64, etc. So viewing the source will show us that it's actually being displayed using the data scheme, and it's data scheme, excuse me, and it's base64 encoded, which is what we see right here. So let's try making the request again by changing the avatar value to private in hopes that the server will access the resource and get past the IP to block. To do this, firstly, right-click on one of the radio buttons from the avatar and then click inspect. So if we just look at the actual button itself and inspect it, then edit the value of the radio button to private. So this piece, the radio, just change the value to private. Be sure to select the avatar you edited and then click the update avatar button. Unfortunately, it looks like the web application has a deny list in place and has blocked access to the private endpoint. Okay, so as we can see from the error message, the path cannot start with private, but don't worry, we've still got a trick up our sleeve. So we can use a directory traversal trick to reach it. Try setting the avatar value to x/./private. So this is the traversal portion that comes in. Now we'll see that have bypassed the rule, and the rule updated the avatar. This trick works because receiving the request for this, it knows that this piece means to move up a directory and translate it. So as long as it doesn't start with /private, I think that's the rule that was in place. If it starts with /private, it won't work. But technically now it starts with X, and then we've done a directory traversal, and now we're going to private, which will, this is pretty much the equivalent of just saying that we want to start with private, but the query itself doesn't start with private, and so that bypasses the rule. Viewing this, you'll see the currently set avatar now contains the contents from the private directory in base64 encoding, and then you can decode it to find the red flag. So first things first, I want to actually use the attack box that we have anyway, so I'm just going to do show split view, which is going to be really insane. So I'm going to click this view full screen just so it opens it up in full screen for me, and I'll be able to look at the actual screen. Then we are going to open up the browser, and then we're going to navigate to that IP address that they gave us, or that path, which is this whole piece right here. So we're just going to copy this, and we're going to go in our browser, and we're going to paste it, press enter, and we are going to go to customers first and sign up, and then we're going to create a customer profile. So it'll just be Hank, and then is it going to type? There we go. hank@thm.com. None of this needs to be real because, I mean, it doesn't, which is odd to think about, but it'll create it for you no matter what, and you'll be fine. So now we're here. So, okay, so we're here. So what it's telling us to do is to go to the portion for customers new account page to view the avatar selection feature. Okay, that's where we need to go. So customers is where we're here, and I think it might work if I went to your account. I think that might take me there. If it doesn't, then we can just manually go there. Yeah, so this just takes me to my actual account itself, but there is the new account page. So new, what is it? New dash account dash page. All right, so here are the avatars. So now it's saying, if I click this guy right here, so let's zoom in a little bit for you just so you can see what's up. If I click this guy right here and I right click on the actual button, right, and I inspect the button, we can see that there is this value right here, right? So the value is assets, avatar, PNG. So just to display what they did, right? If we just go to /private, press enter, and then do what, a refresh, I guess, it should say, no, it doesn't do it. So what does it say? So it says if we go over here and we do click update avatar, you'll see the form change, and above it we'll have that, and then this is what's going to happen. So if I go to that and then do update avatar, so that's what I got to do, is I got to go here, I got to right click on this guy, go to inspect, it'll bring it up over here, and then I'm going to change this value to /private, and then I'm going to click update avatar. That's what's going to say. So URL cannot start with private. So there it is. So now we know we can not do that. So what we can do again, we'll click on this guy, and then we will go ahead again and do right click, inspect, and it'll take us to that specific one. And we'll have here, we're going to do x / private, and press enter here. Then we're going to click update. And so now it says avatar was updated. Okay, so now we need to just look at the page source and then look for the current avatar portion. So it's basically this piece right here. So I'm just going to highlight that, do inspect, and it'll take me here. And so now we have the current avatar background image, URL data, base64, and then there's this base64 encoded portion right here that I should be able to, I'm just going to do this. I'm going to copy this whole thing, and we're just going to go to CyberChef and modify it inside of CyberChef. So we're going to do this. I think it's going to paste that whole piece. And what I'm interested in is removing all of this, right? And then removing that last parentheses at the end as well, like so. And then we'll just click on this magic wand, and there you go. THM, you worked out the SSRF. So fairly simple exercise, okay? Just to kind of, because they gave us pretty much everything that we needed to do. So just so you can see what's up, right? So essentially, if I click on this one right here, and then I go update avatar, it'll change it. Now here's my current avatar. And now we can see that the current avatar actually has a picture here, right? So this is me without doing any kind of modification to the source code. This is what it would actually display. So if we right click on this, click on inspect, it'll take us to that portion, and we can see that it's, you know, image, base64, etc. So I can literally just take this, very similar to what we had previously, and you see like this giant portion of text right here. And we can copy this, go over here, and go to the CyberChef and paste it. And then if we remove that first portion of this, which is the base64 element, all of that, remove that first, come to the very, very end of it, and remove this parentheses, it should give me something, but it gives me absolutely nothing. So it tells me that pretty much most of this is jargon, or it's garbage. So if I look for the double equal sign on this page, let's see if I can do that. So if we do Control F, do a double equal sign, and then see if we can find it, there is no double equal sign. So it seems to be that it doesn't even exist in this particular case. So if I do a single equal sign maybe, so let's see if we can find a single equal sign in all of this, and it doesn't exist in all of this. So this whole thing implies to me that all of this right here is just like a really complicated placeholder to let us know that this is just BS, right? So then it's kind of irrelevant at this point. The key element was, if we click on this guy, right click on the actual button, go to inspect, we'll see that the value of it, and based on the types of request forgery, we saw that the value right here was assets avatar 3 PNG, which is a path that we can see right here. So we can actually change this, right? So we're doing a combination of two exercises here. We're going to do the changing for SSRF, but we're also combining it with the path traversal, which is where that x / ... and then we're going to go to private. Now this piece right here is the piece that, like, they've done the homework for us. They know that there's a private page, and all of those things. And so all we need to do is just try to find a way to access that private page. And this is, now we can see that the current avatar is actually blank. But if I right click it, or if I just go here and I right click this and I do inspect, it'll take me to that portion. And now I can see that the avatar image has now been modified to whatever that private page's base64 was, which is much shorter than that giant thing that we saw at this piece right here. So then when we pasted that, we saw that the value itself was the flag. So I kind of like jumped the gun and I got to the answer at the end of it. But hopefully now you understand how the thought process behind this works. And to find those private pages, you would just do one of the scans that we normally would do when we go through reconnaissance, and you can use Nikto for that. You can use GoBuster for that. There are a lot of different ways that you can find these various directories that would be available. For example, the directory that we have here, which is the new account page, as well as the directory for /private. So both of those could just be found by doing a GoBuster scan. And then from there you find them, and then you document all of them, and then you go ahead and you analyze the web page for potential vulnerabilities that may exist, and that ends up making it kind of fun to then just now try to break into the system, which is what we were able to do quite successfully, if I may say so myself. So there's your answer. The THM, you worked out the SSRF, and we are officially done with this room. This is actually a great introduction to server-side request forgery. If you've never done anything like this before, hopefully this was easy enough to wrap your head around, and hopefully you got a chance to actually practice it because you were inside of TryHackMe. Now, if you weren't, I totally understand. You can try to follow along. I try to over-explain. One of our guys, one of our members of Hackaholics Anonymous, he's like, look, over-explaining is actually not a bad thing, and it helps people understand these things better. So I hope that when I go into these deep explanations, it actually helps you and doesn't hinder you. And if you're really sharp, if you're one of those viewers that is really, really good at retaining information and you're very good at understanding these things, then you can skip past most of that stuff. But I do it for people that are not from cybersecurity. They don't have a background in tech or a background in web development or anything like that. So just to make it a little bit easier for them to understand what's going on. And especially if you don't have access to TryHackMe as a paid member, then I kind of have to over-explain just so you understand what just happened, what we went through and what we did. Because just to go through the exercises willy-nilly and try to get you the answer to the final question, it is more useful for the people that actually have access to TryHackMe and they're trying to complete the room. But if you're just trying to learn what it means to do server-side request forgery, I feel like I do need to over-explain. But anyways, in any case, we got a chance to understand what it actually means to do a server-side request forgery. We looked at the various ways that we can find those types of request vulnerabilities, and we even were able to launch it against an actual website to see what we can do and manipulate. And of course, the defenses that would be in place, we kind of found out how to get around them, which is what this very last exercise was. So hopefully it was actually valuable to you. Hopefully you learned something from it. And yeah, that's pretty much it. If you did get value out of this video and you want to get more videos like this one, I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And I've gotten some comments from people that they're like, I don't get notified when new videos come out. That's because you didn't turn on that notification bell. I think it's like, it would be like right down here. It's like right under the video. And if you turn it on, then you will actually get notified the next time that a video comes out. But then just keep in mind, I post videos pretty much once a day throughout the work week. So Monday through Friday, there's always going to be at least one video that's going to get posted. So if you don't check your YouTube frequently, you're going to get a bunch of stuff. After like 2 weeks, you'll probably get 10 videos that are updated. So just keep that portion of it in mind, but you can always just make sure you subscribe to the channel, and then the new videos will pop up in your feed. So there are a few different ways that you can be notified of this. And then there are some people that also just drop comments inside the comment sections of the timestamp that they were at, so that when they come back, they can just pick up from where they left off, because a lot of the longer videos, some of the videos on here are like 4, 5, 6 hours long. So a lot of those videos, it's kind of important to just pick up where you left off so you don't have to click back and forth. I put timestamps in every single one of the videos to make it easier for you to navigate the video and find a specific part that's most interesting to you or applies to you, or you can go to that part and then pick up from where you left off. So hopefully it makes it a little bit user friendly and you can get access to the information that you need. There's a bunch of videos already on the channel. There are going to be more videos coming out. The current big playlist that I'm working on, there are two big ones. This Junior PenTester is one, and then we have the CompTIA Pentest Plus that drops every Friday. There's a new episode that drops every Friday, and hopefully within, let's say, a month or so, I'll be done completely with that, because I'm going to do like a big bulk recording of everything for that, so we can get all of that done for you. And then the most important piece that's going to be coming up is just the integration between AI and all of these various tools. And I have to do all of these foundational pieces so that you understand what's going on, so that when we go into the advanced stuff like AI integrations with cybersecurity tools, those things you can actually really wrap your head around. Because if you don't know the basics, those things are going to be impossible to understand, and I'm going to get a bunch of comments from people asking me to explain the basics to them. So I have to do the basics to make sure that you have access to the basics, and hopefully you'll actually go through them and learn them so that everything else will start making sense for you as well. So drop a comment if you have any questions about the video that we did today. If not, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And a quick word from our sponsor and we'll be done. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the comment section, and if not, I hope I see you in the Discord chats. And that's it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. In episode 13 of the Junior PenTester training series, we go through the introduction of the cross-site scripting vulnerability and attack combination. And cross-site scripting has to do with the scripts that are embedded into the contents of a web page, and how you would go ahead then manipulate the various elements of a web page to do something that you would want it to do. And this would be a client-side attack. In the last video, we did server-side request forgery. That was a server-side attack. So this is something that happens through your web browser, and ideally it would submit obviously the request to the web server for it to process, and it requires both of those things to be misconfigured. So the client side as well as the server side both need to be misconfigured in order for this to work, and we're going to go through what that actually is and what you can do with that. There's the brief of the room, what XSS payloads are. There's something called reflected XSS, stored XSS, and then DOM-based XSS, and we'll go through all of those. And then there's something also called blind XSS that, as the name kind of implies, you don't get to see the responses from the web page, and you kind of have to try to find other ways to track whether or not your attack was successful. And then, of course, the various practical exercises that we have at the end of this, which is perfecting the payload that we have, and practical example for blind XSS. So these two actually have two completely separate virtual machines that we're going to end up using and attacking, and hopefully successfully manipulating and getting some results from them. And that'll be it for this specific video. Created through TryHackMe. We don't get the name of the developers for this room, although I know there was at some point there was a human being that sat down and did this, but sometimes they do give us the names of the developers, sometimes they don't. So just a shout out to TryHackMe. This is a subscriber-only room, so it means you do need a paid subscription in order to be able to access the virtual machines. But for the content, you can, I mean, it's all free for you because I'm going to go through it right now. I get nothing from TryHackMe to promote them, but I think they're a really, really amazing platform, and a lot of universities use them because it gives you a controlled environment to run hacking exercises, and you won't get into any kind of trouble. So you get attack boxes, you get virtual machines that will be your targets and your victim machines, so on and so forth. Really, really great platform. So if you don't have a membership, I encourage you to check it out. If not, you can get a free membership. They have, I think, 300 or 400 rooms that are available for free through just a basic membership, and you can go ahead and get access to that as well. And even those rooms have virtual machines and attack boxes that you can use. So that being said, a quick word from our sponsor, Hackaholics Anonymous, and then we're going to dive into it. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the introduction to cross-site scripting. As a quick heads up, since we're going to be talking about scripting, cross-site scripting, right? So it's all based on JavaScript. So it would be useful if you knew what JavaScript was, or at least had a basic understanding of that language. We are going to go through some examples of it, and I'll do my best to explain it so that if you don't have a background in JavaScript, you'll still understand what's going on. And there's also going to be client-server requests that we're going to be submitting, so understanding what that means, what requests in general mean, and what responses mean, and what types of responses we can expect based on the requests that we submit. It's a very basic understanding of just HTTP and web application interactions and website interactions, all of those things, super, super basic understanding. So ideally, it would be useful for you to have an understanding of both of those concepts, which is JavaScript as well as client-server requests and responses. Cross-site scripting, also known as XSS in the CySec community, is classified as an injection attack, where malicious JavaScript gets injected into a web application with the intention of being executed by other users. And in this room, we're going to learn about these different types of attacks, how to actually create the payloads, how to modify the payloads to evade filters, and of course end up with a practical lab where we can try it out and see what we can get done. These vulnerabilities are extremely common. There are a few reports of these things found in massive applications, and we can get paid very well to find them. So one of the big things in the CySec community and the pen testing community is called a bug bounty. And I've done just a few shorts on YouTube just to kind of demonstrate what some of the biggest bug bounties in the world will pay you. But Apple has a $2 million bug bounty program where if you can actually find some bugs in their applications or in their services, you'll get paid really, really big money. But then there's a bunch of different websites, for example, Shopify or Steam Chat or HackerOne, and all of these things that actually pay you real good money. HackerOne is a marketplace for different companies to come to and hire individual contractors like freelance hackers, and then you'll get paid to go ahead and hack into these different companies and try to find whatever their vulnerabilities are. So in this example, they found a stored XSS vulnerability via the assets, but it's been blocked by the CSP. So an asset like this right here, go to the program, etc., 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 was the first step, right? And then the next one was to go to the created program, then create the asset, submit a report. Whenever the asset is rendering, the XSS is firing, and open the submitted report, and it's still going to be firing, and then click edit, and it's still be firing. The impact would be that it's executing for anybody and everybody that would be using it, and this was one of those things that ended up paying this particular person, right? I think, what was the dollar amount? It said $2,500 to find that specific vulnerability. And it's not 2 million that you would get paid from Apple, but 2,500 is not a bad chunk of money. Or getting $7,500 for something that was found in Steam chat, which is another one of those things that was through HackerOne. So HackerOne is one of these locations where it's a marketplace. It's a giant marketplace of companies, for example, Tinder or Dynatrace or InDrive or a bunch of companies that are available that are looking for people to hack them, and you can get paid anywhere from $1,000 to $100,000. So these are not small bug bounties. There are some small ones, right? So this is like a $50 one. This is a $99 one. So there are some small bug bounties, but you can get paid to practice your hacking skills. That's kind of the concept here, right? So if you just want to practice and you want a real environment to practice without getting penalized or without getting any kind of a issue, you can always come to HackerOne, choose Wells Fargo, for example, read through the rules for their the bug bounty program that they have, and then from there you can implement various attacks to see if you can get past some of their defenses or find any glitches in their systems, and then they'll pay you. So this is probably the best way that I can have anybody who's interested in becoming a hacker practice their skills without getting into any kind of trouble. And that would be to actually go to a place that they'll pay you to do it. So that is that for the introduction. So what does XSS stand for? It stands for cross-site scripting. So let's talk about the various payloads. A payload is the JavaScript code that we want to be executed on the actual target's computer. So there are two parts to this. There's the intention of the payload and the modification of the payload. The intention is what you want the JavaScript to actually do, and we're going to talk about it in future pieces in this video. The modification is the changes to the code that we have to make to execute every scenario, because every scenario is different, right? So again, we're going to be talking about that in a little bit. So these are some examples, right? So this is the simplest that can actually happen. And it basically is going to pop up a box. It's like a little pop-up box that comes up on the screen that just says alert. That's basically it. It's just like a little script that executes, and the pop-up, it doesn't say alert. It's an alert pop-up, and then it'll say XSS on the screen. That would be what's going to be inside of the alert pop-up box, right? This is just a proof of concept to see whether or not the website is actually even vulnerable to an XSS attack, right? So this would be like the very first thing. It doesn't do anything malicious. It's just a pop-up that comes onto the screen. It reads XSS, and if you see it and if it executes successfully, that means that the specific part of that website is vulnerable to these types of attacks. Session stealing is one of the really big ones. So if you want to get the login tokens, for example, of a website's or of a user's session on a website, these things are kept in cookies on their machine. So it would be on the user's machine inside of their web browser. So this specific script right here takes the target's cookie, it base64 encodes the cookie to ensure that we can actually transmit it across to us, and then post it to a website that is controlled by the hacker. And once that has the hacker actually has these cookies, they can take over the target session and be logged in as that person. And this is all done through this it's a relatively simple script, right? So it'll fetch from the hacker steal cookie. So this is what it's going to fetch, this specific piece right here. And then it's going to take the document cookie, which is from the person, and it's going to ideally transfer it. We can also just go ahead and get like a real detailed explanation of this instead of me butchering the explanation of this. So let's see what we can get from our favorite Google AI right here. So it says this is a simple script that attempts to steal cookies from a user's browser. Script and script are the beginning and end of this. The fetch portion is a modern JavaScript API used for making network requests like fetching resources. This specific portion is the base URL to which the stolen cookie will be sent, And so it just tells it to us right here. It just breaks it for us, right? So this is the root, the domain controlled by the attacker. The steal is the path on the attacker server, like a script or something. And then the cookie parameter is the following data will be a query parameter named cookie. And then we concatenate it, that plus sign that you see at the end right here. Where is it? This piece right here. So this piece, this whole piece is combined, concatenated, meaning this piece right here will be added to the end of this, right? So the cookie is going to equal whatever the value of this is going to end up being. And so that gets concatenated to this. Now, the document cookie is the property that accesses all the cookies that belong to a current domain that the user is visiting. And these are typically used for session management, user preferences, etc. The BTOA part is a function that encodes a string in base 64. And it's often used to make binary data, safe for transmission, etc. That's it, right? So very, very simple, right? So how this works is that if there's a vulnerable website that actually has this kind of a vulnerability, they can inject this specific JavaScript into a page on this website, right? This element, this script tag going into example.com through some kind of a field that would allow us to do it, like a comment field or a profile page or anything that actually has an input, and that input was not sanitized. So we have to input it somewhere. And so when you inject this into something, it could literally be something that would be injected into here, into Gemini right here, right? This is technically an input field, this piece at the bottom of the screen right here. But when I did it, Gemini actually read it, and instead of fetching my cookies on this website, it starts giving me an explanation. So you know that there's like a really advanced filtering and sanitization process on Google Gemini, but technically any portion of a website that you can print something or type something into, it's technically a location that you can submit some kind of JavaScript code, and then based on what its functions are, it would do it for you. So this specific one steals session cookies. This one right here is a key logger. So it acts as a key logger. It means that anything you type on the web page will be forwarded to a website under the hacker's control. So this will capture your usernames and your passwords or any kind of commands or things like that. So if you want to be installed on the acceptor user login or credit card details, things like that, that could actually be captured. So document on key press. This is one of these JavaScript functions that are available, and then it's going to execute and then of course fetch this piece, and then it's going to concatenate it with a base 64 encoding of whatever that key is, and that'll be sent to whatever that website is, the hacker's website right here, right? Business logic. So this is a lot more specific than everything else, and it would be about calling a particular network resource or JavaScript function. So imagine a function for changing the user's email address that's called user change email, and your payload would do that. So it would say user change email, and then it would change it to the attacker's email. But this specific piece right here is calling on a function that already exists in JavaScript that we're now calling upon, and that function does a bunch of other things in the background. So it looks really simple right here because this is what it's supposed to kind of look like. You wouldn't type up the whole function's code. You would just reference the function and then say change it to this specific value, and this function is going to work in the background, and it's going to do what it needs to do to change the email of that current user to the email address of the hacker. And then the hacker would then presumably be able to log into the guy's, let's say, bank account by using his own email, or he could change the user's password by using his own email. And then once he's changed the password and it's his own email, it's really crazy when you really think about it. So it's very, very powerful stuff. These things are very, very powerful tactics, and they're not things that don't exist in the world anymore. None of these things that we're talking about are expired and don't exist. These things actually really do exist, and you can actually use them. You would just have to go through the motions to be able to find them. And a great playing ground for that would be a place like HackerOne, and finding any of those vendors and then just kind of running through these exercises. So which document property could contain the user's session token, and that would be the document cookie property, which JavaScript method is often used as a proof of concept, and that is the alert that we just saw at the very, very beginning. So Now that we have that, let's talk about the different types of XSS vulnerabilities or attacks that we could execute. Reflected XSS happens when user supplied data in an HTTP request is included in the web page source without any validation. Okay, so here's the example. A website, if you enter incorrect input, an error message is displayed. So the content of the error message gets taken from the error parameter in the query string, and it's built directly into the page source. So this would be the query string that we see right here, and you have the error parameter invalid output detected. Okay, and if you look at the source code, you can see that there's an alert that says invalid input detected, right? So this would be something that is displayed to us if we do incorrect input, right? The application doesn't check the content of the error parameter, which allows us to insert malicious code. So we can then go and put whatever script right after the error portion of this URL, or input it inside of the actual source code for the value that we saw previously right here, right? Inside of the paragraph, you see that it's just basic text, right? Invalid input detected. You would just go ahead inside of that paragraph that opens with this P and closes with this /P, you put your script. So everything that starts with the script and ends with the script, that's basically it, right? And then you just go ahead and put your evil.javascript location, and then it would just launch it ideally. So the vulnerability can be used as per the scenario that's displayed to us here. So this is the full scenario here. So first, as the attacker, we send a link to the victim that contains a malicious payload. So this one's more zoomed in so we can look at this here. So we send a link to the victim that contains a malicious payload. Now, the victim clicks the link and is taken to a vulnerable website. And this is what we would see right here. The link containing the attacker's script is then executed on that vulnerable website. So this guy right here is on the website already, right? And we've poisoned the website. We've injected the website with our stuff, with our JavaScript. So when the user clicks it, the vulnerable website is now executed on that, or the script is executed on the vulnerable website. And when it's executed, it goes back to the victim, and whatever the data that the attacker's script is gathering is actually sent to the attacker. They could steal the victim's cookie, which would allow us to take over the victim's account or anything like that, right? So it's not complicated as far as the flow of the process is concerned. It just requires this piece. This piece is very, very important. The vulnerable website is where all of this kind of is combined and integrated together. If the website is vulnerable, we can inject it with our malicious code. And then if this guy goes over here and just clicks on one of those things, that's like a normal thing for him to want to use, what's going to happen is that it's going to execute on the website, and then by executing, we get whatever the goal was that we wanted it to get. So the attacker could send links or embed them into an iframe or another website containing a JavaScript payload to potential victims, getting them to execute code on their browser, potentially revealing session or customer information. So how to test for reflected XSS, which was actually one of the vulnerabilities that we saw at the very beginning that somebody had exploited on HackerOne, and they got paid $2,500 for it. You have to test every possible point of entry. So it could be parameters in the URL query string, the URL file path, HTTP headers, although it's unlikely, or just modifying the source code as you just saw previously. Once you found some of the data, which is being reflected in the application, the web app, you'll then need to confirm that you can successfully run the JavaScript payload, and the payload will be dependent on where in the application your code is reflected, and we're going to talk about this in a little bit. So where in a URL is a good place to test for XSS on reflected stuff? And that would be in the parameter. And again, the parameter is everything that starts after this equal sign. So you see, or actually after the question mark. When you see a question mark, the first piece that you see is the parameter. And after the equal is the argument for the parameter. Now, the specific argument previously was invalid input detected. So the parameter is error equals, and then the argument for that parameter is invalid input detected, okay? Everything after the question mark is what you are interested in looking at when it comes down to URLs specifically. So you find the question mark inside the URL, and then everything after that question mark is what you would want to pay attention to. And then after the equal sign is where you want to start injecting things, right? So error parameter equals, and then after the equal sign is where we want to start injecting things. And then you can even look at the source code to see if you can just modify the source code accordingly. And that's what we did on the last video with the server-side request forgery. We actually did that, and we were able to gain some interesting access to certain parts of a website. So that is all falling under reflected XSS, everything that we just talked about so far. So let's go into stored XSS. In this particular type of XSS, the payload is stored on the web application, and it's inside of a database, for example. And then it runs when the other users visit the site or the web page. So it's stored. For example, a blog that allows users to post comments. These types of comments aren't checked for whether they contain JavaScript or filter out any malicious code. So if we now post a comment containing JavaScript, this will be stored in the comment database of that blog. And every other user now is actually visiting the article. They'll have the JavaScript run on their browser. Pretty crazy, right? So they don't even have to click on it, right? It's like the comment, as long as it loads, it'll then run, which is insane. If you really think about it, they don't even have to interact with it. They just have to visit the web page and then it'll run. Crazy to think about. So the attacker, this is the first part, right? So we insert malicious payload into the website's database by, for example, leaving a comment, and inside of that comment, there is a specific source code or there's some kind of a link that would inject the script that we want into that website. For every visit to the website, the malicious script is then activated, and then the victim is visiting the site, and as soon as it loads, it finishes loading, it actually loads on their site. The data to the attacker script gathered is sent to them, and then they could steal victim cookies, etc., and just execute on whatever their goals are for their specific attack. But very, very simple, right? It's stored on the database of the website, and then it'll just launch every time that the victim visits that specific web page, and they don't have to interact with it, they don't have to click on it. So this specific type of XSS could redirect users to another site. They could steal user session cookies, perform other actions while while acting as that specific user. So how we can test for this is every possible point of entry, very similar, where the data is stored and then shown back in areas that other users have access to. And it could be comments on a blog, it could be user profile information, it could be website listings. So developers think limiting input values on a client side is good enough for protection. So changing values to something the web application wouldn't be expecting is a good source for discovering stored XSS. For example, the age field that is expecting an integer from a drop-down menu, but instead you manually send the request rather than using the form that allows you to try a malicious input. But it's very interesting. Like it's expecting something small, so it has a drop down, but then you just manually modify that. So once you found some data which is being stored in the web application, you'll then need to confirm that you can successfully run the JavaScript payload. The payload will be dependent on where in the application your code is reflected, and we'll talk about this again in a little bit. So how are stored XSS payloads usually stored on a website? And they are inside of a database. So let's talk about DOM-based XSS. DOM stands for the Document Object Model. It's a programming interface for HTML and XML. XML is kind of just a more advanced version of HTML. It represents the page so that programs can change the document structure, style, and content. The web page, a web page specifically, is just a document, and this document can be either displayed in the browser window or as the HTML source. And this is a diagram of what this looks like. So the document itself, the root element of it is the HTML version, and then inside of the HTML version, you have the header, the title, and then the text that actually connects to it. So all of this is underneath the header. Inside of the header, there's a title. Inside of the title, there's the text, my title, or whatever the title would end up being. Inside of the body element, you have a variety of different attributes could exist, right? So the A attribute, the A element, has the href or ahref is what I call it. And this ends up being a hyperlink. This is something that we can actually click on. So the ahref is something that is pointing to a link somewhere. And then that specific link always has a text value as well. And so what you'll see on the screen is a link. So let me see if I can actually find one right here. Right here, boom, perfect. So what we see right here is w3.org. But if I actually look at this, so if I inspect this specific element, we'll see that it's actually a href. So, whoops, that's not, oh, come on, buddy. Let me make sure that I can actually zoom in here for you. There we go. So we can see that it's a href, right? So a href, and then it has the actual link, and then the text, which is w3.org. So all we see is the text, but clicking on that text will take us to this specific link. And so this is what we're looking at over here. Now, there's multiple elements that can go inside a body. There's multiple elements that can go inside the header. So this specific h1 tag is just the header, like the headline that you would see. This piece right here is, I think, like a subhead. This would probably be the header. So if we go to this and we inspect this specific piece, we'll see what kind of tag is associated with it. So where is it? It's this piece right here. So if I take this and if I expand it, we can see it's DOM based. There's no actual header or h tag or anything that's been associated with it. If we go further up, we don't see any of those things either. But we do actually see that there's a font size that's been associated with it, and that's kind of it. And then what is the DOM would be another element right here that we can go ahead and look at, and then that'll bring us over here. And this one, if we go here, let's see, font size 18, that's basically all we see right here. And then the text value itself is just what is the DOM. So there are different versions that we can do this. In this particular case, instead of just putting h1, they actually give it a font size. And so in this case, the element h1 takes whatever attributes are associated with that h1 element, which is usually font size 18, and it's in bold. That's kind of just depends on the styling sheet. I'm digressing a little bit, but you just look at it, right? This is the document. So when you look at the document has a bunch of source code. Various elements of the source code will do different things, okay? And underneath the overall HTML root element, you can have a bunch of different individual sub elements, and inside of those you can have all the other types of elements, and then they could be text, they could be links, etc., etc., etc. So if you want to learn more about this, you can actually visit this website right here, which is through W3, and it just teaches you more about this kind of stuff. And this is a very, very, as you can see, there's no styling sheet associated with it. So if you looked at any of these things, it's more useful to actually kind of, if I clicked on this and then inspected this, we could learn more about this than anything else, because we can come over here and there you go. That's the h1 tag right here. And so the h1 tag has been applied to this, so that's our header. And then this one most likely has the h2 tag, which gives us the subhead. So you see this is an h2 tag, and then it goes further down. And then if there is an h3 tag, which I don't see, so it's a bunch of h2 tags that basically fall under this one h1 tag. So this is kind of what it looks like, right? You can just look at the contents of this page just so you can see what these various HTML elements will resolve to, okay? That's all you need. Now, exploiting this specific XSS vulnerability. So this type of vulnerability is the type where JavaScript execution happens directly in the browser without any new pages being loaded or data being submitted to the backend, to the server. So execution occurs when the website JavaScript code acts on input or user interaction. So the website gets contents from the Windows location hash parameter and then writes that onto the page in the currently being viewed section. The contents of the hash aren't checked for malicious code, which allows us as the attacker to inject JavaScript into that specific portion. So crafted links could be sent to the potential victims, redirecting them to another website or stealing content from the page. So if they click on this, right, that could basically just be something that we've put maliciously, and it looks like a normal link. Right? If you want more information about, X, Y, and Z, click here, and then the person wants more information, they click it, and that specific hyperlink is going to send them somewhere that we would want it. So how we can do this, how we can test for this, can potentially be challenging because it requires you to understand JavaScript to read source code. So this is kind of one of the most challenging ones. You need to look for the parts of the code that access certain variables that an attacker can actually have control over. For example, window location X is a parameter, and you need to be able to notice these types of things that would exist inside of the JavaScript. When you found that, then you need to see how they're actually handled and whether the values are ever written to the web page's document or if they're passed to unsafe JavaScript methods, for example, eval for evaluation, right? So what unsafe method is good to look for in source code? It would be potentially eval. So to take from this whole section, the big piece that you can take is, all right, what do you want to look for to try to do this kind of attack? You want to look for eval inside of the source code. And if you can actually find that, so let's go see if we can find eval inside of the source code, which I don't think we can because I think this website is entirely HTML. But let's just look at the source code. So we're going to go, where's view source? I can just right click, do view page source, and we can look at the page source. And if we can find eval, and we can't because it doesn't exist, because even though it's a super basic page, they were not silly enough to include that kind of vulnerability inside of the web page. But that is something that you can potentially look for to pull it off. Now let's move on to blind XSS. This is the portion that was referenced multiple times throughout the contents today. Blind XSS is similar to stored, which we actually have looked at in the case that, the payload gets stored on the website for another user to view. But in this case, we can't actually see the payload working or be able to test it against ourselves first. So this is the piece right here, right? So what we did in server-side request forgery video, which was the last video, was similar. There's actually a version of it which is blind SSRF, blind server-side request forgery. And the whole thing implies that we can't see whether or not it's working. So we have to find other ways to track whether or not it's working. Now, an example would be a website has a contact form where we can message a member of the staff. The message content doesn't get checked for malicious code, which allows us to enter anything that we want. Then they get turned into support tickets, which the staff views on a private web portal. So we don't see that last part of it, right? We don't see this piece right here. We submit it and then it gets sent. And we can't tell whether or not it worked unless we have some kind of other type of tracking. So using the correct payload, we can actually make calls back to our own website, for example, which reveals the staff portal's URL, the staff member's cookies, and even the contents of the portal page that's being viewed. Now we can potentially hijack the staff member session and have access to the private portal. So how do we test for this? We test for blind vulnerabilities. You need to ensure that the payload has a callback, right? So it needs to send to your server, or your website, or some kind of a reverse shell, or some kind of a listener, something. There needs to be something in place that can track whether or not this is actually working. This way we can actually see when it's being executed. A popular tool for this is the XSS Hunter Express. And it's possible to make our own tool in JavaScript. This will automatically capture cookies, URLs, and page contents and more, which is this little tool right here, the XSS Hunter Express. And as many other tools that we have, this is actually available on GitHub. So if you go to github.com/mandatory-programmer/XSS Hunter-Express, you will be brought to this page, and then you can go ahead and download it, or you can clone the repository. Of course, there's documentation available that you can review to see how you can use it. There are screenshots available. Very, very cool tool, very, very useful tool. And it's something that you can use when you go on HackerOne and you're trying to see if you find any website or any company that wants you to check for XSS vulnerabilities. You can go ahead and use XSS Hunter to run your tests and see if you can find. So what tool can you use to do this? That would be XSS Hunter Express. And what type of XSS is similar to blind XSS? And that would be stored XSS. And that's pretty much all we got. So let's now do the exercises. So the first one is perfecting the payload exercise. So I'm going to start this machine and it's going to load while we go ahead and read the contents. I need to minimize this, so while it loads in the background, we're going to read the contents. First, we need to understand what a payload is. And the payload in this context and in very many other contexts is essentially a script, right? It's code that's going to be sent and then it needs to be executed. So in this case, it's no different. It's JavaScript code that we want to execute either on another user's browser or as a proof of concept to demonstrate that a vulnerability actually exists. So the payload could have a lot of different types of intentions. It could be to bring up an alert or to prove that we can execute JavaScript on the website by extracting information from them or from the user session. So how it gets reflected in a target's website will determine the payload that we actually get to use, right? So how it gets reflected will determine what you need to use. To explain this, we're going to actually use this virtual machine that was just launched for us. We're going to execute this specific alert with the string THM that's going to pop up, right? So very, very basic script. It's just an alert. It's going to pop up and it should read THM. If we succeed, it should read THM. So we're presented with the form on level 1. You want to enter your name. Once you've entered your name, it should be presented on a line below, for example, hello, Adam. So in this particular thing, we're just going to do the pop-up, right? That's basically it. So if you view the page source, you'll see that the name is actually reflected in the code. Instead of entering the name, we're instead going to try entering the actual payload. And then when we click the enter button, we should get the pop-up. And then if we looked at the source code, we can see that it says hello, and it has the source code in there, right? So it actually has the script inside of the source code instead of Adam, right? So this has hello Adam. So whatever value you put into it is actually going to be printed, which means it's going to be executed. So you can put the script and then it'll still say hello, whatever the script is inside of the source code, but the pop-up will actually execute on the screen and then we'll see THM executed as the pop-up. So that was one piece. The next one is similar to what we had, except now instead of it actually saying hello Adam in the source code, it's actually on the page, and now it's going to have a separate button for us, right? So we can see that here. So if we look at that, the source code, instead of saying hello Adam, it'll say hello, and then it'll say input value for Adam. Input value being the one that was collected from this, right? So the value for this input is going to be printed on this section, and the source code will read hello, and then it'll give us the input value of that previous form item. So it wouldn't work if we were going to try the previous payload because we can't run it from inside the input tag. So instead, we need to escape the input tag so that it can actually run, and we can do this by using this piece right here. So you see the quote, and then this forward thing, and then inside of the quote forward thing, you then have the script portion, right? So the quote and forward or greater than symbol, whatever, it closes the previous value parameter. So it closes this right here, right? So you see this, right? You see this, and it's the very end of this that you can see right here. So if you do that, you're now putting that into here. So it closes that input value for you. So it assumes that it has something, and then it'll move on to executing the next block of code, which will be this block of code. And so if you do this, now you can see, right? So quote opens up, right? So check it out right here, right? Input value, quote opens up. There's supposed to be some kind of text, and then the quote, and then it closes. And so this is what we have right here. Now it opened up with the quote for us automatically, and we gave it a quote, and then we closed it. So this input value is now complete because it has the open right here, and it closes right there. And then we can move on to the next block of code, which is going to be our actual payload, the script, right? And then that'll give us the response, the pop-up that we want. And then finally, we have another one asking for the name, and the name as previously before. So you do see it right here. So this is now, we have the first input, and then we have another one. And this is now a bigger block of text. This piece right here does not have the option for you to drag it open. And then this one right here actually does. You can see it by this bottom element right here. That piece, that allows you to drag it open and enter like bigger paragraphs and modify paragraphs and things like that. So we have to now escape the text area, and we need to do it a little bit differently from the previous element, because this element right here is not similar to what we had up here. So this one had input, which was the initial parameter that opened it up, and then there was a value inside of it, and then we were closing the value, right? And now inside of this input element, it's already done. So this is why HTML is kind of important. So you see the H2 right here. Every single one of these things has to have its counterpart to close that piece. So div opens, and then we have this / div that closes. You have H2 that opens, and then you have / H2 that closes. We have script right here that opens this portion, and then we have / script that closes to say that this portion is now complete, right? So for this, for input value, what we need to make sure is that it didn't have the open bracket, input, close bracket. It didn't have that. It has input, and then the next piece is the parameter, and that parameter needs an argument, and then it has the close bracket. You see that? So when we know that this type of stuff exists, and that's how text for XML and HTML, that's how source code works, then you get to make sense of this. So we have H2, and it closes with an H2. This one has text area, and it closes with a text area. So what that means is that instead of just doing a quote and a close bracket, we're now going to do the closing text area element, which is what's required for this to close. And then after that, we input our script. So the final piece looks like this: text area open, text area closed, and then we have script alert, etc., etc. And then there's this other text area, that second portion of the text area, that's always going to be there. So the important part is this first piece, which is the first element closing, right? Now we can see that it should technically work. The last portion, I think, should just be like a little glitch, or it should not even give us a glitch. And that should give us our pop-up. And then finally, we have the name into the form. You'll see that reflected on the page. This looks similar to level 1, but upon submitting the page, you'll see that the name gets reflected into some JavaScript code. So this is the source code right here, and it doesn't show us an example screenshot of it, but we have script document get element by class name, and then in the 0 index position, which is the very first index position, inner HTML, and that's Atom. So that's the whole piece. So we'll have to escape the existing JavaScript. So now we actually have JavaScript that's going to display the name. So we need to exit it so that we'll be able to run our own code. And so to do this, we need to just do the / and then the semicolon, which will close this script out. And then we put the alert, and then that's it. So we'll see that it will execute the single colon, closes the field specifying the name, which is this guy right here, this piece right here. It closes that, right? Then the semicolon signifies the end of that full command, and then the double / make anything after it a comment rather than executable code. So we have this whole piece, and then inner HTML equals quote, quote, semicolon. So this is now fully done. This entire piece is fully done. And then after that, we have alert, THM, etc. And then anything after that would be considered a comment, which would not be executable. And finally, we'll be able to get our pop-up. And then we have the one as level 1. So it's similar to level 1. And the name also gets reflected in the same. But now if we try this piece, it won't work because you will actually get, I think, sanitized. So the word script gets removed from the payload because now it's stripping it out, right? There's a filter block in place, so it's stripping it out. So if that's the case, we need to then find a trick around that, right? So now instead of just putting a single script, you're going to do s script crypt. So what it's going to do is it's going to delete that because it'll notice that as an actual word that's been blocked. But then once that's deleted, this piece combines with that piece, and now you have a script that's executed. And then same thing for the closing portion. So those things are to be removed, and then the final payload ends up working like the normal stuff. And then it'll actually run and you'll be able to get it. And then we have this piece where if we look at the source code, it's now being pulled from what looks like an image source. So we still have to close it just like we did previously, but that doesn't seem to work. So let's expect it. So if we look at it, we'll see that this is actually being placed inside of an image source tag inside of the HTML. So obviously that's not going to work if you do that, because it does need some kind of image source. So we can see the AND characters right here. So where are they at? Not the AND characters. I'm so silly. You can see these and these two characters that are getting filtered out from the payload, right? So these characters right here, they're being filtered out. This is being filtered out. This is being filtered out. So all of those things are being replaced. So kind of similar to what we can do previously is you can first test out whether or not this actually is going to work by actually putting an image in there. So you would do / images cat, etc., and then putting onload, which is another one of those parameters, one of those functions that exists inside of JavaScript, and then viewing the code, and then we can see that this is what it's going to look like. And on load, it should get that. So when we click it, the pop-up with the THM screen, text will actually pop up. There's something called polyglots, and it's a string of text that has escape attributes, tags, and bypass filters. And we have something like this, as you can see right here. There's a bunch of escape characters in here. And so when you look at this, you could have used the below polyglot on all 6 of our levels that we completed, and it would have executed the code successfully, because there's a bunch of escape characters in here that allow the JavaScript code to run as normal. So technically, what I could do is I could just use this in every single one of the exercises, and you would be able to execute it properly. But I think what's useful is to actually learn those individual portions, these individual modifications that can be made, to learn what it's like to manipulate the various defense mechanisms that exists on a specific server, right, or on specific JavaScript websites. So what we're going to do is we're going to implement all of these things. A lot of them are pretty self-explanatory and easy to understand. So just to make our lives a little bit easier and quicker, because I don't want to repeat everything that I did, because I literally read them in as best of a detail as I possibly could. So what we're going to do is going to run the exercise that would get us our 6th. Actually, no, we need to go through all of them to be able to pull it off. So I'm going to do this one, right? Hank, press enter. It says, hello, Ank, confirming XSS payload, and nothing is actually input in there. So the very first one that we need to input is just the normal XSS script that we have right here. So we'll just go here, and then we're going to paste this in here, press enter, and now we get a pop-up that says THM, right? So that actually worked, and there we go. So that was level 1, right? Now we can move on to level 2. Now this one isn't going to work because it's just going to print the script onto the screen right here. So if I go and look at the code itself, right? If I look at the source code right here, boom, right here, we'll move in on this. We'll see hello input value, and then it actually has the script, all of these things. So what we need to do is we need to close the boom, and then we do that one right there. So that's what it will look like. So you do that, press enter, and now we should have the XSS payload, and it didn't pop up. So let me make sure that it actually works, because I really do want it to work. So, oh, I think I did it in the wrong place, sorry. So it needs to be in this place, not the hello portion. So it needs to be in that place. Press enter. There you go. Now we have the pop-up. Excellent. So now we can move on to example number 3. This one right here, if we do Hank, enter, and it says hello Hank. This is the text area portion, right? So if we look at the source code for this again, so inspect the element, go right here, we go right there, and then we should see that it says text area, and then it has that. So we need to put this piece right here, this last piece, closing piece, before we put our script. So it's going to look like this. You do that / text area, and then close, and then from there you paste your script, right? And then press enter, and there you go. there's our pop-up. So that's level 3. Level 4, if we go into press Hank, it'll do what? Hello Hank. And now we can look at the inspect element of this to see what this is showing. And it's a span class name. So it says hello span class name Hank, and then it closes it out for us. And so what were the instructions for this one? I forgot that one. So this is on level 4. If we go to level 4, yeah, this is the one where it's actually doing a script execution already for us. So to be able to finalize this one, so if we go over here, payload failed, obviously. So if we do an inspect of this element and we go here, zoom in on this, we can see that there's a span class, etc., these things being executed, and this in the background, I wonder what part of this I should be able to see my JavaScript being executed, because I am very curious to actually find that specific JavaScript that's being executed. And let's see where we can find it. I think it would be under, not under network, it's under sources. Nope, it's not under sources. It should be somewhere. I wonder where it was. But it is something that we have been confirmed to notice that there's a script being executed. It just doesn't tell me at what location I would be able to find the script. I think it would be something that I might have found if I had, you know what, let me just look around for it, because I know that I can find it, because we found it for all the other ones as well. Oh, it's actually right here. It's right below that piece that we had right here. So underneath this, so it's inside the same div, right? So if we open, or as underneath the form, there we go. It's inside the form, inside of the ID content. So that's the piece right there. So ID content, right there, there's a document get elements by class name, and then the name, and then Hank. And if we go into this piece right here, which was where the actual form was, and it says hello Hank, etc. And so from the form, it's pulling that, right? Get elements by class name, and it's pulling all of the data that are inside of this form itself. So this is the piece right here. That's the piece that's being executed. So we need to make sure that this piece right here is being closed out based on the information that we received. So if we actually execute it as such, we do the closing quote, the single quote, we do a closing semicolon, and then we do the alert THM, close that, and then we do another semicolon, // So boom, this is what it will look like right here. Enter, and it'll then execute, and there you go. It now executed the JavaScript code, and we actually have it. And then after that, it closes this back out, right? So there we go. Now we can move to level 5, which is going to again ask us to enter our name, but this is the one that's going to sanitize the full script, right? So if we go and execute it, we should be able to see that this piece right here, look, it removed everything, right? So if I go ahead and inspect for this specific element and we pull it right here, we can see that basically everything from our script was removed, right? The open and close elements of it were still there, but everything else was actually removed because the word script does not exist. So in order for this to work, we need to modify the script in this capacity. We actually put the word script inside of script right here. So you see S script and then crypt, right? Like that. And then you got to do the same thing right here between the S's of the script. So just put another script in there like that. You do that, and then you come out, press enter, and then there you go. It executes it for you, and it'll confirm our payload execution. And finally, we have level 6 execution. So we'll go to this one. And this is the one that the image cat should be pulled, right? So there you go. You have the images cat being executed. So if I pull anything in here that's a script, it won't execute because it's going to look at an image source for us, right? So if I go ahead and inspect this image, it'll pull this up right here, and this is what we're seeing, the image source, and then the enter an image path. If we inspect this, we'll get to see that inside of that, there's this other piece that's being input into the form. The name for the payload is actually getting the request for this specific thing. So we see the images cat being requested, and then the actual image is being pulled from that folder, the images folder. So what we need to modify in this is a little bit different from what we saw previously with everything else, because we are not now doing the full-on script command. Now what we're doing is doing the images, cat, and all of that, but now we need to close it with a close quotation. We put a space, and then we do onload equals alert THM, or, you know, let's do Hello Kitty, because that part really doesn't matter. And we do that, and then we close that, and then we do, I think that's it. That's basically it. You do that, press enter, and we should get the pop-up, and there we go. It says Hello Kitty. So that part doesn't really matter. And there we go. The final execution is now going to be confirmed. Oh, because it's that's so funny. It shouldn't be Hello Kitty. It should actually be THM, because they really want that specific phrase to be confirmed. Otherwise, they won't give us our credit for completing the exercise. So there you go. THM has not been executed successfully. And there is the final flag. That's so funny that like it has to say THM, otherwise you won't get the full XSS flag at the very end of this. Now, what I'm really curious about is using this thing right here, right? So they said we could technically use this for every single one of them, and we should be able to launch the flag or launch the thing. There you go. So that one worked for that. So if we go to the very first one, and we also input it here, same thing, right? I'm using the same thing. It launches. There you go. If I go to the next one, do that, press enter, launches. So it works for every single one, which is what's known as a polyglot. And I know a little bit of JavaScript. I have no idea what a polyglot is. And I could technically have Gemini explain it to us. So let's see. Can you please explain the above polyglot? Let's see what we get from Gemini, because it's very good at explaining complicated things. So in this context is a piece of code that can execute successfully in multiple different contexts or bypass multiple different sanitization filters, often by cleverly closing or manipulating tags. This particular one is designed to trigger an alert THM pop-up in various XSS scenarios. And the overall goal is to do this, right? Detailed breakdown, you have this. I mean, this is so much of a breakdown that it's like a whole thing to be able to learn from here. But one of the key things that I would tell you to do, I'll say this, right? Look at this. We're going to do this just because I love you and I want you to succeed. I'm going to terminate this machine. We're going to zoom in on this mofo. Super zoomed in. So there we go. Let's zoom in. And you're going to get to see this right here, just in case you don't have access to TryHackMe. Pause the screen. Have fun typing this out. But it needs to be case sensitive, and all of the different elements of this should be done correctly. So type this out, right? Take this word for word and go ahead to your favorite AI and have it explain it to you. And then you'll learn what a polyglot really is. But to know what it is, you can just know that it's meant to be executed in different environments and still be successful. In this particular case, it's an XSS polyglot. And as you just saw, it will work in every single one of those 6 exercises that we just went through. So very, very useful to know things like this. And I have yet to master anything that's even remotely close to this. So I'm not in any way explaining this or saying this from a high horse or trying to act like I'm better than anybody. I literally would not be able to begin to explain this for you unless I went through a word-for-word reading of what Gemini just gave me. And that's beyond the scope of this video anyways. It's good for you to know that things like this actually do exist so that you can go ahead and take advantage of them if this is something that you want to specialize in. When you go into further different levels of penetration testing, this might not be a bad thing to specialize in, because cross-site scripting is a really big one. It's one of those really big topics that companies pay for, and there's a lot of forums in different companies' websites that you can mess around with to see what can potentially be done. And if you can execute a basic alert pop-up, then you can technically execute a variety of different types of scripts and technically do malicious things, which means you can get paid from the companies on HackerOne and so on and so forth. So I'm going to stop reading. I'm going to stop beating the dead horse, the proverbial dead horse. And we have the next exercise, which is going to be our blind XSS example. For the purposes of this particular exercise, we need access to the virtual machine, the target machine that's going to be launched, which is what was launched right down here for me. And I also need to start the attack box, which is the internal attack Linux machine that's available through TryHackMe. You can also connect via OpenVPN to the TryHackMe server and then use your own computer and the IP address of your own computer to pull this off. You do need to have Netcat installed on your computer if you're going to exercise this, because we do need to create a Netcat listener on our attack box or on our main computer so that we can get that connection back from the victim machine, that website that we're going to be exploiting. So the whole purpose of this is to essentially combine a few of the tactics that we've learned so far with another tactic, which is to create a reverse listener with Netcat and then establish that connection. So once the virtual machine is launched and the attack box is ready, this is going to be the website that we're going to get access to. We're going to go to the customers tab, we're going to create a new customer profile, and then we're going to go to support tickets and we're going to start creating tickets. Now the first one that we're going to create is just going to say test in the ticket. So this will be ticket number 1, I guess, or this one is ticket ID 3, whatever. So you do test, and then you just want to see what the response of the page is going to be and what the source code is going to show us. Now, in this case, it's a text area, right? So we've already seen the text area element of this. So we know that we need to have this close tag right here so that we can actually execute something with JavaScript after that text area is closed. So that's the first one. We see it. So we see that we can now do another version of this. So we'll do text area test, and then we look at that, and then we can see it right here, right? So you can see that we close the text area right here through the first portion, and then we put test, and it still printed the test for us. So it's not like it's not available. It's just that it printed the test outside of the text area. It's kind of hard to see, or maybe it's on my monitor that it's hard to see. On the recording, it seems to be that it's actually easier to see. So you can see that there's the text area itself, and the word test is printed outside of the confines of the text area. So that means that this actually worked. This piece that we have, that actually worked. So now what we can do is we can try to see if we can run JavaScript inside of that little portion and see if it'll actually execute. And if you do run this piece right here, you should get a pop-up that will give you the alert THM. So what I'm going to do is I'm going to just launch from this portion right here. I'm going to create the payload that will connect to our Netcat listener. And from the Netcat listener, we should be able to get a reverse connection to the web server. And then from there, we should be able to technically get the rest of the data that we need, which is mostly the document cookie. That's the big piece that we're trying to get. We're trying to get the cookie value of the document. And so this is the full payload that we're going to be executing now that we know that we can actually execute JavaScript. So the first portion of this is the text area, right? So this portion closes the text area field. This portion opens an area for us to write JavaScript, and we've already talked about what the fetch command does inside of JavaScript. It makes an HTTP request. Now the URL or IP portion right here that you can see right here, this is going to be the IP address that is assigned to my attack box. And on your own machine, if you have Windows, you can do ipconfig and you would get your IP address. On Linux or Unix, you would do ifconfig, and then you're looking for the interface IP address, which is usually like ENS0 or ENS5 or something like that. And that specific interface value will end up having an IP address assigned to it, and that's the IP address that you want to find. And I'll show you kind of what that looks like in a little bit. So you put the IP address in this particular case. So it could either be the catcher URL, because you could put a URL in there as well, or the IP address that we're going to end up using. And of course, the port number that's followed up after the fact is the port number that we're going to be listening on. So in this case, this is the port number that we're listening on. So it would be whatever the IP is, colon 9001, right? If you use that port number. Then we're trying to pull the query string, which is the victim's cookies, right? So this is, remember, anything after the question mark is a query. It's starting a query. So we're looking for the cookie, and then we're trying to pull that cookie string. We're going to base64 encode it, and we're going to pull the document cookie, which is all available here. So boom, after you've input the port number and your IP address, you start the parameter, which is the cookie string, equals, you have the closing quote right there, and then with the plus sign, we're going to concatenate the next portion, which is the base64 encoded version of the document cookie, and then we're just going to close out our script, and that's pretty much it. That closes the actual JavaScript code, and then now we should be able to execute that and get a listener connection through our netcat connection, which would then allow us to see the request that comes through the victim's cookies, and then we'll be able to hopefully get the final answer for this. So it says you may encounter issues when receiving the request using your own VM and the VPN, so it's recommended that you use the attack box. And this is the main reason why I pretty much default to using the attack box instead of using VPN and connecting to my own computer, because there are some times that there are issues that are generated when we do exercises like this one. So I am going to be using the attack box, and that's pretty much the whole thing. That's how the story goes. So from here, the very first thing that I'm going to do is I'm going to open up my attack box machine in a new window so that we can go ahead and just kind of zoom in on it and execute the exercise. So we have the machine right here. It's opened up for us. It's in split screen. I'm going to open up the terminal. The first thing that I want to do is I just want to create this netcat listener, right, in order to be able to pull this off. So I'm going to do netcat NLVP 9001. Now those flags for the NLVP, so it's like, you know, do not resolve for domain names. That's what the N, I believe, stands for. The L would be you're in listening mode. The VP, I think it's for like verbose and assigning a port number. I don't remember the flags, so my apologies. Let's actually just, instead of kind of using that as a scapegoat, let's actually find out what the NLVP flags inside of netcat are. So what are the NLVP flags in netcat? What do they do? Let's see what the explanation for this would be. Should be fairly straightforward. So yeah, N is for numeric only IP addresses, so it doesn't resolve for domain names, right? It doesn't perform any DNS lookups, which is useful. L is in listen mode, which is what I already talked about. V is for verbose, which is what I already talked about. And P is for port, so I was actually right. Okay, great. So I don't feel too bad about this now. So that's what we're going to be doing. So we're going to do that, and then we're assigning port 9001 for our listening port. You can technically assign any port, but for my particular case, I'm more interested in using a port that I'm pretty sure is not currently available. And that's actually the first thing that I should probably do. Is first let's run ifconfig just so we can see what our IP address is. So these things are not the interfaces that we're interested in. Those are the Ethernet interfaces. LO is for loopback or local, which is always going to be 127.0.0.1. So that's not it. ENS5 is the interface. And so the IPv4 address is 10.10.230.254. And then you can also see that in the top right here, 10.10.230.254. I just wanted to do the full exercise so you can see how you can find your IP address. So we're just going to clear the screen. And now we're going to do our listening or our listener using netcat. Boom, press enter. Now it says it's listening on the local machine, right? On the actual local machine, it's listening on port 9001. So that part is all good. Now we can open up our browser and go to this IP or this address right here, this full address. That is the address for the website that is potentially vulnerable, right? So we go there. It's going to give us the customer. There you go, Acme IT support. We're going to click on customers. My login from the last one probably does not exist anymore. So we're going to recreate it, and it's going to be Hank at, let's do THM, a bullshit email address. Password is going to be password. So this is all like almost irrelevant what you enter, because you're just going to end up creating an account. Now, once you're inside your customer dashboard, you're going to click on support tickets. And now we can see a few other things, including create ticket. And so the create subject or the ticket subject is going to be test. The ticket contents is what we're most interested in here, which is going to be the script that we're going to input in there. So in the interest of time, I'm just going to copy this whole piece, which is this full script that we have here. I usually type it out. Should I type it out? I think I'm going to type it out. I just want to like get these things in the bones, right? I want to get them in my fingertips. So we're going to first close out the text area, and we're going to open up a script. We're going to do a fetch command, and we're going to do HTTP / right? And then I'm going to give it the IP address of my attack box, which is the one that we found with ifconfig. We're listening on port 9001, so that fully closes that for us. And now what we're going to do is the question mark cookie equals, and then we're going to close out the quote. So this is what it looks like so far. We've closed out the text area, and we have written the first portion of the script. So it's going to be opening the script. We're going to call on the fetch function, and inside of that, we're going to begin the actual port or the IP address and the port of our listener, right? So this is our netcat listener. That's where it's listening on right now. And then we're going to do the question mark cookie equals, and we just got to make sure that we close that first quote that we have right here. So that's so far so good. So now we're going to do the concatenation with the plus sign, BTOA, so that we can base64 encode. We're going to do document.cookie, and then close the parentheses for that, space, another close parentheses, semicolon, and then we're going to close the script. And then that is the full piece right here. So once we finish that part, we have a space plus space, BTOA, document cookie inside of parentheses. There's another space right there. So if I click one, it's going to move forward. And then the next one is going to be this closing parentheses and then semicolon, and then we close the script entirely. And that's basically it, right? That's the full payload that we have. So now I'm going to click create ticket, and I've created the ticket. So I'm going to go ahead here, and it's already done. It finished the connection, and that was very, very fast. It said we need to wait a minute, but it was really, really fast. So connection received on this port. The cookie value that we wanted to get, right? We made a GET request to get that cookie value is this. So this is the full cookie. It's the base64 encoded version of the cookie. So I'm going to copy that, and then I'm just going to open up CyberChef in my own browser just to make it a little bit faster for us. We're going to paste the base64. What happens is that when it's like a clean piece of encoding, you'll get this magic wand option that will detect what this is right here for you. And so you just press that, and then it'll take it. Now it says staff session, and there you go. That's the cookie that we need for our answer. So JB3, etc., etc., etc. And this one is actually different. So 4AB3 da 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 da. So that's actually different. So that's interesting. So maybe I needed to do the other 3 exercises to be able to pull this off, because the staff session cookie is completely different in this particular case. So I wonder if really it did need to be something else that I had to do, because that's actually very interesting that it's a different value that I got this time. So I will say this, right? So just to make sure you don't have any issues if you're doing this on your own, create the first 2 cookies, or create the first 2. How many did they do? I think they did 2, right? They created 1 ticket, and they just did test, and that was the first ticket. Then they did another one where they did the text area test to see if it will leave the text area. So that's 2 cookies, or 2 support tickets, excuse me. So they created 2 support tickets, and then they did one with the alert pop-up. So that's actually 3 support tickets. And then the 4th support ticket was the one that they did with the final payload where they downloaded it. So I wonder if that is the specific order that you need to do this for, because I jumped the gun, and as my first support ticket, I did the final payload, and now the value of the session cookie is different from what we have in the answer over here. But you can see that it worked, right? So that's the piece that it's like, okay, well, at least it worked. So that's fine. So I'm okay with that part. But I think it was important for you to do the first portions of this exercise, just so you can finalize and get that last support ticket to actually match the answer for you. So again, do one, just a regular test, and then that's it. The next one will be the closing of the text area, doing tests, so just to see if the test will show up outside of the box. And then the next one is going to be this one, where you get the alert of the pop-up, right? The pop-up for the THM. And then, so your fourth support ticket is going to be the ticket that I just created, so that you can get that final answer, which ends up being the base 64 encoded cookie that you can just then go to CyberChef for, and you can decode it. So assuming that you just don't skip to the very end like I just did, I think you should be fine, and I think you should be able to get that final answer from that practical exercise. And then that's pretty much it. Like, everything up until that point was just reading through the lecture materials and then making sure that you understand what these various different types of cross-site scripting attacks are. And assuming you understand that, and assuming you got all that, you can do the perfecting payload, which was kind of like a nice test to see the different types of payloads we can run to get that pop-up to show up. And remember, you have to put THM in the payload so that you can get your final flag. You can't put Hello Kitty like I did, which didn't give us the final flag. So you have to do exactly the one that they want you to do. And then the final one was the blind XSS, which just makes sure that you actually do all of the first 4 tickets, I think, right? Again, I keep losing count. So we did, you did 1 ticket, then you did 2 tickets, and then you did the 3rd ticket, the 4th ticket. So you do 3 tickets first, and then the 4th ticket will end up being the one that you do the netcat listener for, and then you do this complex payload where you actually have a reverse connection to your netcat, and then it'll retrieve the cookie value for you. And then from there, you're off to the races. You can use CyberChef to base 64 decode that value, and then you'll be able to get the answer. Ideally, it will be the actual answer, because the answer that I got previously when I first ran through this room was not the answer that we just got right here. Very, very different session cookie. But I think it's because, I just think it's because I jumped the gun and I kind of just went to the very, very end and I did the last exercise. But that was pretty much it. I loved this specific exercise. Anytime that I repeat these types of rooms, I get more ingrained, like the data rests in my mind a little bit better, or a lot better, I should say, and I just understand the content so much more. So if it's your first time going through it and you don't get it, don't fret, don't worry about it, because if you go through it again after you've completed it once, go through some other stuff and then come back to this and then go through it again, it'll just click better. You'll understand it better. And every single person that has tried it like that always comes back and they're like, yeah, I understand it so much better now. So I do recommend you doing this more than once. Don't just do it one time, especially if you don't have a background in HTML or XML or JavaScript or any of those things, because it's your very first introduction to it. And so it would be normal if on your first introduction you didn't understand everything that was going on, and you just need some more practice and similar exposure to it. So be patient with yourself, be kind to yourself, try it more than once, and I promise you'll get a better understanding of it. And with that being said, we are done with this official room. One final word from Hackaholics Anonymous, and we'll wrap it up. If you found value in this video and you would like to get more videos like this one on Junior PenTester or on PenTest Plus or anything else, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. Make sure you drop a comment in the comment section if you just want to say hi, or if you have any questions about what we went through, because it was a little bit complicated what we went through. But I think if you actually follow the instructions letter by letter, I think you should be perfectly fine. We have a bunch of content that's already on the channel. There's a bunch of content that's in line to come out, including the CompTIA PenTest Plus training series. This specific video I think is going to go down mainly because of the fact that there are a lot of people that are talking smack to me in the comment section, and they are nitpicking on this particular video because when I made it, I was not as well versed in system administration on Linux as I am today, and so I made certain mistakes in my lecture, and people are coming for me in the comment section, and it's disheartening because people can be very, very mean in the comments, as I'm sure you already know, in social media and in the internet. This one, however, see, that's the thing, that's the other thing, that's like this video and this series of playlists, the Linux Plus playlist, has been so instrumental for people passing their Linux Plus examination. And so there was literally a 4-month difference between these two playlists. This one was 10 months ago, this one was 6 months ago. People have used this playlist to pass their Linux Plus examination. This one apparently was not the best version of the video that I could have made, and people are talking smack to me. So it's all the people who are talking smack clearly did not go watch the Linux Plus playlist, which is, I get it, it's fine. So for the most part, it's a shorter video. It's a 2-hour video. The Linux Plus playlist is over, I think, 20 hours of content. There's a lot of content on that playlist, but that's why it's like so comprehensive, and a lot of people use it to actually study for their examination, and they learn mastery of Linux through it. So anyways, I think the shorter one, I think it's going to end up going away. The rest of them are going to stay. We do have the PenTest Plus playlist that's available to you, and it's being updated every Friday. Network Plus is already done. Python for Hackaholics Anonymous is a members-only playlist that's for the Hackaholics Anonymous members. Security Plus is already done. Linux Plus is already done. CySec 101 is already done. We also have the SOC Level 1, SOC Level 2, and Security Engineering playlists that are all already done. Members-only videos that are available here, so all of those things. And the PenTest Plus stuff, members get weeks in advance. So that's another one of those things that is like a really, really big benefit for being a Hackaholics Anonymous member. But apart from that, just make sure that you like, subscribe, and turn on notification bell. Drop a comment in the comment section if you have any questions. And that's pretty much it. So let's talk real quick about Hackaholics Anonymous, and it will be done. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section on the channel. And that is it for today. So boy, Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. And I'll see you in the next video later. In episode 14 of the Junior PenTester training series, we're going to go through the concept of race conditions and how they actually apply to and affect web applications and web application security. This is actually a concept that is relatively new in the world of TryHackMe, and it is an important concept because it's something that can be exploited and manipulated for the benefits of the hacker. I'm not going to say necessarily that it's beneficial to the target or the victim, but I mean, we are talking about pen testing, so this is all supposed to be stuff that would be good for us as ethical hackers, as penetration testers. So we have the intro, the concept of multi-threading, race conditions and what they are, web application architecture, because it's very important since we're manipulating and exploiting web applications. There's going to be the first exercise for exploiting race conditions, detection and mitigation, and of course the final challenge against the web application. This was developed by Strategos or Strategos. I always mispronounce it. I have no idea what the correct pronunciation is, so that would be something that I'm actually curious about. In case you ever watch this, please drop a comment and let me know what your final pronunciation is for your username. This particular person has developed a lot of the rooms inside of TryHackMe, so we're grateful eternally to him or her or them or whoever it is for them to actually creating all of these resources for us so that we can learn and become better. This is a subscriber only room, which means you need a paid subscription to pull this off. TryHackMe is totally worth the money. So it's something that they actually require many universities for their students to get access to, because it gives you an environment for you to test all of these things and apply them and experiment with them without getting into trouble. So I do highly recommend it in case you have not checked it out. I get nothing from TryHackMe for saying this. I just really love the platform, and I'm grateful for them for having learned everything that I've learned so far from them. So very, very useful platform. I highly encourage it if you don't have one already. Let's talk about Hackaholics Anonymous for literally less than a minute, and then we'll jump into race conditions. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into race conditions. To help us really understand what these things are, let's look at a scenario. So let's say that you have the responsibility of testing the security of an online shopping web application. There are a lot of questions that come up. Can you reuse a single $10 gift card to pay for a $100 item? Can you apply the same discount to the shopping cart multiple times? The answer is actually maybe. If the system is susceptible, meaning if it's vulnerable to a race condition vulnerability, we can actually do this and then some. So in this video, we're going to be talking about what that specific vulnerability is, how in a situation in computer programs where the timing of events influence the behavior and outcome of a program, how this actually applies to that. It typically happens when a variable gets accessed and modified by multiple threads at the same time. And due to a lack of proper lock mechanisms and synchronization between the different threads, an attacker might be able to abuse the system and apply a discount code multiple times, for example, or make money transactions beyond their balance, for example. So the objectives of this video are to first understand what they actually are, what race conditions are. And using a tool like Burp Suite, one of our favorite tools in pen testing, there's multiple videos on this channel specifically on Burp Suite and how to use its different features. But we've also been using it a lot in this specific training series because we're talking about pen testing, and Burp Suite is literally designed to help for pen testing web applications. We're going to be using the repeater feature inside of Burp Suite to exploit race conditions. And along the way, we're going to learn about threads and multi-threading and state diagrams, the prerequisites for you to understand how the web works. So in case if you don't know how the internet works, that's a really good thing for you to study. You need to know what packets are, and you need to know what frames are. Now, these are conversations and specific elements of the OSI model, and they come for different parts of the OSI series, the OSI layers. So there are frames that go inside of packets, or packets that go inside of frames. I'm a little bit dyslexic. I forget which one is which. I think packets go inside of frames, if I'm not mistaken. And then, of course, there's the Burp Suite basics, and you can actually find that video on this channel. And if you want, just go through the entire Burp Suite series of videos so you can really get a good understanding of what it is and what it does. And as long as you understand those things, you'll be able to pull off this room without any kind of a hitch. So let's get into the multi-threading concept. To understand multi-threading, we need to first understand programs, processes, and threads, and then how all of those things feed into this concept of multi-threading. So what is a program? It's a set of instructions to achieve a specific task, basically. You need to execute the program to accomplish what you want. So unless you execute it, it won't do anything. It just remains a set of static instructions, right? So you have to actually launch the program and use the program, interact with the program. There are different types of programs. They have different types of complexities and features and functions. And depending on the program, some of them require interaction to work, like a calculator, right? Even if you open a calculator, it's not going to do anything for you unless you actually punch in some numbers and use some formulas. So think of a program as a recipe. You just downloaded a new coffee recipe, and it includes a variety of herbs like cardamom and cinnamon. And these are the instructions, right? Combine brewed coffee, cardamom, cinnamon, and cloves if you're using it in a saucepan. Heat the mixture over low heat for 5 minutes, stirring occasionally. Don't boil it. Strain the coffee into your mug. Add milk if desired, and sweeten to taste with honey or sugar. Very interesting. I've never tried it. I don't even know if this is a real recipe. I am almost very curious to actually try it because I love coffee and I like messing around with coffee. So That might be interesting. I might try it. I don't know. And maybe it'll be horrible. So unless someone carries out the above instructions, no coffee will be served, right? You have the instructions, but unless you actually use them, nothing's going to happen. So comparing this to the minimal Flask Python, the Flask, excuse me, which is in the Python language, and the very first program you ever learn pretty much in any coding language is how to print hello world onto the screen. Now, Flask actually allows you to create servers, right? So you can create a very basic server on Flask or through Flask, and that Flask, I guess that server will end up just printing hello world. So the code will dictate that the app will listen on port 8080 and respond with a minimal greeting that contains hello world. However, we must run these instructions before we expect to get any pages. So the Flask code is shown for demonstrative purposes. We didn't provide an environment to run it, so you can't actually run it. But this is just to demonstrate, right? From Flask, import Flask. That's always what Python scripts start at. You need to, like in 99% of the script, you need to import some kind of a library that you're going to end up using. Then you create a variable, which in this case is going to be the Flask pulling the name of the specific variable and instantiating the actual variable. And then we're going to route the traffic to this function, and it's going to just print hello world, or it says greeting hello world. That's basically all it says. Then it's going to check if the script is being run directly. If the name equals main, then run it on the host, which is the local host, on port 8080. And this is a very common function right here. It's looking for the name attribute, and if the name attribute is main, which is basically checking to see if this script is actually set up and running, and I don't know what I just did. I think I clicked around too much. And if it is, then you're going to run it. And now I need to put this back into my original window, so hold on a second. All right, there we go. So processes now. So we've talked about what a program is. So let's talk about processes. One afternoon, you decide to try out this new coffee recipe you downloaded online. You start going through the recipe one step at a time. You're in the process of making the coffee. While in the process of executing the instructions, you might get interrupted by an urgent call. The ice cream machine is in the background. The ice cream guy is in the background. So if it gets too loud, I'm just going to pause real quick until he leaves, but hopefully it won't be too annoying. You might work on another job, right? So if you get an urgent call, or you might be working on another job while waiting for the water to boil, which is what I actually do every single morning. I just start my coffee percolator and then I walk away, and when I smell coffee, I know that my coffee is done. The interruptions and waiting are generally unavoidable. The act of carrying out the recipe instructions who makes the coffee is similar to the process of executing program instructions. A process is a program in execution. Think about it like that. That's probably the best way to articulate this. A process that's running on your list of processes in your computer are essentially just a bunch of programs that are running, whether in the foreground or in the background. A process is basically a program that's running. It's in execution. So in some literature, you might come across the term job, and both of these refer to the same thing, although the term process has superseded the term job. But a job in this context is also the same thing as a process. So unlike a program, which is static, right? It's not running yet. A process is a dynamic entity. It holds several key aspects, including the program itself, which is the executable code, memory, which is the temporary data that's being used from your RAM. It's also known as volatile memory, and it uses the processing power of your computer. So if you have 16 gigabytes of RAM, when a program starts running, it's going to start using that processing power to execute. And if you have too many programs running at the same time and not enough memory to support all of them, then your computer is going to lag and it's going to crash, etc. A process usually hops between different states, and after it's in the new state, which is it was just created, it moves to the ready state, which means it's ready to run once given actual CPU time and CPU usage. Once the CPU allocates time for it, it goes to the running state. So it has 3 states, right? Furthermore, it can be in the waiting state, pending input or output, or even completion. So input or output would be something that a calculator, for example, would be waiting for, right? And once it exits, it moves to the terminated state. So technically, we actually have 5 states, right? So new means that it's been admitted, it's ready to go. Once it's ready, it needs to be scheduled for dispatch to get into running. If it stops running, it's interrupted, it goes back to the ready state. Once it's running, it can either be terminated or it can be in a wait state, which is awaiting input and output. And if it doesn't get that, then it goes back into readiness. Or if it does get that, it will go back into readiness and then it'll start running. So it's a really great graphic that kind of explains the flow of a program's execution and what happens through its various states. And it's important for us to recognize this because in different states, there are different things that can happen to this specific program. And this is also where race conditions will end up coming in. We need to understand which state the program is actually in, or which state the process is in technically. And once we understand that, we can determine whether or not we can use a variety of different race conditions to manipulate the program or the process. So if we run that if we run that Flask code, a process is going to be created and it will listen for incoming connections on port 8080. Otherwise, it'll spend most of its time in the waiting state. When it receives an HTTP GET request, it will switch to the ready state, waiting for its turn to run based on the CPU scheduling. Once in the running state, it sends the HTML page to the client and returns to the waiting state. From the server's perspective, the app is servicing clients sequentially, and the client requests are processed one at a time. So just one after another, right, in order. And Flask is multi-threaded by default since version 1.0, and we use the argument without threads to force it to run in a single thread, which means it's forcing it to run sequentially and it won't run multiple things at the same time. So the Flask command, again, is for demonstrative purposes only. So Flask run without threads, host, etc. It will then run, and it will run it in a single thread without having multiple threads, which will require it to run in sequence, right? Which then brings us to this concept of threads. So another coffee analogy, just wrapping it up. Consider the case of a commercial espresso machine in a coffee shop. Nice. Let's say it has 2 portafilters. At the start of the workday, the barista turns on the espresso machine, and whenever a customer orders an espresso, 1 portafilter is used to prepare an espresso shot for them. Does another customer order an espresso? No problem. The second portafilter comes in, and the warmed up espresso machine is the process. Each new order is assigned a portafilter, and that's the analogy for the thread, right? So you have a single thread. As you can see, the one on the left is technically a single thread espresso machine. This one is multi-threads, right? You can have 2 threads technically running at the same time. A thread is a lightweight unit of execution. It shares various memory parts and instructions with the process. So these 2 threads are technically using this overall machine or program, right? And technically, espresso machines actually do have programming inside of them, especially the modern ones. They're definitely programmed. So in many cases, we need to replicate the same process repeatedly. And think of a web server serving thousands of users the same page, or a personalized page, but they're still serving thousands of users. And we can adopt one of 2 main approaches. Number 1 would be the serial approach. One process is running. It serves one user after the other sequentially. New users are in-queued, meaning they're placed in a queue, and until the last one finishes, they won't be able to run, right? So that's the serial process approach for threads, right? The next one is parallel. One process is running, it creates a thread to serve every new user. New users are only queued after the maximum number of running threads is reached. So for example, you have 2 orders processing, 2 new people come in, they have to wait for these 2 orders to finish processing. Once they're done, they will get the next 2 spots. If these 2 orders are processing and 4 people come in and they order espressos, they'll have to wait in order. And so the next 2 will come in, and then the last 2 will get their turn once the those are done, right? So threads still technically offer the concept of enqueuing or being enqueued, meaning placing somebody in waiting terms, right? And they just can process multiple things. So it's faster than a serial waiting time. Parallel waiting times will allow you to, or I should say, web server running these things. We can think of two approaches of this, which would be, I guess it is a serial or a parallel waiting time. So serial will be singular thread, parallel will be multiple threads, and then you're limited to the maximum number of threads. So the previous app can run with 4 threads using Gunicorn. I want to say Gunicorn. Man, these names. Who comes up with these names, bro? Okay, so it's green unicorn, so G unicorn, I guess, Gunicorn, whatever. It's a Python WSGI HTTP server. WSGI stands for Web Server Gateway Interface, which bridges web servers and Python web applications. So it just connects Python's applications to web servers. In particular, Gunicorn, whatever, can spawn multiple worker processes to handle incoming requests simultaneously, meaning at the same time. By running Gunicorn with the workers for option, we are specifying that we want 4 workers, also known as 4 threads, to tackle client requests. Moreover, threads equals 2 indicates that each worker process can process 2 threads. So my bad. So each worker is not a thread. Each worker is an individual worker, and then each of these workers can have 2 threads, which gives us a total of what? 8 possible threads. So Gunicorn command, again, is for demonstrative purposes. We didn't provide an environment. You can't run it, etc., etc. So when you actually do run it like this, so Gunicorn workers 4, threads 2, it gives us 8 threads, right? 1, 2, 3, 4, 5, 6, 7. I'm guessing there's an 8th one somewhere working as well. So it's worth noting, it's impossible to run more than 1 copy of this process as it binds itself to port 8080, okay? TCP or UDP ports can only be tied to 1 process. So on port 8080, on TCP port 8080, as you can see right here, this process can only run on that specific port, which means that there's only going to be a maximum of 8 potential threads that can exist on this possible port. If you wanted to run it on another port, that's a whole other story. So you can't actually run Gunicorn on port 8081 and do the same thing, and now you have another 8, which would give you 16, right? So you can do that. It's just that in this particular example, it's running on port 8080, which means you're only allowed to have 1 instance of it. The process can be configured with any number of threads, and the HTTP request arriving at port 8080 will be sent to those different threads. So technically, you can actually max it out at, I don't know, 1,000. I can't say infinity, but because you actually do have to give it a number, but you could technically max it out at a much higher number, so long as your server can actually support it. That's the other part, right? Like the processing power of your server needs to be able to support it. So you downloaded an instruction booklet on how to make an origami crane. What would the instruction booklet resemble in computer terms? So it's still a program, right? We haven't done anything with the booklet. So it's technically a program. Now, what is the name of the state where a process is waiting for an I/O event? And the key term right there is waiting. So the name of the state would be the waiting state. So now that we know all of this, let's talk about race conditions. All right, so here's a new scenario for us, a new analogy. Picture the following situation. You call a restaurant, you reserve a table for a crucial business lunch because you're very fancy and you're very professional. You're familiar with the restaurant and their setup. One particular number for table, the table number 17, is your favorite table, it's your lucky table. It's considering that it has a really nice view and it's relatively isolated and you can carry out business, right? You call to make a reservation for table 17. The host confirms that it's free as there is no reserved tag that's placed on it. At the same time, another customer is talking with another host and making a reservation for the same exact table. So at the same time that you're on the phone making your reservation, they're making their reservation. So who really reserved the table? That's considered a race condition. So why did this happen? This situation happened because more than one host was taking reservations. Furthermore, it took the host a few minutes to fetch the reserved tag and put it on the table after updating the daily reservation book. There is at least a 1 minute window for another client to reserve a reserved table. Similarly, when one thread checks a value to perform an action, another thread might change that value before the action actually takes place. So here's the first example. A bank account has $100 in it. Two threads try to withdraw money at the same time. Thread 1 checks the balance, sees 100, withdraws 45. Before thread 1 updates the balance, thread 2 also checks the balance incorrectly, sees 100 because the balance has not been updated, and withdraws 35. So that's a total of what? 80. Now we can't be 100% certain which thread will get to update the remaining balance first. However, let's assume that it's thread 1. So thread 1 will set the remaining balance to 55. Afterwards, thread 2 might set the remaining balance to 65 if not appropriately handled, because thread 2 still thinks what? That there's $100 in the account. So technically, that's actually very interesting when you really think about it. Thread 2 calculated that 65 should remain because it's withdrawing 35 from 100, right? That's when thread 2 checked it. It was still at 100. So in other words, the user made 2 withdrawals, but the account balance was deducted only for the second one because thread 2 said so. That's pretty insane when you think about it. That's really awesome. Okay, so example B, let's consider another scenario. Bank account has $75. Two threads try to withdraw money at the same time. Thread 1 checks the balance, sees 75, withdraws 50. Before thread 1 updates the balance, thread 2 checks the balance, incorrectly sees 75, and withdraws 50. Okay? So thread 2 will proceed with the withdrawal, although no such transaction should have been declined. Or excuse me, the transaction should have been declined because technically, right, take out 50, you're left with 25. You can't take out another 50. It would overdraw the account. But these types of things would imply that thread 2 still hasn't seen the updated balance, or thread 1 is taking too long to update the balance. Therefore, thread 2 is operating based on the assumption that there's still $75 in the account, right? So, example A and B demonstrate a time of check to time of use vulnerability. So this is a race condition vulnerability, what we've seen so far. So now here's a code, example code. So considering this specific thing with 2 threads running a task, completion by 10% increments. So you import threading. X equals 0, which is going to be the shared variable, right? In this function, you're going to increase it by 10. So global is X, right? That's the global variable. And for I in range 1 through 11, so it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It won't go to 11. That's how Python works. It's going to increment X by 1, right? And then threading current thread, etc. Name 0% complete, right? And then it's going to add increment to it. And then it's just going to keep repeating this until it hits 10, okay? Thread 1 is threading dot thread. So this is basically the thread function inside of threading. And it's saying that we're going to increase the target by 10. And for the target, it's literally calling on this specific function, as you can see right here. And then it's going to say, that's my name. And then for thread 2, it's going to increase it by 10. It's going to say, that's my name, right? Then we're going to start them. So thread 1 is going to start, thread 2 is going to start, thread 1 is going to join, thread 2 is going to join, and we're just waiting for them to finish. And then both of these things have finished completely. So this is basically a threading script, right? You're doing a script that's going to increment by 1 until it hits 10. It's a shared variable. So both of those threads are using the same exact variable, okay? So this is where everything kind of starts becoming a little bit interesting. So from the thread, from the current thread that it's using, whatever the name of the current thread is, it's going to take this integer that we have right here. And every single time that this runs, because this for loop that's going to run right here, it's going to be a repetitive loop. It's iterative, right? It's going to iterate through this I integer variable. And every single time that it loops, it's going to increase. It's going to increment by 1 until it hits its final range. So it's going to start at 1, it's going to increment by 1 until it hits its final range, and it's just going to keep printing this onto the screen for us, okay? And that's basically it, right? So they start together, they do nothing except print a value onto the screen. Consequently, one would expect them to finish simultaneously, or at least the results to be consistent. However, in the program, there's no guarantee which thread will finish first and how early it will be. So this is the first execution of this specific script. So thread 1, 40%, thread 2, 70%, thread 1, 50%, thread 2, 80%, thread 1, 60, thread 1, 70, thread 2, 90, thread 2, 100, thread 1, 80, thread 1, 90, thread 1, 100, and now it's been incremented. But now you can see the variable is now in different, it's different. It's starting from the same thing. So let's actually see. I wonder if it starts at 10, right? Because it's not supposed to. It's supposed to just increment by 1 is what's really interesting about it, because it starts at 0, it's supposed to increment by 1, but it starts at 10 right here, and it's at 40% when it's at 10, and it's a global variable, it's a shared variable, so you would think, right, that they would be looking at the same value and only incrementing by 1 until they hit 10. So when you do a second execution, thread 1 starts at 70. It started at 40 this time around. Starts at 70, thread 2 is at 40. Thread 1's at 80, 50. So you can basically see that obviously they're not doing this at the same time. They're not finishing at the same time. Thread 1 is finished at 100% here. Thread 2 takes its sweet time. This one, thread 2 had finished. Now thread 1 was taking its sweet time. So running it multiple times will lead to different results. Each time it should lead to a different result, pretty much. In the first attempt, thread 2 reached 100 first. Second attempt, thread 2 reached 100 second. We have no control over the output. If the security of the application relies on one thread finishing before the other, then we need to set mechanisms in place to ensure proper protection. So considering those examples, it's better to understand the bug's gravity when we leave things to chance. So on the attack box, we're going to save this specific code, run it multiple times to observe the outcome. If you save it as race, you can run it by doing this. That's fine. So as we saw in the program, 2 threads were changing the same variable. Whenever the thread was given CPU time, it rushed to increase X by 1. Consequently, the 2 threads were racing to increment the same variable. This shows a straightforward example happening on a single host. Generally speaking, a common cause of race condition lies in shared resources. So for example, when multiple threads concurrently access and modify the same shared data, examples of that are a database record and an in-memory data structure. There are many subtle cases. So these are 3. Parallel execution. Web servers may execute multiple requests in a parallel, as you already know what that means so far. So they basically run them at the same time to handle concurrent user interactions. If they access and modify shared resources or application states without proper synchronization, it can lead to race conditions and unexpected behavior. That's the parallel execution. There's database operations that happen at the same time. So concurrent, meaning running at the same time, those types of operations like read, modify, write sequences can introduce race conditions. So 2 users attempting to update the same record simultaneously may result in inconsistent data or conflicts. The solution lies in enforcing proper locking mechanisms and transaction isolation. Then we have third-party libraries and services. So a web app often integrates with third-party libraries, APIs, and other services. If these components are not designed to handle concurrent access properly, race conditions may occur when multiple requests or operations interact with them simultaneously. So that's kind of the 3 more common versions of when a race condition can take place, the causes of race conditions. So does the presented Python script guarantee which thread will reach 100% first? And the answer to that, of course, is going to be nay. All right, so in the second execution of the Python script, what is the name of the thread that reached 100%? And I think that was thread 1. So thread 1 was the one that reached 100% first. So we'll do thread 1. And that's pretty much it. So now let's look at web application architecture. I've done a good amount of conversations around architecture for operating systems specifically, but not necessarily architecture around web applications. I would imagine that there would be some similarities, but let's go through it and find out. There are multiple models that we can look at when it comes down to web applications. So there's the client-server model. When applications follow a client-server model, the client is the program or application that initiates the request. So for example, we browse a web page, the web browser requests the web page, which is a file, right? And so the client in this particular case would be the web browser. The server is the program or the system that provides that service and responds to incoming requests. So the web server responds to an incoming HTTP GET request and sends an HTML page or file to the requesting web browser, which is in this case what? The client, right? So that's the client-server model. Generally speaking, this runs over a network, meaning an internet connection. The client sends the request over the network, the server receives it and processes it before sending back to the required resource, okay? The typical web application follows a multi-tier structure. So architecture separates the application logic into different layers or tiers, and the most common designs use 3 tiers. You have the presentation tier, the application tier, and the data tier. So in web apps, the presentation tier consists of the web browser on the client side, meaning us, the users, viewing it and using it. The web browser renders the HTML, the styling sheets, the CSS, and any JavaScript code if applicable. Application tier contains the web application's business logic and functionality. So it receives client requests, it processes them, it interacts with the data tier, and it's implemented using the server-side programming languages like Node.js, PHP, SQL, possibly whatever, right? Data tier is responsible for storing and manipulating the application's data. So typical database operations include creating, updating, deleting, and searching existing records. And it's usually achieved using a database management system, DBMS. Examples of this include MySQL or PostgreSQL. And so these are the database management systems, but the actual programming language potentially would actually be the structured query language, which is SQL, right? So this would be the data tier, which is responsible for storing and manipulating the application data. So this is what it looks like. You have the web browser, which is the client, the users using the web browser. They connect through the cloud, the internet, to the web server. The web server will connect to the web application server. And then from there, it'll be feed back to the web server, which will then feed back to the web browser, which will feed back to the actual user. So the states, right, we need to consider. You have a few examples. We have validating and conducting a money transfer. We have validating coupon codes and applying discounts. So for a money transfer, if you want to transfer, let's say, to a friend or to your own account, you're just doing an internal transfer, or you're doing a transfer from one bank that you have to another bank, like using Zelle or something like that, right? So this could all be considered a transfer. So you would click on confirm transfer. That's the last piece of the transfer. And then the application queries the database to confirm that the account balance can actually cover the transfer amount that you want. The database responds to the query. If the amount is within the account limits, the application conducts the transaction. If the amount is beyond the account limits, the application shows an error message. Not enough funds, right? Insufficient funds. So you click confirm transfer, application queries the database. Database responds to the query. If it's actually within the limits, it'll conduct the transaction. If it's not within the limits, it'll say insufficient funds. That's basically how it goes. In the ideal scenario, the code will lead to 2 program states, amount not sent or amount sent. So if the amount is not sent within limits, amount is sent. Amount not sent, it exceeds limits, and then it goes back to, okay, amount not sent, and it'll give the error message insufficient funds, so you have to change your amount. If it's within limits, it'll actually send it, right? So that's the transferring of the money. There's a validating coupon codes and applying discounts. So it could be another one. So the user goes to the shopping cart, adds a coupon code, and it could be they enter the code. Application queries the database to determine if that coupon code is actually valid and if there are any constraints. Then the database will respond, and it'll say, it's applied if the code is actually valid and there are no constraints, or the message saying that if the code is invalid or there are constraints applying for that specific user. So they click apply, query the database responds, is it valid? No, displays an error message. Yes, it applies the discount, right? So the two scenarios ideally in this case would be the coupon isn't applied. Is it valid? Okay, it's applied. It's not applied. Why is it not applied, right? It'll give us the error message to say it's not applied for whatever reason. Maybe you mistyped it or something like that. And it could be used, it could be not applicable to your user account. You could have another account that's already implementing that supersedes this one. There could be a variety of different reasons why it wouldn't work, right? So those two states may not necessarily be actually the case. So if we look at analyzing the discount code example, ideally you would want either not applied or applied, but it's too simplistic. So you can add a different state, an intermediary state, which means checking the availability of the coupon. So coupon not applied, right? You add the coupon, it checks the availability of the coupon. If the coupon is applicable, it'll apply the coupon. If the coupon is not applicable, the coupon will not be applied. So depending on how the application is developed, we can expect more states. So checking coupon availability could be checking coupon availability and checking coupon constraints, right? A coupon might be valid, but existing constraints on that user may prevent it from being applied. So coupon applied might also be divided into two states. It could be recalculating total. That could be another state. So coupon not applied, right? Add the coupon. It's checking the validity, and if it's invalid, it'll say coupon not applied. If it's valid, it'll say, okay, if there are constraints, coupon not applicable because of whatever constraint, so it'll go back to coupon not applied. If there are no constraints, then it'll say that the coupon is applicable, recalculate the total, and then mark the coupon as applied, and it'll say coupon was applied, right? So you can actually probably do this with almost every example that we've gone through, because there's all of these extra steps to check, right? Checks and balances is very similar in the digital world as it is pretty much in any other world. So why is it important? Why is all of this important when we're talking about race conditions? Because all of these things technically take time. It happens in milliseconds or microseconds. It happens so quickly that you don't really get to see how long this actually takes. And maybe if your internet service is slower, it might take longer for you than somebody who's running a fast internet. But technically, each one of these steps takes a little bit of time, however long time it takes. And until it actually gets to this final stage, it's technically going through these variety of different stages, which means that something else could be running on a different thread at the same time, and they could, that next thing, that second thing could actually be running, and it could be doing something that maybe the web server or the web application doesn't want you to do. So in what we saw in the above example, there were passed through multiple states before the coupon is actually applied. So if we do it on a time axis, this is what it actually looks like, right? So coupon not applied, you add the coupon, checks the validity, checks the constraints, recalculates the total, marks coupon as applied, and applies the coupon. And this is the timeline, right? So from adding the coupon to the coupon being applied, there are technically 3 steps that are taking place, right? So this is very important to understand when we're talking about race conditions, right? It's literally a race. So there's a time window between the instant that we try to add the coupon and the instant where the coupon is actually marked as applied, and then it can't be applied again. So as long as the coupon is not marked as applied, most likely no controls prevent it from being accepted repeatedly. And we might be able to apply it multiple times during this time. And this is where the burp suite repeater is actually a very interesting tool. So this situation is similar when considering the states for program making money transfer. So ideally speaking, it would be 2 states. Considering the business logic, we can easily update the diagram to include 3 states. The reason is that we expect some time spent checking the account balance and the limits, although the amount of time might be brief. It's not 0, right? It's a very, very short amount of time, but it's definitely not 0 because it takes time. So if we dig deeper, we can uncover more hidden states. So again, amount not sent, right? You want to confirm the transfer. It's going to check the balance and the account limits. If it exceeds the limits, it's not sent. If it doesn't exceed the limits, if it's within the limits, the amount would be sent. If the web application is vulnerable, we still have one challenge to overcome, which is the what? The timing. So in vulnerable applications, the window of opportunity, that time between no, it's not applied, yes, it's applied. No, it's not sent, yes, it's sent. That's the window of the opportunity. So if we go back up here, right here, from here to here, this thing, this portion is our window of opportunity. So it's relatively short, therefore exploiting it necessitates that our request reach the server simultaneously. In practice, we aim to get our repeated requests to reach the server only milliseconds apart. So how do we get the duplicate requests to reach that? And that is what we use Burp Suite for. So how many states did the original state diagram of validating and conducting money transfers have? Technically, if we go up here, the money transfer one, this is the, what is it? Coupon not applied. If we go up here to the money transfer one, technically there were 2 states, right? So in the very, very first one, there were 2 states that were available for us. So is my keyboard just dies because I think I talk too much. So how many states did the updated diagram of validating and conducting money transfer have? And it had 3 states because we added that new state, right? How many states did the final state diagram of validating coupon codes have? And that was that big one that we had right here. So we have 5 states right here, right? So boom, and we go ahead and apply that. So now let's actually exploit the race condition. So let's have some fun. All right, for this particular exercise, there are a lot of instructions and click-by-click type of stuff that we have to do. So instead of just reading through this and then doing the actual exercise, I'm going to open the window, open the attack box and the burp suite and everything like that. And I'm just going to display it to you. And we're just going to go along with all of these instructions click by click. And hopefully I will actually be able to pull it off and we'll be able to get the flag at the very end of it. And if I can't, then what's going to happen is I'm going to troubleshoot until I do get the flag at the very end of it, because persistence is the name of the game when it comes down to this type of work. So we're going to open this up in a full screen so that you can actually see everything that's going on. And then I'm going to zoom back into here and I'm going to move it into my second monitor. And then from there, we're just going to truck along. We're going to make sure that we actually pull this off, and hopefully you will get the flag at the end of it. And I hope you're actually going along with me on this as well. Like the click by click, I think is very important for you to also experience as well. So let's open up Burp Suite and let's get the show on the road. All right, so here is Burp Suite. Now, usually when I use this, I do it in conjunction with Mozilla Firefox and Foxy Proxy so that I can intercept all of the requests that are being made from Firefox inside of Burp Suite. But based on the instructions that we have right now, they're telling us that they want us to use the actual browser inside of Burp Suite. So when you go under the proxy tab, as you can see right here, inside of the proxy tab, you get the option to open a browser, right? So you can click on that and there's an actual, I think it's a Chromium browser that opens up inside of Burp Suite. But when you do this, so if you haven't configured it completely, when you click on it, it'll give you this error that it says you can't run the browser with sandboxing enabled. So your OS doesn't allow you to do it. So you have to go to settings, Burp's browser, and then allow it to run without a sandbox. So from here, what we're going to do, we're going to click on settings, which can be accessible via this button right here. It can also be accessible up here through proxy settings. So we just do whatever, click on settings, and then underneath that, we need to click on the Burp browser, which is underneath tools right here. So you can see that, click on Burp browser, you go through here, and then there's going to be a button. So I'm just going to zoom out to make it a little bit easier. When we have the Burp browser, we're just going to go under, what is it? It says allow it to run using a, or without a sandbox or something. Oh, right here. Boom, it's right here. So allow the Burp browser to run without a sandbox. So that's good. And we can just close this. And now we should be able to open the browser. And let's see if it actually works. So let me make sure I click it. So I did click it. So I wonder if it works. Let's kind of shrink that down. There you go. So now we have it. I think it actually opened up 2. Yep, it did, because I double clicked. So there you go. We'll just close one. All right, so now we have our Chromium browser And great. So we're using the no sandbox stability, all that good stuff. Okay, so we have the proxy running in the background. The browser is officially open. And now we can go to the web application port, or the IP address, excuse me. So it's basically this. So the one that was assigned when I launched my victim machine or my web app is on that IP at port 8080. Now the port 8080 part is not going to change for you, but when you run this, you're probably going to get a different IP address. So just keep that part in mind. So as soon as I clicked enter, I don't know if you noticed, but there was something that popped up in the background, right? And so this is what we see right here. So it says you can actually go into it and log in as any of the users, right? So that's kind of the key element that we're trying to see right here. So using this, we can see what we can find. We'll see that there's a GET request right here. I can click the forward GET request and it should load the actual web page in the background, and it'll allow me to hopefully be able to connect to the, there you go. So there we got it. So I had to click the forward twice. So now I have username, I have password, and I think I have to do this multiple times until we get to the point where we want to get that post request. So I'm going to log in as this guy. So 77999, whoops, let's go back. So 0779999 1337 is going to be my username. Password is going to be pass1234. Press enter, and then again, we saw it in the background that there is actually a request that was submitted. So it's a post request now that we can see right here. So if I kind of pull this up a little bit so we can actually see everything. So we should be able to see the request as well as the response. So let's see here. Okay, so I logged in using the Chromium browser that it had, and I logged into one of the main accounts. So this is actually the Mozilla Firefox browser, I believe. So let's kind of shrink this one just so we can see both of them in the background here. So we have the second account. So this is the second account that I logged into, ends in 1111. And then we have the first one that I logged into that ends in 1337, okay? So when you land on the home page, you get these two buttons right here. And so you click pay and recharge, and it brings you up right there, right? So if I just go back to home, this is the one that we're going to be sending money to. This is the Firefox, and then this is the Chromium, okay? So in this one, just to kind of show you how we what we look like right here. So under the intercept tab, I just clicked forward when I did the login on, like, I think maybe 2 or 3 or 4 times, and it completed my login, and I ended up inside the application. When you click on HTTP history, you can see all of the requests that were made. So there was a bunch of GET requests, right? So GET login, and then it retrieved all of these various elements for us. And then we were actually able to submit our login via the post request. This is where we were actually sending our login information in there. So you can see the username and the password. And then it redirected me to the dashboard that we see here. And then this was the response for that request, that post request. So this was the set cookie for the session, and this is the cookie that we got. Dashboard, connection, keep alive, and the timeout was 5. And so I want to say this is, for now, this is like pretty much the most relevant information. And we got to the dashboard, and we are now inside the dashboard, and all of that is working, right? So we're technically here. Now, the next piece that we want to do is we just want to kind of test to see if we send $1 or something like that, what would end up happening, right? We just want to try to transfer the amount, or an amount that exceeds the balance and a small amount, like $1, to see how the system will respond in each case. So I need to first get this number, which I guess is their mobile number, I would assume. So we would paste the mobile number in here. We would paste the other same thing, paste it over here. And then first we want to send $1. So we'll just do $1 like that. And then we'll transfer it. And then we'll get something in the background in Burp Suite. So you can see there's a post request that's taking place. Target phone number is that phone number. Confirm phone number and amount is $1. And so that's what we got right here. I'm going to forward it, and it's done. So we'll go to the HTTP requests. We'll look at this request right here, that post request to send $1. and then we can see again the data that was submitted. So target phone number, confirm number, amount dollar, and it says keep alive, timeout 5, dashboard transaction successful is where we were redirected, and remix status 302, I guess, and all of that. And so on the request side, we can see that the content length, let me see if there's anything that's relevant to the actual time that's taking for this to process, because it doesn't seem to really give me much on the number of seconds or something that it took really to get there. Let's see what we can see over here. Status code length, extension, title, notes, IP cookies. It gives me an actual time value, which is over here, but it doesn't really tell me anything else. So let's kind of shrink this down, see if we can see anything else. And let's see. Yeah, so it doesn't really give me anything about the length of time that it took, at least on the surface level. I'm pretty sure I could try to find something if I kept digging into it. The page on the Chromium still says transferring right here. This guy still has its old balance. So if I maybe refresh the screen, okay, we see that we got the dollar transferred to this person. So $8.98. So they actually did receive the money sent to them. If I click on home, I wonder if this will load for me without doing a whole other thing in the intercept. It doesn't. So we need to forward these things so that we can actually get to our home page. So let's make sure we actually get there. All right, so now we're in the home page. Our dollar balance here is $4.55, and the HTTP history reflects all of those GET requests because I clicked on home multiple times, blah, 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 blah. Okay, so we were able to send $1 successfully. Now what we're going to do is we're going to send $10, right? So we're going to do the same thing. We're going to send it to that phone number. And what we want to do is we want to send $10 this time, which is going to be more than our limit. It's more than what we have available. So we're going to go back to Burp Suite. We're going to click on Intercept. We're going to forward this post request. And let's make sure that it actually gets there. So I'll forward it one more time. An application error. Interesting. So no user found in root loaded, but the user is required, etc. So the application gave us an error. So let's look at what happens over here with the request that we submitted. So this is the post request that had the $10 request, right? So that's the one. So we submitted that. The response after the fact gave us an insufficient balance data root response, and that was the session cookie that was assigned to it. And then we got another one that gave us a 200 response code, which was a success message. So the actual response itself came back fine, it seems, because it was a 200 response code. But the value of this, the message transaction declined. So that was the response that we got, and we got a good amount of data from this as well. Unexpected error occurred, note not found, unexpected error code, unknown error, etc., etc. So transaction declined is what we see inside of the URL at the top, and the message itself is insufficient balance. So that's kind of the key things that we can take away. So all right, so that makes sense, right? So we got that. The credit itself did not work because the balance was $4.54, and it should still be a week. But the thing is, this specific thing, it says that it gave us a successful reload of the web page when it actually didn't. So I'm just going to go back to the home page manually, and let's see if we can actually get into it by just forwarding that GET request and get ourselves back to the home page. Okay, so 455. And obviously, transaction was declined. We were not able to transfer that money. So now what we're going to do is we're going to use the Burp Suite repeater, right? So we can try to manipulate this whole thing and see what we can actually get done, right? All right, in order for us to get that final flag for this exercise, we need to get either of these accounts to basically have more than $100 in it. So since this one has 455, I'm essentially just going to duplicate this $4 by what? By 20? No, that would be $80. So let's say by 30, right? We'll do 4 times 30 repetitions, okay? And that's the whole idea here. So the first thing that we need to do is we need to redo another request, and we need to submit it as a a repeater request. So we need to first do a post request, and we need to send the $4. So we'll do this, we'll do this, we'll send $4, right? And then we're going to click transfer. Now it's going to be captured by Burp Suite, and we'll see it as a post right here. So what happens is that this post request is going to be created. I should see it on my list right here. This is what we have right here. So there we go. We have $4 submitted over here, target phone number, and then we have a $4 amount. So this request is the one that we're going to repeat because we want to make sure that we actually get $100 inside of our target account. So what we're going to do is we're going to send it to the repeater. You can also do Control R. And when you do that, your repeater highlights. So we click on repeater, and now we are here. So the next step that we need to do is we need to duplicate this, right? So when we send this to the repeater, right next to the received request tab, there's a little plus button, right? So let's go ahead and do that real quick. So this is the actual tab right here. So this is the number one. So we're going to click on this thing right here, and we're going to create a tab group, and then this will pop up. And you just got to make sure that you need to add this one, which is going to include our tab right here, which is that post request that has the $4. And we're going to create the group now. So now we have a group here, okay? Once the request tab, which is this number one, has actually been assigned to the group, which we just see right here, we can right click on this, and there you go. So there's the duplicate tab button. Now this is going to pop up, and it's going to allow us to do it ideally. So I'm going to duplicate this thing 30 times because I'm interested in sending, and then look at that. You see all of these things right here, right? So now we have these duplicated tabs that we can hopefully, ideally, go ahead and repeat. So what we can do now is we can click on send, right? So let's make sure we're actually on the group itself. And we can, once we click on the group, it has all the 31 duplicates in there. We can click on send, and it'll say send current tab, send the group in a sequence as a single connection, send the group in sequence as separate connections, and you can also send it in parallel. Now, based on everything that we've discussed so far, sending it in sequence most likely isn't going to work, and there is documentation, everything inside of the lecture portion of this that tells us that it's not going to work. So I know for a fact, and just to make sure that it does work in the interest of time, we're going to send it in parallel because that's literally what we want. We want to send everything at the same time to actually be able to pull this off. And that's what the documentation tells us to do ultimately. Because if we send it in sequence, either as a single or a separate connection, we are going to get failed responses. We're going to get failed requests, I should say, that are going to send it out. But if we send it as a parallel, if we send the group in a parallel, it will send everything all in one at the same time, and the processing time will be much smaller. When you send them in sequence, the processing time is typically half a millisecond. When you send it in sequence, it's about 3 seconds per request. When you send them as parallel, it's about half a millisecond per request. So it ends up being much, much faster. And all of them should be successful in this particular case. So what we're going to do is we're going to send all of these things in parallel, and we're going to just click it, and let's wait for it to complete. And it's completed. We actually got a response. It's a 204, which I think is in the series of successful responses. So we did have that. And if we actually go to the proxy, we should be able to see, I think, in the history of these things, or we'll go look at the documentation. But I do know that it actually has completed because we got that final response from our repeater in this particular case. And if we go over here, there you go. I already refreshed the page, but you can just click refresh if you don't see the balance updating. And now we can see the balance is updated to over $132. And now we actually have our flag to complete this specific thing, which is THM phone race. So why was this successful, right? This is the point of the documentation that we're going to end up having to do right here. So first, let's make sure that we get our flag, because that's a key element that we want here. So phone race, there we go. And so that's our flag. So let's go read through the documentation to see why this actually worked, right? So the instructions is basically what I just did. So we used the repeater, we sent the post request, it was captured. We forwarded the post request to the repeater. We created a group for it, right? So this is what they did, create the tab group. We added our initial tab to it. We duplicated it. They just duplicated it 20 times. I duplicated it 30 because I wanted to make sure that we actually crossed that $100 line. I could have probably done 25 and it would have still gone to $108 and we should have still been fine. But what we're doing is we're essentially, the key element here is once you've done the duplication, you need to send them in one of 3 different formats. You see in sequence, single connection, sequence, separate connections, or parallel, right? So if you do sequence in single connection or separate connection, on a single connection, it sent all the requests in tabs before closing the connection, and it can be useful for testing client-side desync vulnerabilities. When you send it over separate connections, it sends a request from the group, closes the TCP connection before repeating the process for the subsequent request. So when you do this, the screenshot shows 21 TCP connections because that's what they did on their end for this exercise. And the first group that was labeled 1 comprises of five successful requests, and they were successful by checking their respective responses. We can also see that they took around 3 seconds as indicated by the label 3 right here. So if we kind of zoom in on this a little bit, this is the first group. The section at the top, they were actually successful, and we can go to the responses to see whether or not they were successful. Where are the associated responses? I don't see the responses on this particular screen, but these were the ones that they said were successful, so we'll take their word on it. And then we can see that the duration on the right hand side here took 3 seconds on average, right? So it took at least 3 seconds to complete those. The next ones, the section 2 right here, these were the unsuccessful responses that came back, and these ones took a significantly less amount of time, right? So the second group, label 2, shows 16 denied requests. They were around 4 milliseconds. Interesting to check the relative start time as well, right? So that's basically what we have for this grouped version that was sent in separate connections, the sequence over separate connections. We can also see the whole TCP connection for a single request, and we can confirm that the post request was sent in a single packet. So that's very important to understand. It was sent in one packet. You can see it right here in this one line item. There were 21 requests that were sent inside of that one packet, but it was sent in one packet. But what happens in the parallel portion? So this is what we did and actually got the results, right? In the start column, we notice that there are 21 packets that were sent within a window of 5 milliseconds, right? Labeled as 1, as we can see right here. So all of them were sent within 5 milliseconds. So 216826 was the start one, 217371, so literally 5 milliseconds was the length of time that all of them took to send, not just one at a time. Each packet for the first example was taking 3 seconds each. All of the 21 that they sent over here were sent literally within 5 milliseconds. All of them were also successful, and they resulted in a successful credit transfer. And each request took about 3.2 seconds to complete, which was this portion right here. So the packets were sent in 5 milliseconds, but each one of them took approximately 3.2 seconds to complete. Okay, so this is what we got. Now, when you pay attention to it, you notice that each request led to 12 packets, which is what we see in this packet line right here. However, in the previous attempt to send in sequence, we see that each one of them had 10 packets. So why did that happen? According to sending the groups in HTTP requests documentation, when sending in parallel, the repeater implements different techniques to synchronize the request's arrival at the target. They arrive within a short time frame. The synchronization technique depends on the HTTP protocol that's being used. In HTTP2 or above, the repeater tries to send the whole group in a single packet. In other words, a single TCP packet could carry multiple requests. In HTTP1, the repeater resorts to the last byte synchronization, which is achieved by withholding the last byte from each request, so it's not sent incomplete, or it's not sent completely, I should say. Only once all of the packets are sent without the last byte are the last bytes of all of those requests sent. So it's very interesting. You can send up to 100. They will be sent all the way up to the last byte, but the last byte won't be sent. And then once all of them are sent, then all of those last bytes are sent. And so you can see that the post request was sent over 2 packets in this particular case. You have the TCP that was sent, and this is a Wireshark analysis that we're looking at here. And then we have the HTTP that was sent, and it was sent over a span of like a fraction of time. So it wasn't really that long of a time, but it was done in multiple packets that was sent. And inside of those, you had these individual bytes. So this is, it's beyond the scope of this conversation because we would have to dig deeper into packet analysis and Wireshark and networking in general and all of those things. But if you ran the exercise the way I ran the exercise, you should have received the flag that I received. And I don't want you to just get the flag just so you can get the answer. I want you to go ahead and actually run the exercise and do the repeater, create the group, create the duplicates, and send them as a parallel group just so you can actually get this response, because it is quite interesting and it's quite fun when you run something like this and it actually ends up working. So now we can move on to detection and mitigation. Detecting these types of conditions from the business owner's perspective is challenging. If a few users redeem the same gift card multiple times, it would most likely go unnoticed unless the logs are actively checked for certain types of behaviors. And these can be used to exploit even more subtle vulnerabilities. So it's clear that we need the help of a pen tester and bug bounty hunters to try to discover these types of vulnerabilities. So pen testers understand how the system behaves under normal conditions when enforced controls are actually enforced. The controls can be use once, vote once, rate once, limit to balance, limit to 1 every 5 minutes, and a bunch of other types of controls you can implement. And the next step would be to try to circumvent this limit by exploiting the actual race conditions. So figuring out the different system states that can help us make educated guesses about the windows where a race condition can be exploited. And this is where Burp Suite can be a really useful, handy tool. The mitigation can be done in a few different techniques. So you have the synchronization mechanism, which can be done by programming languages that provide these things like locks, right? So only one thread can acquire the lock at a time, preventing others from accessing the shared resource until that lock is released. Atomic operations refer to invisible execution units, which is a set of instructions grouped together and executed without interruption. This approach guarantees that an operation can finish without being interrupted by another thread. And the database transaction, which are multiple database operations that go into one unit, right? So consequently, all of these operations with the same transaction either succeed or fail as a group. And this approach ensures that data consistency that prevents race conditions from multiple processes modifying the database concurrently. So these are potential mitigations that you can deploy, detections that can be done. And again, this is beyond the scope of what you're doing, right? This is not something as a junior pen tester you're going to be responsible to do. This is the job of the senior pen testers, the job of the security engineers and the developers and all of the people that are going to be working on this. It's just that you need to understand these things. So I don't want to hear any comments of, hey, how do I do this and what do I need to do? Like, this is not your job. This is just so that you're aware of what's going on, right? Your job as a pen tester, or I should say as a junior pen tester, your job is to understand that these are the things that can actually take place and that they need to be accounted for, and they can cause a lot of damage and a lot of money and all of those things to a given business. So you need to work with the senior pen testers as well as the security engineering team to make sure that these types of race condition vulnerabilities are mitigated. So let's go look at this final challenge that we have. For this challenge, we're basically left to our own vices, and the goal is to transfer money so that we can get past a certain limit on an account, and then they'll release the flag to us. So we've learned about race conditions and various situations leading to them, system complexity, geographical spread, can lead to unforeseen situations, including vulnerabilities for race conditions. So it's vital that we first observe how the system behaves under normal conditions and then try to find out how it behaves when we try to exploit the timing. With the currently available tools, we have plenty of available techniques to try. I pretty much know exactly what I'm going to try, which is going to be exactly the repeater exercise that we just did through Burp Suite. And for the most part, it should be successful. So we have the machine that's right here. I had to cancel this machine, the previous machine, and then start this one. So hopefully it's available in the background. Sorry about the noise that my freaking annoying neighbor's kids with their stupid bikes. I really want to go ahead and destroy their bikes because they're just loud for no reason. Excuse my anger. I just got really annoyed real quick because I'm almost done with this recording, and then these guys decide to go right now at 8:35 and just start driving around on their stinking anyways, dude. Moving on. All right, excuse the anger. All right, so this is going to be the new IP address at that port. That'll probably be our banking application. We have 3 users that we can see we can transfer money back and forth from. And let's log into them to see what their balances are. Okay, so the first guy, Razor Kond, has $100 in his account. And he has favorite transfers already that are here as well. So let's see if we can log out and go check out what the balance of the other guy is. So we have 6282 and White Horse is his password. He also has $100, and so we can log out. I'm pretty sure they're all gonna have $100. So it's like, okay, well, what's the point here? So if we do, 9317 as the last guy, green, orange, and he has also $100. So, okay, so, I mean, that's pretty much it. So we're going to transfer the money into this guy's account, which is Warunki, I guess. And then we will go over here. We'll go to proxy. I'm going to clear all of the history of everything that's here, just so we can kind of start fresh here. So let's remove from scope. And what's going on? Let me delete these items real quick. Delete all these selected items. Yes, I am sure. And we should be starting fresh. We're going to go to intercept. We're going to drop this connection, which is that final connection. We're going to open our browser. And I did it again twice because I'm just click happy. And so we're going to now go to the web application itself, which is stored at 10.10.104.68 on port 5000. It's going to give me the request to actually process it. So let's go ahead and forward it so that we can log in. And this is what we got. So we'll start with this guy. So 6282 White Horse. And his request to log in should be submitted to Burp Suite. So we're going to forward it so that we can actually log in. There we go. No response received from the web server, of course. That's so annoying. Okay, so let's do that one more time. Let's see if we're actually logged in, because I should already be logged in. I don't know why it's saying that I have no response received. There we go. Okay, cool. So we're officially here, and now we want to do transfer to Warunki is what we're trying to transfer to. So we'll click on favorite transfers being Warunki, and then we're going to go back into Burp Suite, and we're going to forward it. And you could technically turn off intercept to be able to pull that off so that you don't have to keep doing forward and going back and forth. So you should be fine in that regard. So this is the key element right here, right? So the piece that we want to get to Warunki is going to be, let's say we're going to do $99 of a transfer. If you send 99, it sends him $4.95, and he's going to end up getting $94.05. So that's what the fee is for that. So if I send 99, he actually ends up getting 94.05. And if I just repeat that 10 times, then he will end up being over, because he'll get $940 and he'll end up being over 1,000, right? And then that should be the goal, right? It says after the account gets 1,000, we'll be fine. So we're going to click continue on this. Burp Suite is going to capture it, and we now have the request. We'll go to HTTP history. We have the transfer at the bottom right here, and the data that is being sent is 99, and he's going to end up receiving 94.05. So this is the one that we want to duplicate. So we're going to right click on that. We're going to send it to the repeater. The repeater is going to highlight. Then we're going to, I just want to delete this group. So let me delete this group, close all tabs in group. Yes, close all of those tabs. And this should be the request that I'm making right here, which is, yeah, this is the one that I'm making. So now I'm going to create a group, and we'll call it group 2. We're going to include tab 32 in there. And there we go. And now we're going to right click on this. We're going to duplicate this. We don't need to duplicate it 30 times, although that would be interesting. We'll duplicate it 10 times, which will give us a total of $940 that will be sent to Homeboy. We're going to click this drop down. We're going to do parallel. We're going to send it in parallel and cross our fingers. Okay, so the response came back with a 200 status. It was completed. Let's go and check his guy's account. We'll do a quick refresh. And does he have $1,000? He doesn't. He does not have $1,000. So let's see why. I wonder what happened. So it sent $476. And that's actually interesting. And the only way that I was able to actually find that out was logging out and logging back in, because refreshing didn't work. So that was interesting. I thought that it would send more money, but I guess we have to now repeat this another time. So we're gonna log out of this guy's account. Let me actually turn off intercept and log out of this guy's account. We'll log into Warunki, and he's gonna be the one that we're gonna end up using as the final passage here. So we'll do green, orange here, log in. So he has 476. That's fine. We'll go back here and we will turn, or let me actually click transfer to, who's this guy? So we want to send it to, we want to send 476, and we're going to send it to Rasser. So I'll send it to RasserCont. So we're going to log out of that guy's account. We'll log into Rasser. So 4621 will be the guy that we're going to be receiving the final money. So technically, I guess it repeated what, like, I think it repeated 3 times or maybe 4 times, because it went from 100 to 476. So he gave him 376, which is 4 times. So that was the 4 repetitions that I think it actually was able to complete for us. So if that's the case, we can now just repeat this, let's say 3 times, right? Just to keep within those confines, and it should be fine. So we're going to send the money to Rasser, and I'll click that. And now before submitting this, I need to turn the intercept back on. So intercept is now on. The proxy is running, and we're going to send $470, which will do 446 finally. And then if we just repeat that 3 times, it should be fine. So we received the request. We intercepted this right here. We're going to go to HTTP history. We'll go at the bottom. We have this request right here that's sending the 470, which ends up 466. Okay, perfect. Right click on this, send it to repeater, go to repeater. Now we have this guy right here. So we're going to do this. We're going to actually, no, I'm sorry. We're going to click this button right here. We're going to create a group, which will end up being group 3, include number 43 in there. And now we're going to right click on 43. We're going to duplicate it inside that group. And we just need to duplicate it 3 times. That's all we need. So we'll do that duplication, crash that, and then make sure we're clicked on this right here. And just to make sure that we're on the right one, it is 470, perfect. So now we're going to send this in parallel, and then we're gonna click on that and wait for the response, which should be a few seconds. There we go. And it says internal server error. And the server encountered an internal error, was unable to complete the request. Either the server is overloaded or there's an error in the application. Very interesting. So I hope I was in the right one here. So let's try it one more time. Let's see if it gives us okay, there we go. The second time it worked. And so let's see if we actually get this guy's funds. So we'll log out of RasserCon, and then we will do the 4621 login one more time. Let's see if it actually works. And he only has 546. So this is really interesting that this is actually not working the way that I thought it would. It's not sending all of the money. And I guess now we have to repeat this twice or something. Like, this is so odd that this is happening. So, okay. So this is fine. Let's go back to Burp Suite, and we will go to proxy. We will turn off intercept just so we can navigate appropriately. Transaction failed. See, that's the issue right here. So let's go to this. And he still has $476 though. How crazy is that? The transaction failed, but this guy still received $476 or whatever. What is it? 446. He received $446. That's so crazy that it failed. Okay, anyways. All right, moving on. So we're going to try it one more time because he still has $476. This is insane. So he still has $476. Burp Suite Community Edition error. Of course, there's an error. Please get back to my dashboard. Thank you so much. Let's go here. Let's turn the intercept back on. We are going to try this yet again. Before I do that, I'm going to go to repeater. I'm going to just close these groups right here. I just want to close all the tabs in this group. Yes. And we're going to go to group 2. We're also going to close all the tabs in that group. Yes. And then we're going to go to proxy, HTTP history. We're going to select all of these items. We're going to delete all of these items, and that'll be good. So that we're starting fresh, right? WebSocket, all of that stuff, we're going to start fresh. Where intercept is on. Actually, let's just get to the transfer page. So we're sending it to RazerCond, and let's make sure he still has 546. He does. So we're sending it to RazerCond. There we go. We're going to go here, turn intercept back on, and let's do this one more time. So I need to just send him not even that much. I just need to send him, we'll do 400 to keep it light. So $380. We just need to repeat that twice and it should be fine. So we're going to do continue. It should be captured in the back end. Perfect. So let's now go inside of this, go to HTTP history, click on our post request. We see the request. That's exactly the one that we want. We're going to forward this to the repeater. The repeater is going to be here. We're going to create a group and we're going to add it to the group. Perfect. And now we're just going to duplicate this once, I think. Oh, I don't even need to do that because it was duplicating it because it includes the first one as well. So if I duplicate it just once, it'll just have 2 groups. Maybe that was the issue that was happening. Because when I duplicate 3 times, it includes the first one, so it ends up being 4. Maybe that ends up being the issue. No clue. So we have these now. We have 2 different requests that are inside of this group, and we're going to send them in parallel. We're going to send group into parallel, wait for the response. We got a 200 response. That's all good. So let's go and look at this guy's account, and let's see if we got it. And seems to not be the case. So let's log out. Let's go back into Razer's account, which is what, 4621. Log in. Still has not been sent. So let's do one more time. The result seems to be false, which is interesting. I wonder why this is happening. And Warunki still has the 476. So this is what's happening. I feel like the second time that the error processed, it actually really didn't send any kind of transaction because it did give me an transfer error when I lifted the intercept. So then what we're going to do, I guess we're going to log out of Warunki. We're going to log in as RazerCond, and then we're going to transfer out of RazerCond's account and see if we can pull this off. Hopefully this will work because this is, now I'm kind of upset that this is not working. So let's go, and what was Warunki's login? It's the 9317 is his login. But see that it worked for this. So maybe, what is it? Is it Zavodny? Is the one that has the money? 6282? No, he only has $1. What the hell? That's so insane. I don't understand why this is not working because technically that's so frustrating, dude. Okay, so fine. Let's go and log back out. I'm just moving money around at this point, and it seems to not be working, and it's so annoying. Okay, so the transfer did work for this guy because the money is now gone. So this is what's really obnoxious now. Okay, so we want to go back into Warunki, and we're coming from RazerCond. So we're going to send him a total of $500 twice. That's basically what I'm trying to do here. And I am sincerely hoping that this is going to work. Actually, so $500 will end up being $475. So we'll do it 3 times. So we're going to duplicate the request twice. If this doesn't work, I'm just gonna be so upset, dude, because this should be working perfectly fine. So there it is. I'm gonna do that. We're gonna send it to the repeater. There's some kind of challenge that I seem to be having for whatever reason, and it's kind of upsetting me. No, it's not upsetting me, but you know what I'm saying. It's like it's frustrating. It's like why is this happening? I don't understand why this is happening. And I'm doing everything the way that I should have done it, or the way that we did do it previously, and it did work in some capacities. Just for whatever reason, the other pieces of it aren't working, and it's really kind of upsetting me. So I keep saying that, but it's really not. So duplicating it twice will end up giving us 3 of these tabs. That's great. We're going to make sure that we have the group selected. We are going to make sure that this is being sent in parallel, and it's going to send the group in parallel, and click. It's going to give me a response, and it gave me an internal server error. The server encountered an error. Oh man. And now the second time it worked, and it said the result is false, but it said it worked. So let's see what's going on here. The Warunki account still has $6.20 in it. All right, we're back in day 2 of this exercise. I did some Googling, and other people also ran across pretty much similar challenges to what I ran across. And there were a couple of items that, or comments that said people had to try this multiple times to try to make it work. So I don't feel as bad about it not working yesterday. I'm hoping to be able to approach this with a fresh mind and hopefully be able to actually make it work. This time around, I'm just going to use the Firefox browser with the Foxy Proxy extension. And so this is the extension that's available as an installation. There's a good series of tutorials that I put for Burp Suite that you can use to learn how to configure Foxy Proxy. But if you actually are using the attack box from TryHackMe, it comes pre-configured, and all you have to do is just turn it on the way that I did. You would go click on it right there, and then just make sure you click on Burp, and then it's actually turned on, and your browser will end up working. And then as long as Intercept is turned on over here, it'll start capturing those requests. So we are inside of Raser Khan's account, and from here we're going to send money to Zavodny, and from here we'll do $95 or whatever, $95, which will end up doing $90.25 in total. And from here we're going to turn on Intercept, and then I'm going to click continue, and the capture will be made. So the request is going to be captured in the background, and we're going to right click on this. We're going to send it to the repeater, and inside the repeater we are going to create our first duplication here. So we'll do a tab here. I'll make this the first one, and we'll start it with a red color, and we'll do a duplication of, let's see, I just wanted to see if it'll actually work properly. So if I do 2 duplications, it'll give me a total of 3 requests. So we'll start small, right? And then we'll go here, send it in parallel, and we're going to click send. And let's see if the server will respond appropriately. It gave us a appropriate response. So 200, okay, we sent 3 requests of, what is it, $90.25, right? So let's see how much ends up in the Zavodny account. So from here, I'm going to go to proxy. I'm going to turn off Intercept, and the request should have been completed. So if we go to log out, and we'll disable Burp Suite, go to log out, and it should log us out, and we'll go to Zavodny's account to see if money was actually transferred into his account. That would be great if it was. And so $90, so there was 1 request that was transferred into his account, which is, I guess, okay, because it should have transferred more, honestly, because it seems to have only transferred just 1 of the requests, and I thought it would definitely send more. For whatever reason, I thought it would send more, but it only sent that 1. So we will intercept back on. So we're gonna send to what, Warunki's account this time around, and we'll do intercept on. We'll make sure to turn on Burp Suite up here, and we're going to see if we can send that 190, which will be 180 final, and go over here. I'm gonna forward the request, or let's send it to a repeater first. Go to repeater, and we're just duplicating, or we're repeating the cycle just to see we can actually pull this off. Hopefully, I'm at this point I'm just trying to see what the potential limitations may be, how I can maybe do this more. Not exactly sure. It should be possible. So now I'm gonna do 20 requests, which will give me a total of 21 tabs, and we're gonna send them in parallel. I'm pretty sure it's gonna make the server crash, but let's see what it will actually do. It gave us a true response, so the server did not crash. So let's actually go and see whether or not this actually works. I'm gonna give it like a few extra seconds before I end the intercept to see how much of this actually works, because the request that I had, this transfer request, was the one that we just modified, and this is the one that has 180, and so I hope that that's the one. Yeah, that's the one with 180. That's the one we sent through the repeater. So let's turn intercept off. It's going to say transaction failed. Obviously, we will turn the Foxy proxy off. We'll go here, and we're going to try to log into Warunki's account, because that's the guy that we sent money to. Oh, wow, that worked. Holy cow. I can't believe it. Okay, I'm actually shocked that that worked. So I'm gonna take my win. Because that was it was like one of those like stressful situations. So this time around, it actually worked in 2 requests. I have done this multiple times since last night, and it did not work this quickly this time. So I would say duplicate what I just did if you want to make it work. And for a second, I was afraid that I wasn't recording, and I was like, God, I hope I captured this recording, but I actually am recording, so that's nice. So based on the stuff that I read when I was doing my research last night, and just the experiences of other users, there was no official, here's what you should do and here's what you should try and you'll get this to work. People just said that they had to try it multiple times. And then I tried this myself prior to recording. I tried this several times with a variety of different strategies, and the most recent one right before this recording, I had 6 attempts to send it to the repeater, and so there was literally 6 tabs up here for the 6 attempts, and they still were not working. And I don't know what it was that was blocking everything, and I tried 5 duplications, and I tried 10 duplications, and it didn't really work. So this is the very first time that I actually tried just sending. In the first one, there were only 2 duplicates that I did, and a total of 3 tabs were actually sent. And these were how much? So this was for 95, and then ultimately the amount that was actually sent was just 195, or there was like a one completion that was made, which was the $90.25. And then the second attempt that I did, I literally sent these 20, and I sent the whole 190 that I could, and the final amount was the 180. And out of that, it seemed to be that so it was like 1263 was finally completed. So let me open up my calculator to see how many of them actually went through, because if the guy's balance was 100 to begin with, and so 1263.50 divided by 180.50 is 7. So 7 of the requests out of this 21 actually completed, and we were able to get it. There were multiple times where I went through here and it gave me a server crash, like it was an internal server error, and the server crashed and didn't work, right? There were multiple times that it gave me a success message, a 200 success message. So let me kind of zoom in on this for you just so you know what I'm talking about. This piece right here, there were multiple times that the server crashed and it gave me a 500 error, or a 500 response right here instead of the 200 that you see right here. It gave me a 500 response and it said server error, right? Internal server error. And there were multiple times that it gave me a 200 okay, but the money didn't transfer. So the only thing that I can think of that may have worked this time around, was the reason for it working this time around was that I started with a small amount, and then the second attempt was a really, really large amount, like a number of duplicates is what I'm referring to. And finally we got the flag. So this is out of the, probably by now I have done like over a dozen for sure, including last night's attempts and including all the attempts that I made prior to starting the recording tonight. I have made over a dozen attempts, and this is the only one that actually worked, and it actually caught me off guard because I didn't think it was even gonna work. And now we have officially finished this room, and we are done with race conditions. This was honestly one of those things that I was like, dude, like I was this close to being like, you know what, F this, and I was just gonna go and steal somebody's answer from the internet and make up some BS of what I did to actually make it work. But you just saw it live, and you should have seen the look of surprise on my face, because I was like, oh my god, I can't believe this actually worked. So it worked. We actually finally got the answer, and we have done a series of exercises on race conditions, and this is actually a really interesting vulnerability to exploit. And I have never used Burp Suite in this manner, so this is actually something that I'm very interested in learning more about, because I think this is a very strong skill set to be able to do this with Burp Suite. And I almost want to go and see what I can do in the real world in HackerOne or some other type of platform where I'm like, oh, I'm curious as to what would happen if we were able to pull this off in the real world. And this is in Junior PenTester, which is the other piece that's actually very interesting to me, because this is not an advanced, or it's not supposed to be an advanced strategy. It's supposed to be something that the junior pentester or somebody who's studying junior pentester is supposed to be able to pull off. But I have done this multiple times. I'm literally creating a playlist for CompTIA Pentest Plus, and I've actually done pen testing in a variety of different conditions, and they were much more difficult than this. It's just that this required so many more repetitions than anything else that I've ever done to be able to get that final flag. So I think the big lesson here is the persistence and the perseverance that is required to be able to pull exercises off sometimes. Like some exercises will actually require you to persist, like for real. You got to stick to it, and you got to try multiple attempts. You got to try a variety of different tactics or different versions of the same tactic, I guess you can say. And maybe it'll work, or maybe it won't. And if it doesn't, you start back from the beginning, and then you keep trying until you get the flag, until you get the result that you're looking for. And that is a lesson of life. This feels like one of those things that it was very profound just to go through this, because it feels like a true lesson of life, not just pen testing and whatever. So anyways, hopefully you were able to pull this off. I don't want you to just steal the answer. I want you to try this as many times as it takes for you to be able to get that flag yourself. I think it's very important for you to get that experience under your belt and in your bones, in the cells of your body. I think that part of it is crucial. If you're just here to get the answers for the flags, I understand. I totally get it, because I was very frustrated and I almost did the same thing. But the feeling that I have right now is much more satisfying than having to go steal somebody else's answer for this flag. So I hope you also persist, and I hope you actually go through the exercise and you get to the flag yourself, and that way you'll be able to really walk away more confident than if you were to just steal the answer from me. But that's it. We're officially done with race conditions, thankfully. To get more videos like this one, and if you actually did find value in this video and from this channel, I really do encourage you to like, subscribe, and turn on that notification bell that's under this video so that you get notified the next time that a video comes out. As we go ahead and wrap up the junior pen tester, or at the very least, we're going to wrap up Introduction to Web Hacking, which has command injection and SQL injection, and then we're actually going to officially go into Burp Suite. For the people that have not seen the other videos on Burp Suite, we're going to go and do a deep dive of Burp Suite, so you'll really get a good training and good education on it. And I mean, drop a comment if you have any questions in this particular video, or really any questions about anything else that may be going on. If you just want to say hi, I welcome all the comments that come in. Unless you just want to be mean, and unless you want to say really not nice things, then don't leave a comment. You know, if my mom taught me, if you don't have anything nice to say, don't say it. So I'll say the same thing to you. I'm open to constructive criticism, but if you just want to be mean and if you just want to talk smack, it's like, I'd rather not hear it, and I'll probably just end up deleting your comment and blocking you from the channel, because I want to control my peace. I want to control my environment. But feel free to drop any questions you got. Feel free to drop any comments that you got. Feel free to check out the rest of the videos on the channel, the rest of the playlists on the channel. This is the one that we're building out right now. Every Friday, new videos from Pentest Plus drops. We've already finished Network Plus, so that's a complete playlist. Security Plus and Linux Plus are all complete playlists. People have gone through those playlists and have actually passed their examination, so I encourage it if it's something that you want to learn. There were very comprehensive trainings. The Python for Hackaholics Anonymous is reserved for our Hackaholics Anonymous members, which you'll learn about in just a few seconds. And these are also members-only videos and members-first videos that are available to Hackaholics Anonymous. So they get priority with all the posts that come in, and there are exclusive videos that are specific to Hackaholics Anonymous. So there's that. There's SOC Level 1, SOC Level 2, Security Engineering. There's the Cybersecurity 101. If you have not completed that, that's all really strong foundation in cybersecurity. And basically everything else that's on the channel. Feel free to sift and sort through the content to try to find anything that might be relevant to you. And apart from that, make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out on this channel. And I'm so happy that we were able to complete the race conditions video. So quick note from Hackaholics Anonymous, and we will be wrapped. If you're serious about your CySec training and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackers, and at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. In episode 15 of the Junior Pentester training series, we're going to go through the concept of command injection. And as the name implies, this is where we inject commands into a web application to get it to do whatever it is that we want it to do. And these specific vulnerabilities are actually very important vulnerabilities when we look at the OWASP top 10 list, which is the top 10 list of vulnerabilities that are exploited. This is a list that is put out by the OWASP people, and they do it every 4 years. So there was 2017, and the most recent one was 2021. And then in 2025, there should be another one that's released that will be the updated list. But essentially, whenever you look at any of these lists, the last like 3 or 4 different versions of this list, command injection, or I should say injection in general, has been one of the vulnerabilities that has been declared. It stood out a lot. The 2021 version of the list had injection at position 3 on the OWASP top 10 list. So it's a very important one. And then there are different versions of this, right? So as we'll talk about in this particular video, we're going to be doing, PHP and Python examples, but technically CSS cross-site scripting works, and there are so many different versions of injection attacks that will work. And then there's going to be another one that we'll do after this video for SQL injection, which is specific to databases that are housed on web servers. And this is just one of those topics that, as you'll see, it's actually kind of simple to wrap your head around, and it's extremely powerful. If you can learn to exploit it, and you do actually exploit it, it ends up being one of the most powerful tools that you will have in your arsenal of tools as a pen tester. So we're going to do an intro to this. We're going to talk about how to discover these, how to exploit them, how to remediate these types of attacks. And of course, there is going to be a practical exercise that we're actually going to implement it against a web server. And then you'll see how simple and easy it is and how powerful it is to be able to launch that. And then we'll do a conclusion, final thoughts, and then we'll wrap it up. This specific room is available inside of TryHackMe. It was created by CMnatic. So shout out to CMnatic. Thank you so much for your work and your efforts. And it's available on the TryHackMe platform, which means that we love this place even more. It is one of the paid rooms, so you do need a paid subscription with TryHackMe to be able to execute the commands in this room and to be able to access the virtual machine, all that stuff. However, I think it's totally worth it. I get nothing from this, but I just really love TryHackMe because they give us a controlled environment to do all of our attacks without getting into any kind of issues, any kind of legal trouble, as they say. But you can always just do this on your own machine. You can go through all of the content with the video, and then you can, of course, launch the exercises themselves on your own Kali Linux machines or any other type of machine, and mess around with them and implement them so you can kind of get the hands-on experience with them. That being said, a quick note from Hackaholics Anonymous, and then we'll dive into it. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into command injection. All right, so what is command injection? That is the first question here. It's essentially a vulnerability that you can manipulate and exploit on web applications, which allows you to inject commands, for lack of a better word, and to run specific service calls or pull data from a web application and do a variety of different things. And the limits really are narrowed down to a handful of things. And we'll talk about what all of those things actually are. So what we're going to be doing in this specific video is how to discover these vulnerabilities, how to test and exploit them using various payloads, and that's just a fancy way of saying using various commands that are designed for different operating systems, how to prevent them in an application, meaning how to mitigate them, how to remediate them so that somebody does not take advantage of them maliciously, and of course, how to actually apply it in a practical exercise. So command injection is just another way of saying remote code execution. So remote code execution is the technical term for these vulnerabilities when you find them in a CVE database, for example, the NIST database for the common vulnerabilities and exposures. And you're rarely going to see command injection as the term that's used. You're most likely going to see remote code execution. And they're saying the same thing, basically. So if you see RCE or remote code execution, just know that they're talking about command injection. And what it is specifically is us abusing the application's behavior to execute commands on or make system calls on whatever the operating system is, using the privileges that the application is actually running with. So for example, if we're logged in as Joe, or I should say, if the application is logged in as Joe, then whatever commands we execute are going to be under the Joe user, therefore using the permissions that Joe has. So depending on who is actually logged in, or depending on what system is logged in, you're going to be limited to the permissions of that specific user on the system. So We can use these attacks to, get user files or data, or make remote connections, meaning actually get a reverse shell on the machine and do a bunch of other things, export data, maybe steal money, depending on what kind of system you're actually dealing with. But you can use, for example, the command who am I to list what user account you're actually logged in as, and then from there you can try to find out what version of Linux is running or what version of Windows is running, and what the IP address of the server might be, and a lot of other things. We'll kind of mess around with it when we get to the practical section. So this was actually listed as one of the top 10 vulnerabilities reported by Contrast Security's AppSec Intelligence, and it's also a really big one in the OWASP framework. As I mentioned, in the 2021 version, it is number 10, or what am I saying? It's number 3 on the top 10 list. So it's a really, really big one. Injection in general is a really big concern, and we'll talk about how to mitigate it after we kind of mess around with it a little bit. So let's first talk about discovering command injection. The reason why these vulnerabilities actually exist is mostly because there was some kind of misconfiguration that existed on the web application's architecture or infrastructure, and it allows us to exploit certain vulnerabilities for the PHP language or the Python language or Node.js to be able to actually pass data to the application or make system calls on the application, or I should say the operating system of that specific machine. So if you take the input from a field, like a form that's on the site, let's say you're searching for something, so there's a search box on the site. So if you take the input from that and then use whatever that command would be, that would be running in the background to do the search, and then you just manipulate that search. So for example, if we look at this specific sample here, so this is basically a PHP script that's going to search for a song title inside of a list of songs, right? So the key elements here are, number one, the songs variable that is going to look at the database of songs. So inside of this location, there's going to be a bunch of songs. And then inside of this conditional statement, so we have one conditional statement that starts with this if portion right here, and then we have another conditional statement that starts with the if. So this is the biggest block of code, like the most important block of code right here that does the main function of this script. So first it's going to check to see if there's actually a title attribute, and if it is, it's going to get that title. Now this get request that you see here, this is where the script actually interacts with the web app and it makes a get request. This is an HTTP request that's being sent out to get the title from the list of songs that's inside of this location on the web server. And then once it gets the title, it's going to store it in the title variable. Now this piece is actually where the user would input the title of the song that they want to search for, okay? So this is the form, right? This is the form that the user is filling out. They want to search for a song. Now whatever they enter is going to be gotten. So it's going to be the get request is going to retrieve that, and it's going to store it inside of this title variable. And then the script starts to work. So the command itself is to search for, so grep is a search command, and it's going to search for that title, whatever the user input, and it's going to search for it inside of this text file that ideally it will have like all of the song titles that are inside of this song list here. And so if that song title now actually exists, right? So if the user, whatever they're searching for, if that song title actually exists inside of this list of songs, then this portion of the code is going to say, okay, the requested song title does not exist, or the requested song title does exist. That's basically it, right? So I don't want to break down line by line what all the 8 PHP code is and what it does and how to write it, rewrite it. That's a completely different video. It's just that we need to know what the function of this is. Now, the key vulnerability in this specific script is this piece right here. So this is the actual command that the server is going to be executing. And so we can manipulate this command, ideally, to be able to pull other forms of data from the web server that this application is housed on. So this is the piece that we're most interested in, because this would be the piece that we would end up manipulating whenever we actually get to that. So this is just the instructions that's going to explain exactly what I explained. So the output of this song title text will determine whether the application informs the user that the song exists or not. So this information will typically be stored inside a database. It's just an example of where an application will take input from a user to interact with the application's operating system. Rather than just using grep to search for the entry in the text file, we could actually get the application to read data from a more sensitive file, and it will actually do that later on as well. So abusing applications in this way can be possible no matter what the programming language. So this is a Python example of this, where we use Flask, which is just an interaction with a web server application, or web server, like a service provider, I should say. Flask is like a service provider that you can interact with, and then it's going to pull the name of the app itself that would be housed on there. And then we have two functions here. The first function is the key element of this, where it's going to return the value of this command right here, which is just opening a specific process. And then in this function, we see that it's going to make a call on this function. So every function inside of Python actually needs to be called on, otherwise it won't run. That block of code won't work. So in this function, we're actually running this function because we're returning. So return is basically just process whatever the command is and then return the response of that command for us to use later on. So in this case, we're returning this command, the value of this command, and then in this case, we're returning the value of this whole function, and then we're going to end up, ideally using it or manipulating it some other way. So we don't need to understand Python. If you want to learn Python, I have a really, really good Python tutorial that's on this channel. It's actually called Python for Cybersecurity, right? So if you actually go ahead and do that, then you'll get a really, really good education on Python, but that it has to be a whole different video. Essentially what this script is doing, the Flask package is used to set up a web server. A function that uses the subprocess package is executing a command on the device, and then we route that to whatever to execute whatever is actually provided. For example, who am I? And so if we wanted to do that in this particular case, right, with this thing, if we wanted to do that, where you see where it says /shell, right, that would be the path. Essentially, it's routing the /shell. For this case, it's actually going to be routing that. But if we wanted to route who am I, we would then just do, the name of the domain itself and then just /who am I, and that would end up being what's executed for this route that's being sent out. That's really all you need to know. So these are just a couple of examples to see where these things potentially may exist, and it's really just manipulating the commands that are being submitted to the web server, hence the name command injection, right? So we're injecting the command with our own command. We're manipulating the command so that we can go ahead and do it. So the question here says, what variable stores the user's input in the PHP code snippet? And so they're searching for a song title in this snippet, right? So this is the variable that will store the user's input, and then it'll get that title from the list of songs. So it makes a get request, right? So the title variable is the one that stores the user's input, and the HTTP method that's used to retrieve the data that's submitted by the user is that get request. And you need to, if you haven't gone through the CySec 101 playlist, this is kind of, I get a lot of these comments from people that are watching this playlist before going through those playlists. So if you haven't gone through CySec 101, some of the stuff that we talk about in Junior PenTester or in SOC Level 1, SOC Level 2, some of those things are going to go over your head because you don't have your foundations. So a lot of the comments that I get, usually I just respond to them like, hey, have you watched the CySec 101 playlist? And they're like, no. I'm like, okay, well, go watch that playlist first. You'll get all your foundations in that playlist, and then from there, you'll get a really good understanding so that you can work through these playlists. And they're inside of the CySec 101 playlist, there's a strong Linux fundamental series of videos that teaches you the fundamentals of Linux, because what we're going to do in the practical exercises of this video will have to do with Linux commands. So you need to know the basics of those things. And there are a lot of Linux videos on this channel. The very first one that I put out, it was kind of tongue-in-cheek. The commands in that video are really solid, but in the intro, I was referring to Linux as a language, and then everybody, like so many people came for me in the comments and they're like, you don't know what the hell you're talking about. And, you know, Linux is not a language. And they're right. Linux is not a language. It's an operating system. And Unix is not a language. It's also the initial framework upon which other operating systems were built. So for example, Mac OS was built upon Unix and Linux was built upon Unix. So these aren't languages, but I misquoted that, and so people thought I didn't know what the hell I was talking about. I still left the video up because like the commands that are inside of that video are really strong, and you learn a lot from those commands. And it's a condensed version of the Linux Plus playlist, the CompTIA Linux Plus playlist, which is a really solid playlist. That one's like my pride and joy when it comes down to Linux, anyways, because people have actually taken that playlist and they've studied it and they've passed their CompTIA Linux Plus examination. So that's one of the things that I think is very, like, it's a really, really solid playlist. But anyways, you would have to learn things like that because I'm not going to be really covering the foundational details in this video. So anyways, if you wanted to execute the ID command in the Python code, then you would need to go to /ID, because the example here says if you wanted to execute whoami, you would go to /whoami, right? So that would be what you would put routed inside of this specific script right here. That what we'd need to route to that location to be able to pull off the ID command, right? So now that we have understood that, let's talk about how we can actually exploit that. So first and foremost, just trying to find out whether or not the application is vulnerable, we can do by just running some test commands, right? Just some basic commands to see if it'll even respond. And if it does respond, then you can conclude that it's vulnerable, right? A lot of times what will happen is you can just add, or we can call it concatenate. You can actually add an extra command to the end of whatever the valid command would be, just to see if you'll get a response. And the way that you would do that addition would be through the use of shell operators. Now, the one that I found that's like most consistent across pretty much all the operating systems is either the semicolon or the double ampersand, which combines two or more commands together, and then it'll actually execute both of them. So, you know, you have one line of command that you're writing, but then in that one line, you have command A, and then you would do semicolon, command B, and then you press enter, and then the system will run both of those commands. It'll run command A first, and then it'll run command B. So this is how you can really essentially just pull it off and actually exploit this specific vulnerability. It's not complicated. You're just trying to see whether or not it exists. And if it does exist, then you're off to the races and you can do whatever you want. We're going to be running Linux in the example that we're going to be doing in the practical section. So again, it's really useful to go through the Linux fundamentals module. If you have membership with TryHackMe, you can do that. If not, just as long as you have either a Mac computer or you have access to a Linux machine, you can just go through the CySec 101 playlist, and I have the Linux fundamentals videos. There are 3 videos at the beginning of the playlist. I think it starts with episode 4 of CySec 101, where Linux fundamentals begins, and there's a bunch of stuff, and we'll cover this later on as well. Towards the end of the video, I'll just show you how to search for these things and how to find them. But there's a lot of stuff about Linux that's on this channel that will definitely get your foundation set. And I would encourage you to go through that so that any video apart from this one, because this one we're not going to do crazy series of Linux commands, but it does help to know them. But for future videos, as we go further along into pen testing, Linux is one of the key operating systems that's used in pen testing, specifically the Kali Linux distribution that's designed for pen testing. And so this is just one of those things that you got to get really, really good at if you want to be in pen testing. You just got to get good at Linux. So command injection can be detected in one of 2 ways. You have either blind injection or verbose injection. Now, blind injection, as the name implies, you don't get a response on the screen. So you have to try to find some other way to figure out whether or not your command worked. So that could be a Python server that might be listening, or it could be a Netcat listener that might be listening, or you could be running Wireshark in the background to see if the connections that you're making are actually doing something. But it's blind, right? So there's no direct output from the application onto the screen into your web browser that you'll see the output and you'll be like, oh, okay, it's working or it's not working. So it's blind. You have to figure out some other ways to see whether or not your attack worked. Verbose is the type where you actually get direct feedback from the application on the screen, right? So once you've tested a payload, basically another way of saying of running a command, so who am I, that this specific command would end up being the payload in this case. So when you run it, you'll actually get the application's response onto the screen and it'll say, this is your username, this is who you are, right? So that's verbose output. So detecting blind injection, whenever you can, you would do so through some other type of strategy. So for example, you can run ping, right? So when you use a payload that will actually cause some kind of a time delay, for example, ping or sleep, right? Or the combination of ping and sleep. These are actual payloads that you can use to test to see the time delay, right? How long of response or how long will pass before the server responds. That would end up being it. So using ping, the application will hang for a few number of seconds in relation to how many pings you've actually specified. So for example, it'll send a ping for every second. So if you do ping 10, it'll send 10 pings, which would mean that it would take about 10 seconds for it to complete the ping command, right? So another method would be by forcing some kind of output, and this can be done using the, I guess you can call this like the forward arrow or the greater than symbol, which is used to take the output of a certain command. So for example, who am I? It'll take the response of this and it'll put it inside of a text file. And again, this is inside of the Linux video, so you can just see examples of this. And then when the output of this command is inside of the text file, you can use a command like cat, which basically just reads the contents of the text file and displays it onto the screen, right? So that's basically what it is. So we can then just use the combination of these things to see if it actually works, because if a text file is generated, that means it worked. And then you can just read the contents of the text file, right? Testing command injection is often complicated, because especially in the blind injection, right? It's often complicated. It requires experimentation, and the syntax of the commands will vary between Linux and Windows. So the curl command is another one of these things that you can test for blind injection. And it's mainly because we can actually use curl to deliver data to and from the URL. And this could be as an example of it. So if you see right here, this is a URL encoded command that's being sent. So if we wanted to see what it is, we can actually just go to CyberChef and we could decode the command that we just saw right there. And it's pretty good usually for doing like an automatic detection for what it actually is. So as soon as I pasted it, this little thing popped up to the screen, this little magic, wand. So if I click on that, it'll then decode it. So what you see right here, this %3f is actually a question mark. And then search the Beatles. So right after search, there's %3d, and that's the equal sign. And then there is %20, which would be the empty space. And then we have Beatles, etc. So the key piece of this is that this is the URL itself, right? So the HTTP vulnerable that's the actual URL. And then when you go there and you search for something, then the URL will change, and everything after the question mark is the query that's being sent to the URL. And so in this query, we're querying the database to search for the Beatles. And then after that, we put the semicolon, and then we put who am I. So now the system is going to actually execute both of these, because remember, if we do the semicolon, we're now combining the commands together, and the system will actually process both of them. If it's been misconfigured, it'll actually process both of them, and it'll say whether or not the Beatles exist and who we actually are inside of that server. So that's what it looks like when you just run a curl command inside of your terminal, right? You can run the curl command inside of your terminal to see if you can actually get a response from the web server inside of your terminal. And this might be the best way to do like a blind test for a specific web server to see if the actual web server is vulnerable to blind injection attacks. Now, verbose injection is way simpler because it literally just prints it onto the screen. So if it actually is vulnerable to it, whenever you do something, whenever you actually inject something into it, it'll give you feedback or output onto the screen as to what's actually happening and being executed. So for example, the output of ping will actually be executed, or the output of who am I will actually be executed, directly displayed on the web application itself. Now, based on the operating system, you will have a variety of different types of commands you can run. So for Linux, who am I will get you what user you're running under. ls will list the contents of your current directory. Ping, so if you want to find files or environment files, whatever, you can use ls for that. Ping is the command that's going to invoke the application to hang, right? So this will be useful in testing for blind command execution. So if you ping with 10 packets, it'll send out 10 ping requests, so it'll take about 10 seconds. That will be the hanging part. It'll kind of freeze in time for 10 seconds. Sleep can be used in conjunction with ping, and it's just another useful payload to test to see whether or not it's vulnerable. And if you don't have access to ping, you can just try to use sleep, because that's kind of like a pre-installed, it comes pre-configured, right? Sleep is pre-configured in most Linux computers, and you don't have to worry about installing it. So if there is no ping, you can just use sleep and then do sleep for 10 seconds or 5 seconds, whatever, and it'll respond. And then we have netcat, which is used to spawn a reverse shell onto the application. And if this actually succeeds, you literally have a command line connection, a remote connection to the application, and then you can navigate around the machine and just literally click around and type around as if you were already inside the machine. You don't have to do what we're going to have to do inside the practical exercise. You don't have to actually do that. But anyways, the Windows version of these things, so who am I ends up being, what user you're running under. dir, dir, will list the contents of the directory. So this is similar to what ls would do. Ping is the command that will invoke the application to hang. If ping doesn't exist, you can do timeout, very similar to what sleep would do. And then for Windows, netcat does exist, but essentially any executable is followed with a .exe. So it's not just nc, it would end up being nc.exe inside of Windows, and then the rest of the command will end up being very similar to what you do inside of Linux. You just have to do the .exe to call on netcat. So what payload would you use if you wanted to determine what user the application is running as? That would be who am I. What popular network tool would you use to test for blind command injection on a Linux machine? That would end up being ping. And what would you use to test on a Windows machine for blind command injection? That would be timeout if you don't have access to ping, right? So to test a Windows machine for blind injection, you could just use timeout if ping was not available. Now, how do we remediate these things? When we're talking about injection in general, one of the key elements, or I should say two of the key ways that we can remediate it, is either through sanitizing the actual input that's being submitted by the user, or just turning off certain functions that end up being malicious or they can be used maliciously. So for example, in PHP, there is exec, which will execute something, pass through or system. These are commands that can be maliciously used, right? So if that's the case, then what we need to do is we need to either completely turn them off, right? So not diffuse them. What's the word that I'm looking for? I can't believe that my brain just farted and I forgot. Disable, there you go. You want to disable them. So you either want to completely disable them or you need to create some kind of filtering mechanism. So in this particular case, the filtering mechanism is that the pattern that's allowed, right? So in the input type that we're sending, the pattern that's allowed is 0 to 9, as you can see right here. And that plus sign just represents that you can have as many digits as you want, but it wouldn't accept any other form, meaning it won't accept alphabet characters. It will only accept numeric characters because you're only supposed to enter numeric characters in this specific field, right? So if you try to replace it with who am I, or if you try to concatenate who am I, these are alphabet characters, so it will not be accepted. The application will only accept a specific pattern, which is the digits 0 to 9, and it will then only proceed to execute that data, which is all numerical. Otherwise, it will not execute anything else. So these functions take input, like a string or user data, and they'll execute whatever is provided on the system. Any application that uses these functions, we're talking about these functions right here, any application that uses those functions without proper checks will be vulnerable to command injection. Then we have input sanitization, which is by far the most common. So turning off functions is also very common, so I shouldn't say that. But input sanitization and disabling those key functions, or at least configuring those functions with filtering mechanisms, those are very, very important. So sanitizing basically means specifying the formats or types of data that a user can actually submit. And if they try to submit anything other than what's allowed, the system will just wipe it. It'll sanitize it, clean the command, and then only process the stuff that's allowed. So if an input field that only accepts numerical data or removes any special characters like the output, the arrow forward, ampersand, or forward slash, all those should be removed, right? In this specific snippet, it's going to check whether or not the data submitted is numerical or not. So if it's not a number, then it would be invalid. So everything other than this exclamation right here. So when you see this exclamation, that typically means not. So if you see if exclamation command, what it's actually saying is that if it's not this command. So now we have the actual command. So filter the input, get number, whatever, validate, right? So if it's not a command, if it's not a number, right? That's what this basically is saying. If the filter that we do is not a number, this is what the exclamation means, then, don't process it, right? If the exclamation wasn't here, what this statement would say, if it's a number, right? So in this case, we're just saying if it's not a number, then do XYZ or deny them from running it. Applications will also have filters, They'll also have filters and sanitizing data that is taken from the user's input, and they will restrict you to specific payloads, meaning as an attacker, because there are filters in place, you'll be restricted to specific payloads. So for example, there could be a filter that says, quotations aren't allowed. So you can't use quotation marks. It'll strip it out of the actual command. So you can use hexadecimal values of the quotation. You can go to a tool like CyberChef, put the actual command up here, and then use one of these things to convert it into hexadecimal, right? And then all of a sudden, now you see that it's been converted into hexadecimal. Curl, all this stuff, literally it's been converted into hexadecimal. So when you get to see things like this, you can actually potentially, and we call this low-hanging fruit because this is still misconfigurations that are done. So, if somebody simply has, okay, we're just going to strip out quotation marks, technically you could put two sets of quotation marks and the first set will be stripped out, the second set will be accepted, something like that. Or what we did in the cross-site scripting video, the word script, right? So this is what it looked like. So the configuration was done so that you can't actually use the word script, right? So it would strip out anything that actually has script in it. So what we did was we did S at the beginning and then we did crypt at the end. So when this portion was taken out, then we would end up with the word script. So again, very, very easy little configuration that we had to do, and it's a low-hanging fruit that we were able to get access to. So these are the stuff that are relatively easy to do. And so if you know that they exist, or even if you don't know that they exist, you actually should try it because it's low-hanging fruit. And then if you don't get a response, it's like, all right, you can move on to something more advanced. So what is the term for the process of cleaning user input? And that is known as sanitization. So when you think about cleaning input, sanitizing, right? You need to sanitize your house, right? You would sanitize the input from the user as well. So now we get to have some fun and we get to go through the practical exercise that's available here. All right, so I've deployed the virtual machine and we basically are going to have access to this right here. And it's really just it's going to do a ping, right? So we do the IP address, which is 127.0.0.1. It'll do a ping to that IP address. And then we can try to manipulate whatever command is actually sent out to it. to be able to get access to the answers for these two questions right here, right? So we're going to first get the username that we're running as, and then we're going to run the command to find the flag. So if I go over here and just do the first command, so if I do the 27, and you can see all the previous ones that I had are already there, so you're kind of getting like a little sneak peek. So this is the original command. I did this, and then the response was ping 127, so we know that it's running a ping. And then we have all the pings, and then right here it says 4 packets transmitted, 4 received. So on average, it'll take about 4 seconds for this thing to process. So now I know what's going to happen when I actually just press execute here, right? It's going to just do a ping right here. So if I go ahead and now do this, so if I do 127.0.0.1, and then I'll do this just to make our lives a little bit easier, and I'll just copy that. So 127.0.0.1 at this point, now I can just kind of paste this and then just put any command after the fact. So we could do, you know, anything here at this point. I could do pwd to do a print working directory to see what directory I'm already in, which is typically what I like doing just to find out where I'm at. And so now we can see at the end of the ping, we now have another value that's been added. So we're actually inside of the var www html directories where we're at. Okay, cool. So we know that command injection actually works. So I can do this now, and I can do who am I? I want to see, I misspelled who am I? I want to see who I am as a user. So I'll do this, and I'll do who am I? There we go. Now it should actually give me my username at the end of this whole thing. And there you go. We actually see the username. We are the www-data user. And it's like, okay, interesting. So let me see what users actually exist, right? So this is kind of like one of those things that we can do to look at sensitive files, right? So boom, and then we will do cat, and then we'll do the Etsy password file. So if I can actually see all the users that exist on this machine. So we have www.data, and then boom, look at that. We have root here, we have the daemon, and all these other users that actually exist. Now, they have all been separated to their own sets of lines. So if you don't recognize what the Etsy password file looks like, this is the root user. This X is a placeholder for their password hash. So we're not actually going to see the password inside here. It's kind of misleading. The passwords would be inside of the shadow file, or the password hashes would be inside of the shadow file. And then we see, you know, this is where their actual folder is, their root folder for the user is. This is the path to their shell or their bash, and so on and so forth. And so this is the same thing for the daemon user. And then the next one would be for, what is it, the sys user here, the sync user, the man user, etc. So we can actually go ahead and find, oh look, www.data. That's what it is. And then the bin for their user and the shell, etc., etc. So you can, now we actually get to see pretty sensitive information here, which could be very, very useful to us. So, okay, so now we need to go get access to the other bit of sensitive information, which is that password, or not password, the flag that we want, which is on the home TryHackMe flag text file. So we'll do this, and then we'll do cat again, home TryHackMe, and then we'll do flag.txt, just like that. Now we're just executing this command to be able to read the contents of this file right here. And boom, there you go. There's the flag, just like that. So it's not, again, not complicated. Like, once the vulnerability exists and you know what you're actually doing, then you can go ahead and just get a bunch of information. So you can actually do this with a combination of commands, right? So the first command is technically the 127.0.0.1, right? And so that one ends up running ping. So we do the semicolon to separate it, and then we would do a second command. So let's say I will do cd to change directories, and I want to go into the home directory, or the very root directory, which is represented by the /, and then I'll do another semicolon, and now I can actually just run the contents of this. So I could do ls/la, right, to list all of the contents of the cd, or of the root directory, and I want to see what the extra details are, and if there are any hidden files. And now we get to see a bunch of really interesting information. So everything after this portion, because this is the ping, right? Everything after that portion will end up showing, or I should say this, everything after that will end up showing all of our content. So now we have the what is it? This is a directory that gives us read, write, execute, and read permissions for the initial directory. Then the group permission is execute and read, and the user permission is execute, and that would be for everything, I guess. And then we have the root, right? So this one, it's a little bit hard to read like this because I forget what the formatting is. When you actually look at it inside of the terminal, it's a little bit easier to read. But I can do the same thing, and I can just do ls just so I can see what is inside of this location, and it might be a little bit easier to kind of narrow it down, because when it just shows you, all right, so there you go, you have the binary, the boot, dev, etc, home, lib1, lib32, 64, libx32, lost and found, media, etc, etc, etc. So it shows us all of these things, right? And so that flag that we found was actually inside of home for the TryHackMe user. So maybe we can do this. We can go to the home location, and then we can also do an ls here to see what we have inside of the home location. So how many users exist. So we can see that TryHackMe is inside the home, and then we also see that Ubuntu is inside of home. So then I can do this. I can go to cd, or we can just kind of shortcut it, and we can do ls, and then we'll do /home /Ubuntu, and then just to see what's inside of the Ubuntu directory for that user, right? And then we can do that, and there's something called scratch in here. So okay, so let's do this then. We can do the same thing. We'll do ls-la, and then we'll do home Ubuntu, and see what permissions or what is available for this scratch file that's in here. And there's a bunch of stuff that's in there, because there's also the hidden stuff that's in here. So hidden, so the Ubuntu is a directory, it seems, and it's something that is accessible, I want to say. So it is a directory, so technically, and inside of the, actually not, I'm sorry, not the Ubuntu, we're looking for the scratch one. So where is scratch? Let's see if we can find scratch on the screen. Okay, there we go, there is scratch on the screen. And there is the users, obviously, that is Ubuntu that use it. We can actually, it's a directory, and there's a bunch of stuff inside of it. So, okay, so let's go and see what we can find inside of that. So if I do ls and I do home, Ubuntu, scratch, let's see what's inside of that thing. And we can see that, oh, nothing. So nothing actually came. So I guess it's empty. Or maybe we don't have permission to view it. But you can see, right? You can see that we can actually interact with the web server, and we can interact with all of the contents inside of the web server according to what our permissions are. So if I really wanted to kind of get like really good recon going, first I would do who am I, right? Which I already did to find out what my user is. Then I would do host name, because I want to see what my computer's IP would be. And so there we go. This is actually the IP. The 10.10.218.113 is actually the IP. It's not the 127.0.0.1. 127.0.0.1 is like the loopback IP address, right? It's the local, and that's on every single machine. There's always a 127.0.0.1. So that doesn't really give us anything. What we're really interested in is this information. So I could even do this. I could actually do ifconfig, because it's a Linux machine based on what we found. Or you know what? Instead of assuming that it's Linux, I could actually do this. I could do uname and see what it actually is. And then it'll spit back and it's like, oh, it's a Linux machine. Okay, great. So now we can do this. We can do ifconfig and then see what IP address information we can pull from this specific machine. Ooh, it doesn't let me do ifconfig. How interesting. Okay, so let's see. I mean, that's so interesting, because it should let me do ifconfig. So if I do ipconfig, it also doesn't let me do that. All right, fine. So now I can definitely do the uname information, or I did already do the uname information because it gave me Linux, and I did hostname. I could do uname-a and see what other information we can pull from this. And there you go. Now we have extra information, right? So it gives me Linux, gives me the IP address, it gives me the version. It's saying it's on AWS. Ubuntu is the distribution, the timestamp. Very, very interesting. Architecture information, right? Like really, really interesting information. So it's almost as if we're already connected to that server, but we're not. We're just using a web portal to execute this. So this is kind of how it's done. And as long as the vulnerability is there, you can see how relatively easy it is to exploit this thing. So that was it. Pretty straightforward, pretty easy to do. As you just saw, it's really not complicated. Like, most things are not overly complicated. There's a lot of low-hanging fruit, as this exercise showed us. And there are a lot of developers that don't have a security background. So they're really good at coding, they're really good at setting things up for it to function, but they may not necessarily have the perspective of a security person. Therefore, they may leave certain things misconfigured, and then us as hackers will go ahead and exploit those things. So this is where it comes super handy to just, at the very least, try to get all the low-hanging fruit. And then from there, you can become more and more advanced with your hacking techniques and tactics. So in this video, we talked about what command injection was. We talked about how to find them, how to exploit them, how to solve them, or like remediate them, right? And we even ran through this pretty cool exercise where we attacked this little web server and we were able to find a bunch of interesting information. We found the flag that we needed to find. We found the user we found the host name, we found the IP address, like all of that good stuff. And again, super handy if you know what you're doing, if you know what you're looking for and how to run the commands for that specific system, etc. So I hope you found value out of it, and I hope you had some fun with it. If you were using TryHackMe, hopefully you were able to find the answers and get the answers the way that I got the answers. So don't just watch these videos just to steal the answers. Watch the videos to learn how to find the answers, right? The key here is to learn how to do the work, not just get the answer. That's kind of like the big piece, that one of my big goals when I go through these videos. I just want to teach you how to do it yourself. And obviously we'll find the answers together, but I'm more interested in teaching you how to do it. So yeah, that was it. If you got value out of this video, and if you would like to get more videos like this one, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. Drop a comment if you have any questions about what we talked about today, or if you just want to say hi, or if you have any other questions, just definitely let me know. There's a lot of stuff that's already on the channel. So earlier I was mentioning that you can go find the Linux stuff. So you can literally come to the search box here, type Linux. Let's do Linux fundamentals, right? Or let's do like Linux basics even. We'll do Linux basics, and then you'll get, become a Linux expert. This is the video that I was talking about that a bunch of people like talk smack to me for, because I was referring to Linux as a language. They didn't go through the commands, right? They just saw the first 2 minutes of the video. They're like, oh, this guy doesn't know what the hell he's talking about, which I understand. I get it because I referred to it incorrectly, but the commands were really good. And this was like the first official video that I launched on Linux 10 months ago. Wow, it hasn't even been a year. So much has happened during the last 10 months. And then there's the Linux basics stuff, right? So Linux basics, obviously the CySec 101 playlist that has all those things. There's a 2.5-hour Linux tutorial for beginners that exists here. And then of course there's the CompTIA Pentest Plus, or what am I saying? CompTIA Linux Plus. So if you go to the homepage, and you can actually also find it under playlist. So if you go to the playlists page, this is my gym playlist. You won't be able to see that, but you'll be able to see CompTIA Pentest Plus. You'll be able to see Network Plus. You'll be able to find all of the other playlists that exist on this channel, which is a lot of stuff. The most popular ones are the ones that I actually put on the homepage. So the stuff that you see here are the most recent that are being created, but they just happen to be the most popular. So I'm building out PenTest Plus right now. Every Friday, a new episode comes out for the CompTIA PenTest Plus. We have the Network Plus, which is complete. There are 6 videos. They're long videos. So the reason why you see 18 right here is because for every chapter that I'm building, I put out a video. So each one of those videos is about an hour and a half. The videos in this one are 5 hours plus each video. And then we have the exclusive playlist for Hackaholics Anonymous, Security Plus, Linux Plus, CySec 101. This is where I tell people to start with, and then from there you can go into either Junior PenTester, or you can go into SOC Level 1, depending on which path you want to go, either offensive or defensive. But always start there. If you don't know your basics, everything else is going to be very difficult for you. People that have taken the Linux Plus or Security Plus or Network Plus courses through my channel have actually passed their examinations just by going through the videos, right? If you don't want to get the notes through Hackaholics Anonymous, or if you don't want to get the practice questions through Hackaholics Anonymous, you don't have to join Hackaholics Anonymous. Just the contents of the videos have helped people pass their examinations. So it's good stuff, I'm telling you. I'm not saying it to like toot my own horn. I really put a lot of time and energy into those things, and they're very, very solid. Members only for Hackaholics Anonymous, SOC Level 1, SOC Level 2, Security Engineering. So there's a lot of stuff on this channel. There's currently 381 videos. By the time you see this video, there will probably be more than 381 videos. So there's a lot of stuff, and there's constantly growing. I post at least 4 to 5 times a week. I record on weekends, and I schedule them out to come out during the week. So Monday through Friday, you can expect to post, and there's constantly new stuff coming out. So all of that being said, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. If you're serious about your CySec training and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. In episode 16 of the Junior PenTester training series, we are going to go through SQL injection vulnerabilities and those types of attacks. And this is actually the last video in the web hacking portion of Junior PenTester. And we're going to be talking about how to exploit the structured query language databases, SQL databases, how to get access to information that we should not have access to. And of course, we're going to run through some practical exercises and remediations, all that good stuff. My name is Hank Hackerson. I will be your trainer for today, and we're using the TryHackMe platform. Now, this particular room that we're in is actually a free room inside of TryHackMe, which means that anybody that's inside of this room with a free member account, you can go ahead and deploy the virtual machine. You can run through all the exercises that we're going to run. So really, really exciting, really, really cool. And I'm so glad that it's actually this room that's one of the free ones, because SQL injection is a really cool freaking attack that you can do if you learn how to actually do it. So as a part of the contents of this video, as an overview, we're going to talk about what an SQL database actually is, or we should say, what is a database in general? Then what's SQL, right? The structured query language. And then what is SQL injection? We're going to talk about in-band SQLI, blind SQLI, and of course there's different versions: authentication bypass, Boolean-based, time-based, and then out-of-band SQLI, and then of course how to remediate it. Shout out to Logic. I want to say that's how you pronounce it. It's like Logic or Logic, whatever. That guy, or person, I should say, that person for creating this room for us. Shout out to TryHackMe for allowing us to use it for free. I love TryHackMe. I've learned a lot from these people, and I highly recommend that you go create your own free user account so that you can get access to rooms like this. There's like hundreds of free rooms inside of TryHackMe. And then of course there's the paid subscription, which is totally worth it. And I encourage you to get that as well. All right, quick little note from Hackaholics Anonymous, and we'll jump into it. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into SQL injection. All right, for a quick brief, SQL, so the structured query language injection, is mostly referred to as SQLI, and it's an attack that you do on a web application's database server, and it causes malicious queries to actually be executed, right? So you can actually pull information about their customers, the customer usernames and passwords and credit card numbers, whatever, right? So when a web application communicates with the database using input from a user, so there's a form, a search box or something that you can input something into, and it has not been properly validated, there runs the potential of the attacker being able to steal, delete, or alter private and customer data, and also attack the web application authentication methods to private and customer areas to actually gain access to those areas. And this is why SQLI is one of the oldest web application vulnerabilities, because databases have been around for a very, very long time, and they've been housed pretty much as long as the website had a list of users. Databases were around since then. So you can imagine, like, I mean, pre-MySpace, like, I don't know what it was, but there was definitely very, very old websites that allowed people to create user accounts. As soon as you create a user account, you go inside the database in the web application server or in the web server. And then from there, that's where the database is built. And then now you can do SQL, or the system will actually run SQL queries to pull certain pieces of data. So SQL is actually something that's done in a lot of different contexts. And the web application server itself will actually submit SQL queries to be able to pull information from the database to allow people to come in or whatever. So what we're going to learn is what databases are, in case you don't know, what SQL is with some of the basic commands, and how to detect those types of vulnerabilities, how to exploit those types of vulnerabilities, and of course, how to protect against those vulnerabilities, because that's kind of the end goal here. It's not just to attack, but it's to actually find out how to prevent other malicious people from attacking us. So what does SQL stand for? It stands for the Structured Query Language. Now let's talk about what a database is. So if you've never used a database, or if you've not worked with a database before or exploited them, there's terminology that we need to get adjusted to, and this is why we're doing this. So what is a database? And it's a way of electronically storing collections of data in an organized manner. It's a database. It's controlled by a database management system. And DBMSs fall into two camps. You have relational or non-relational databases. And the focus of this video is the relational databases, meaning that there are multiple databases that could actually relate to each other. They have relationships with each other, and they can pull data from each other to check whether or not a user exists, what the various attributes of those users could be, what the various data sets are stored inside of these for each individual user, right? So some of the common ones that you actually run across, which you may have already heard of, would be MySQL, Microsoft SQL Server, there's Access, PostgreSQL, SQLite. All of these things are relational database management systems. So we're going to be talking about the difference between these in a little bit. But within the DBMS, we can have multiple databases, as I kind of explained, or I just explained it to you, I guess. And each one of those databases contain their own sets of related data, hence relational database. So for example, there could be a database called Shop. Within it, you would have information about products to purchase, and then users who have signed up to the shop, and information about the orders that they've received. You'd store that separately in the database using something called a table. So inside of each database, there could be multiple tables. The tables are identified with a unique name for each one, and you can in this specific diagram, we can actually see it. So let me see if I can kind of get you to see this easily. So this is the database server. Then there is the shop database, there's the staff database, there's the accounts database. Inside of each one of these, there are multiple tables. So inside of the shop database, there's the users table, the products table, and the orders table. Inside the staff, there's the users table, the information table, and the audit table. Inside the accounts, there's the customers accounts, orders, and payroll table, right? So these are a bunch of different ways, and you can see how it's all organized, right? It's structured. And this is what a database actually looks like. So what are these tables? Now, a table basically has a bunch of columns, and each column represents a set of data. So Each column has rows. I mean, this is like, if you've seen a spreadsheet, this is easy stuff to wrap your head around. So if you imagine it, it's like a grid with the columns going across the top from left to right, containing the name of the cell, and the rows going from the top to bottom, with each one having actual data. So this is an example. These are our columns. We have the ID column, the username, and the password column. And then each row, so ID 1 will have John and his password. ID 2 will have admin and his password. And then so you'll see this. This is a row, and then each one of these is a cell. And this is basically a spreadsheet. So you should be very familiar with this. If you're not familiar with a spreadsheet, you got to go get familiar with Google Sheets and Microsoft Excel, all that stuff. So each column, better referred to as a field, has a unique name per table. When creating a column, you also get the type of data that will contain. Someone's being integers or numbers, someone's being string, which is standard text, or dates. Some databases can contain much more complex data like geospatial, which contains location information. Setting the data type also ensures that incorrect information isn't stored, so this is actually a part of security here, such as the string hello world being stored in a column that's meant for dates or for integers. If this happens, the database server will usually produce an error message. A column containing an integer can also have an auto increment feature that's enabled that will just go up by 1, for example. So ID starts with 1, the next user that's created gets an ID of 2, the next one gets an ID of 3, like that. It auto increments. This gives each row of data a unique number that grows incrementally with each subsequent row. Doing so creates what's called a key field. A key field has to be unique for every row of data. So each user should only have a unique ID, right? That's basically what makes us ensure that we don't have multiple users having the same ID. And it can be used to find exact row in SQL queries. So if you know somebody's unique ID, you should be able to pull all of their data by just knowing their unique ID. A row is also known as records containing individual lines of data. When you add data to the table, a new row or record is created. And when you delete data, a row or record is removed, right? So the table, or excuse me, the column is referred to as a field because when you look at the data that you're pulling information from the ID field. You're pulling information from the username field. And so John's ID would be pulled from the ID field for the user John, and it will get the value of 1. For the username field for ID 3, we'll be pulling Martin, etc. So hopefully that kind of makes sense. Relational versus non-relational is something that we need to have a good grasp on. Relational databases store information in tables, and often the tables share information between them. And these use columns to specify and define the data that's being stored and the rows that are actually storing that data, right? So the tables will often contain a column that has a unique ID, which is the primary key, which will then be used in other tables. So for example, a table for the user accounts will have all their unique IDs, but then the table for purchases will also track everything based on the unique IDs, right? So the unique ID for Martin will exist in the username table, and it also exists in the order table. And then from there, any purchase that Martin has made will be tracked to his user profile using his ID. And it can be used to cross-reference across multiple tables, right? So, which actually creates a relationship now. So if you can cross-reference data from multiple tables, that means that the data points, my God, my brain just farted. Those values inside of those tables now have a relationship with each other. That's so weird that like that happens. Like literally my brain crashes. The Windows theme, doon, 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 like that literally happens in my brain. So hence the name relational database. Non-relational databases, sometimes called NoSQL, are any sort of database that doesn't use tables, columns, and rows to store the data. A specific database layout doesn't need to be constructed, so each row of data can contain different information, giving more flexibility over a relational database. Some popular databases are MongoDB, Cassandra, and Elasticsearch. So these are non-relational, okay, which actually gives more flexibility because they don't have to now match the various fields or the key fields to be able to meet the criteria of all of the other tables and for them to be able to coordinate with each other. So now that we actually understand this, we can learn how to talk about using that language, the SQL language. So what is the acronym for the software that controls the database? That is a database management system, DBMS. What's the name of the grid-like structure? That would be a table, and that's it. All right, so what's SQL? SQL is the language basically for databases. It's feature rich and it's used for querying a database, basically pulling data from the database, making adjustments to the database, and the queries themselves are referred to as statements. Okay, so you'll see why it looks the way that it does once we actually see like a full query. It's kind of a full statement that you're creating to interact with the database. The simplest of these is going to be select. So you're selecting data from the database. Update will be updating the data in the database. Inserting is inserting data into the database. And of course, deleting will be deleting data from the database. So some databases have their own syntax and slight changes to how things work, but these are all based on MySQL or the MySQL database. After learning these, you'll be able to search for alternative syntax online for the different servers, because they're very similar to each other. They may have like nuanced differences, but they're very, very similar to each other. So first we need to look what select does. And it just pulls data, right? So it's going to retrieve data from the database. Now, if you do select and then you do the asterisk, asterisk is a wildcard character. So it stands for anything and everything, okay? So when you do select asterisk, that means pull everything from users. And we're pulling it from the users table, right? So you have to also close it out with a semicolon. If you don't, it won't work. Literally the entire command will just not work. So this command is going to pull everything from the user's database, meaning it's going to pull their IDs, their usernames, their password, and it's going to pull all of them. If there were 1,000, it would pull 1,000. If there were, 15 columns, it would pull all 15 columns for every single one of the 1,000 entries inside of this database. Select will tell the database what we want to retrieve. The asterisk tells the database that we want to retrieve back everything from the table. And so it may contain 3 columns. From users, tells the database that we want to retrieve it from the table that's named users. Finally, the semicolon tells the database that that's the end of the query. And that's also very important to keep in mind, because those are the types of things, these are the types of nuanced differences that we will end up using to actually manipulate these queries later on. So now we get to actually do individual things. So if we go over here and we see that there are these fields, we have the ID field, username, and password field. We can say, okay, I just want to pull the username and password from the users table. And then it'll bring you only the username and password from the users table, right? So now you're selecting individual fields. So everything is selected, or everything is brought back by the asterisk, right? But then you can do limit 1, meaning only bring me one user from this, right? So because again, this right here is pulling everything from the users. So even though it's just their username and password, it's still going to pull all the users. So if we want to just limit to the top 10 or something like that, we could just do that. We could just say limit, right? So it'll pull everything. Or you can just say limit 1, forcing the database to only return 1 row of data. Changing it to limit 1, 1 forces it to skip the first result, and then limit 2, 1 skips the first 2 results, and so on. So it'll skip the first one, return the next one. Skip the second one, return the next one. So if you do limit 2, 5, it'll skip the second one, or it'll skip the first 2, I should say, and return the next 5 entries, okay? So we can do select everything from users, limit 1. So it'll pull all the fields from the user table, and then it'll only return 1 entry. So we can see where the clause itself, this piece right here, the where clause, and we can actually fine tune or finally pick out the data that we actually want. So you can do select everything from the users table where the username field equals admin. So now, because you may not know what row the admin user is actually in, so you're looking for the username admin, And you can even put asterisks before and after this if you're not sure exactly what the full username is going to be. You can like really fine tune this. So obviously now it's going to select everything from the users table where that username is admin, and then it's only going to enter that for you, right? This will only return the rows where it's actually admin. Select everything from the username table where the username is not admin. So we talked about the exclamation in the last video. We talked about the exclamation equating to not. So username does not equal admin means what? It'll pull everything that's not admin. So it'll give us entry 1 and entry 3, which would be John and Martin, right? Select everything from users where the username is admin or the username is John, right? Now it's going to pull either admin or John for you. So you can actually do that. That's called an operator. The or that we see right here, it's called an operator. And then you can, of course, use the and operator as well. So this will only return where everything is admin or John, right? So select everything from users where the username is admin and the password is this, right? So it will then require both of these to be true. So when you use and, you're requiring both of these parameters to actually be true. Otherwise, it won't work. It won't pull it. In this particular case, we're pulling anything that could be either one. So or is literally either one could be true, where this one is requiring both of these to actually be true. Now, if one of them was false, it wouldn't return anything to you. In this case, if one of them is false, it would just return the other one that might be true. In this particular case, nothing will be returned if either of them is false, right? So using like allows us to specify if we don't know the exact phrasing of something, right? So instead, it either starts with something, it contains something, or it ends with something. And then you can do that placeholder being percentage. So select everything from users where the username is like, and then you do a, and then you give a percentage. So anything could come after the fact. So if it was admin, it would show up. If it was Adam, it would show up. If it was Amanda, it would show up, right? So anything that starts with an A and then it just follows whatever letters finally. And then so it could be anything that ends with an N, right? So same thing. The first part of the query is exactly the same, where the username like and then percentage N, it would give us John, admin, or Martin because all of them end in N, right? Select everything from users where the username is like, right? And then you have the percentage at the beginning, percentage at the end. You just know that there's MI in the middle of it. So it could be admin. It could be, oh my God, I'm drawing a blank on what names. Michael could technically actually pull this as well. I think Michael would be pulled from this as well. So anything, essentially any phrase or any username that actually has MI in the middle of it, somewhere in the middle of it. It doesn't have to be exactly in the middle. It could be like anywhere in the contents of that username. As long as it meets it, then it'll pull that information for you. So all of this, these are just different ways that we can query the database and pull data from the database. So now we can talk about union, the union statement that combines the results of two or more select parameters to retrieve data from either single or multiple tables. So this is where the relational table element comes in, right? So when you use union, you can now pull information from two tables. So the rule is the union statement must retrieve the same number of columns in each select statement. The columns have to be a similar data type, and the column order has to be the same. This may not sound clear, but so we can actually use the analogy. So this is the table, right? So we have the ID, name, address, city, and postcode column. And then we have another table, ID, company, address, city, and postcode. So what do we have that's a combination here? We have the ID, city, and postcode. We also have ID, city, and postcode. We also have address, actually. So we have ID, address, city, postcode exists in both of them. The big thing that changes is name is for John Smith, and then company is for the widgets, right? Or the, the names of the companies. The addresses for these are also different, right? Because this is their home information, that's their personal information. This is their work information. So it's the address of the companies that are there. So using this statement, we can actually gather data from those tables. So we're going to select, and this is not a requirement for it to be capitalized. It's just that it helps us determine what is the verb that we're using, or what the actual parts of the query command is that we're using, and then what the values are that we're trying to pull. So it would be select name, address, city, and postcode from customers. Okay, so this is the first table. So select it from customers, and then union select company, address, city, postcode from suppliers. So what will happen? We'll get the name, John Smith, address, city, and postcode. Okay, and then we will also get the name, widgets, tool company, axe makers, as well as their address, city, and postcode. So we're getting the names. Now check this out, right? The name is actually pulling this. Company is technically the name of the company, but it's a different value, right? But it's actually unionizing. It's actually uniting, combining the all of the names, because again, it says company. It doesn't actually say name, but it's being housed under the name value here, the name field, and it's still pulling the information. Insert tells the database that we want to insert a new row of data. So if you actually want to insert it into the users, then you would tell which table that you want to insert it into, and then you would have to give it the actual field values that you are providing. So in this case, it's kind of easier to be able to look at it like this. So we want to insert into the users table, and then we're going to put in parentheses what we're going to provide to the table. We're going to provide the username as well as the password. So we're going to use these fields, and the values are going to be Bob and then his password. And then notice that the auto incrementation, right? So we talked about auto incrementation earlier. The ID field incremented by 1, so it just gave him the ID of 4, but it inserted his name and it inserted his password into it. So insert into users, in parentheses, the fields that you need to actually provide values for, values, and then insert into parentheses the actual values themselves. And then we have update, which tells the database that we want to update one or more rows of data within a table. We can specify the table that we want to update. So we're going to update the table name, and then we're going to set, right? So we're going to set the fields or values that we want to update as a comma separated, so username equals root, password equals this, and then finally, similar to the select statement, we can specify exactly which rows to update using the clause where, right? So update users, set the username to root and the password to pass, right? And so this is the values and the fields, and they're separated by commas, where the username equals admin. So instead of the username now being admin, because it's kind of like a default username that might be with the web application database. So instead of being the default username, and root also is another default username, but whatever. So now we want to set the username value to root and the password value to pass123 in the row where the username equals admin, right? So now the admin user has been changed from admin to root, and the password has been updated to pass123. And then, of course, delete, we're actually deleting the database, or the line of the database, I should say, one or more rows of data. Apart from missing columns you wish to return, the format of this query is very similar. So delete from users, where the username is Martin, and then so what would happen is that it'll just delete that entire row. So delete from users, because no where clause was being used, all the data will be deleted from the table. And that's basically it. It's once you kind of understand the pattern behind SQL, it's really not that complicated. Like, the most complicated stuff was like maybe this one where we were updating it, or maybe the insert, that might be like kind of complicated to think about, or selecting and unionizing, or combining the values from, that might be the issue. But apart from that, it's like it's kind of easy to do this. It's not really that complicated to do it. So now, what SQL statement is used to retrieve data and that would be the select statement. What SQL clause can be used to retrieve data from multiple tables, and that would be what? The union clause. And what SQL statement is used to add data, and that is what? The insert statement, right? So let's now talk about, we understand what SQL is, right? We understand what the statements are that we can create. So let's talk about what injection actually is. So what is SQL injection? SQL injection is the point where a web application that uses SQL can turn into this when the actual user provided data gets included in the SQL query. Because typically when you're trying to pull data from, or when a web application is trying to pull data from its database, it will create its own statements. It shouldn't include anything that we would provide to it inside of its query. So that's where we can inject our own request or our own statement into the statement that the server creates for itself. So what does that actually look like, right? So where you come across an online blog, each blog has a unique ID number. The blog entries may be either set to public or private, depending on whether they're public release, right? The URL from each entry may look like this. So website, blog, and then the query is right here. So pull whatever you can from the blog where the ID equals 1, okay? From that, this is what the actual query is going to be that the website is going to run, the web server is going to run. It's going to select everything from the blog table where the ID equals 1 and private is 0, meaning false, right? It's not private, basically, limiting one entry. So from what we've learned, we should be able to figure out what that actually means, right? And I mean, I kind of pretty much explained it to you. So the private column is set to 0, the ID number is 1, which means the table is able to be viewing the actual public and limits the results to only one match. As it was mentioned at the start of this specific section, SQL injection is where we can actually input our own query into the database. So in this particular case, we may be able to do something like this. So this little semicolon dash dash would end up doing something like this, right? Where it would select everything from the blog, where the ID equals 2, right? And now this piece right here, this is where it gets interesting, because remember, we know that if we put a semicolon at the end of the query, or if we put a semicolon inside of the query, SQL is going to say, oh, okay, that's the end of the request. That's the end of the statement. And so this would be the only part of it where it actually pulls it. And then this rest of the elements will end up being ignored. So a semicolon in the URL signifies the end of the SQL. And the 2 dashes causes everything afterwards to be treated as a comment. By doing this, we are in fact just running this specific query. So it's now ignoring a key piece of, or 2 key pieces of information. One of them is, oh, privacy is now turned off, right? So we don't want the stuff that's not private. We want the stuff that is private to be presented to us. And I don't care how many you return to me. I want you to return everything you can. So it'll return an ID of 2, whether it's set to public or not. And this is just one example of SQL vulnerability, and it's called in-band SQL injection. There are 3 types: in-band, blind, and out-of-band, and we're going to be talking about them right now. So what character signifies the end of a query? And we already talked about this. That's semicolon. Very, very important, because that's where a lot of this stuff becomes more functional and practical for us as pen testers. So let's now talk about in-band SQLI. In-band SQLI is the easiest type, and it just refers to the same method of communication being used to exploit and also receive the results. So for example, you exploit it, right, on a web page, and then being able to extract the data from the database to the same page. So it just displays it onto the screen for you. Error-based SQL injection is the most useful way to easily obtain information about the database, because error messages are printed directly to the screen, and they can often be used to enumerate a whole database. Union-based SQL is the type of injection that utilizes the union operator alongside a select statement to return additional data. And this is the most common way of extracting large amounts of data via the SQL injection. And so the practical in this particular case has to do with the virtual machine that's been assigned to us in this free room from TryHackMe. So Each level contains a mock browser and also SQL query and error boxes to assist in getting the query's payload correct. So we may need to refresh the page once the machine starts if you get a 502 error gateway. So just keep that in mind. If you have an error, the bad gateway error, you might need to just refresh the page. Level 1 contains a mock browser website featuring a blog with different articles, which can be accessed by changing the ID number. The key to error-based SQL is to break the code's SQL query by trying certain characters until an error message is produced. These are the most commonly single apostrophes and also quotation marks. These are the most common to try to get errors, okay? If we type an apostrophe after the ID and then press enter, we'll see that there is an SQL error. The fact that we've received this message is confirming the existence of an SQL injection vulnerability, because it's actually processing what we entered into it, right? We can now exploit this and use the error messages to learn more. So the first thing that we want is to use the browser without displaying an error. First, we want to get union operator so that we can receive an extra result if we choose it. So if we do the mock browser ID parameter to 1 and then union select 1, this should produce an error message informing that union select has a different number of columns than the original select. So let's try it again. So we'll do 1 and then union select 1 and 2. So now again, same. So 1 and 2 and 3, right? Now it says the success has gone because the article is being displayed, but now we want to display the data instead of the article itself, right? So the article is displayed because it takes the first returned result somewhere in the website's code. To get around that, we need to first query to produce no results. So this can be done by changing the article ID from 1 to 0. So if it has no ID, that would kind of give us an error. So it's just made up of the result with the union select, etc., etc. I feel like I should actually just do all of these things so that we can get to the end of it instead of just reading through it. So here's what I'm going to do. I am going to zoom out of this a little bit so that we can actually load our screen, our split screen right here. And then I'm going to open this up in a separate browser or a separate screen on my secondary monitor. And then from there, I'll read through the instructions and then we'll just manually run all of these exercises together, okay? So that way we can actually kind of do a demonstration instead of just reading through the text. So here's the actual browser itself. This is the level 1 stuff that they were talking about. So the first thing that we're most interested in here is to first just do the error message stuff that they're talking about. So if I go ahead and what is it? So it says if we choose it, or what is it? I'm sorry. At the very beginning, it says try to break the code by putting certain characters and see what is shown up here. So we have this right here. That's the query. And if I just do a quote or an apostrophe, it says syntax error or access validation. You have an error in the SQL syntax. Check the manual that corresponds to your SQL server. At line 1. So now this is what the query is that's going to be presented, right? And so SQL select everything from the article where ID equals 1, and then now we see that the apostrophe is also at the end of it. So okay, interesting. So now we're going to see what we can do without displaying some kind of an error message. So if I do, instead of just doing that apostrophe, if I do 1 and then we would do union, right, select 1 like that, press enter, it'll give me an error message. The statements have a different number of columns. Okay, so union select 1 and 2, and still different number of columns. Okay, 1 and 3. Okay, first article, there we go. Now we actually received that data. So 1, 2, and 3 actually worked, and this was the query, right? So select everything from the article where the ID equals 1, and then union select 1, 2, and 3. And so now we can see that we were able to retrieve the data, right? So because, excuse me, you will see that the article is just made of the result from the union select returning column values 1, 2, and 3. And we can start using these return values to retrieve more useful information. So now we want to get the name of the database. So we can do ID right here will end up being 0, right? Now we want to kind of mess around with this a little bit. So if we do 0, 1, 2, 3, let's see what this returns. Now it just gives us the actual, what is it? It'll give us the website to give us no results, right? Because we want to try to find other information, for example, the actual contents of the article or the name of the other tables that might exist. So if we do 0 for the article ID and then union select 1, 2, and 3, we can now see that it's kind of basically not giving us anything, right? It just gives us the it's almost empty, but not really. It just shows that article 1 and then there's empty. So, okay. So if we do union select 1, 2, and then this is the next piece of instructions that we got. Union select 1, 2, and now we want to try to pull the database name. So if we do that and just give it an empty parentheses, right? So if we do values 1, 2, and then instead of the 3, we just put the database value itself, or the database field name, I should say, and then just do empty parentheses. Now we have an actual name right here. So now we know that SQLI_1 is the name of the database that's useful to us. So the next query should now get us the list of the tables that should be inside of this database. Okay, so ID still is going to end up being 0 because we want to not pull anything from the current database. We're trying to pull everything from this other database that we have over here. So ID is going to end up being 0. We're still going to do union select, and then we're going to leave the 1 and the 2, and then this last portion is what we're going to end up changing. Now this is a new command or a new option that we're learning here, which is the group concatenation command. So it's group concat, and then we give it the table name. So concat the table name value for us from, now it's gonna, you know, don't lose your mind here. So let me just make sure that this is all good. From, okay, information underscore schema dot tables, okay, where the table schema equals SQLI_1. Okay, that's a lot, I understand. So let's first look at the very first piece of this. The first piece is the group concat portion, this piece right here, the group concat portion. This is the piece that gets the specific column. So in this particular case, we want the table name, okay? So it's going to get the specific column from multiple returned rows, and it will put it into one string that's separated by commas. The next one will be information schema. So the information schema database portion, this one right here, that is where every user of the database that actually has access to this, and it contains information about all the databases and the tables that the user has access to. So it's actually going to pull the stuff that we should be permitted to access. And in this case, we're interested in getting all the tables in the SQLI1 database that we actually have access to. So if we press enter on this, we should be able to see what we have access to. So if I do that, now it says, okay, we have access to the article table and we have access to the staff users table, which, okay, staff users is actually interesting to us and it's useful to us. Okay, so cool. Now we've gotten some interesting information. We went from first just being able to pull articles and seeing if there's articles available. Then we were able to see if we were able to combine the two tables by just figuring out, all right, so if we do 1, 2, 3, we'll be able to combine the two tables. Okay, so two tables actually do exist. Then we changed it to the ID equaling 0, and then trying to actually find the name of the table, the secondary table that we might have access to. And that's where we did the ID 0. So yeah, so it was ID 0, union select, and then we did 1, 2, and then we tried to just pull the database, the name of the database, by actually referencing database with those empty parentheses. Okay, up until that point, it was pretty basic, and we were able to find the name of the table, which was the SQLI1. That was the name of the database, excuse me, that we found. Then we did the pull where we're like, okay, well, what tables exist inside of that database that we actually can get access to? And this is the command that was able to give us access to that, this portion where we group concatenated for the table name, right? And then from there, we were able to pull from the information schema of the tables. So information schema is going to be something that you'll see that will be the most generic, and then we can go into table schema and so on and so forth. So that's what we're going to end up doing next, right? So we're going to continue from here. So we're going to now go from table name, and we're going to still do concat, right? So we'll still do the group concat. There we go. And in this case, now we want to get the column name, okay, from the information schema columns. So previously was information schema tables. So now we're pulling the column name from the column schema, excuse me, where the table name is what? Staff users, because that's the one that we're most interested in, right? So staff users. There you go, just like that. Press enter. There we go. Now we actually have the column names inside of the staff users table, or yeah, staff users table. There you go. I need to make sure I get the proper terminology for you. So we first found the database. It was the SQLi1. And then inside of that database, we did the information schema.tables to find what the tables were inside of that database. And we found the articles table, and we found the staff users table. And this command that we're looking at right now is now going to pull the column name. So we found the table, so now we want the column names inside of the table from the columns schema where the table name is actually staff users. And we were able to now find ID, username, and password being the columns that actually exist for us. Great, so now we just need to go ahead and try to find the actual values of those elements. So same thing, right? So we're going to do this. We're going to go back to group concat. So start from the top. Let me just make sure I can actually delete this. I don't know why it's not deleting. Let's see if we could just do this like this. So we'll do this. There you go. Okay. All right, so group concat still, right? Now we're going to do this. We want the username, right? And we'll do this. We're going to do a concatenation tactic right here where we'll do apostrophe, colon, apostrophe. So we're just manually entering a colon. And then we want the password. Okay, so we know that there's a username. We know that there's a password. We don't want them to be connected to each other where we don't know where one begins and one ends. So that's where we put the manual colon right here, just to be able to separate between the username and password so that we know where one of them begins and the other one ends. Okay, so far we're good over there. And then the separator itself, separator. So let me just do this, separator. And then inside of apostrophes, again, we'll do BR and then like that and like that, which would be the HTML tag that forces a separate line. So a new line, right? Line break is basically what that does for us. So this is going to be the full group concatenation query that we're submitting. And now we just want to pull this from the staff users table, because that's where we know everything is. So we're pulling the username, and we're going to separate it by a colon to make it human readable. And then we're going to pull the password, and our separator between all of these entries is going to be a new line, which is where this is an HTML tag for a line break. So that's what our separator is going to be. So anytime that it detects that, it's just going to create a new line for us. And then from there, boom, from staff users, press enter. There you go. Admin is password, or so admin username has password. Martin username has password with $2. Jim has work123. Okay, great. So we were able to pull the information that we need. So now we should be able to get access to the username or the password that we would need to actually get ourselves to the next level, which is whose password do we need? We need Martin's password to be able to get to the next level, which is this thing right here. So we can now go, what is the user Martin's password? It would be and SS like that, word, and then press check password, and now we're good. So boom. Okay, so there we go. This is the flag that we need to complete level 1, which is, where is it? Right here. So in-band SQLI, level 1, the flag is right here. There we go. THM SQL injection 3840. So now we're good to move on to authentication bypass for our next attack. So this is where it's going to get a little bit complicated, and I'm going to give you fair warning because I don't want you to be shocked, okay? Previous exercise that we did, we were actually getting the response from the server, meaning the error messages from the server on the screen. Blind SQLI does not give us those error messages. But in this particular case, what we're going to get is we're actually still going to see whether or not the injection was successful, right? So as long as we get some kind of feedback, it should still be relatively simple for us. So blind SQL authentication is when bypassing authentication methods such as login forms is very useful. So we aren't that interested in retrieving data from the database now. We just want to get past login. Login forms that are connected to a database of users usually do this. So you go ahead and submit your username and password, and then it goes and checks the database of usernames and passwords. And if it exists and they match, then it'll actually grant you access. That's what happens with a login form. You put in your username and your password, you press enter or you press login, and then the information you submitted, the server goes and checks against its database, and they're like, oh, for the username Hank, the password is password. So the query that's submitted, it says, select everything from the users where the username is Hank and the password is password. And so as long as those two things actually match, both of them have to exist. When those things actually match, then you get granted login, right? So in the content of the username and password, but more in whether or not the two make a matching pair in the users table. This is where authentication happens. The web application is asking, do you have a user with the username Bob and the password Bob123? The database replies with either a yes or no or a true or false. And depending on that, whether or not you get access to the login or not, right? So taking that information, it's unnecessary to enumerate valid username and password. We just need to create a database query that replies with a yes or a true, right? So you don't necessarily need the actual username and password. You just need to get a response from the server that says yes, right? So level 2 of this will show us this example. The box is going to be called SQL query, where we can actually see right here, right? So this is where we actually see where everything is being input. And this is what we have as the username and password. So where am I? Right here. So the database is going to be doing this. Select everything from users where the username equals username and the password equals password, limiting 1. The username and password values are taken from the login form fields, and the initial values will always be blank because these fields are currently empty. So to make this into a query that always returns a true, we can always do this. We end it. So this is where that single apostrophe comes in. And then we say or 1 equals 1, and then we give it the end of the command itself by doing that forced semicolon, and then everything after the fact will end up being a comment. So it'll turn this where the username is this and password is this, or the 1 equals 1, and 1 is always going to equal 1. So that will be a true statement. So basically what we're asking the database is either this needs to be true or this needs to be true. And 1 will always equal 1. So the response to that will always be yes, true. So that's how we make sure that this is being done. Now, the key element, one of the key elements here is this initial apostrophe, because you can see that the password right here has that, right? It has that single apostrophe. And then we need to close the apostrophe. So this is what we get right here. Boom, right here. So it says, select everything from username, where this is this and the password is this. And it already has the 2 apostrophes. And we want to make sure that we comment out that, but we still want to close this out so that the system doesn't think that we don't know what the hell we're doing. So if we go over here and we do a single apostrophe, right? And then we do, let me actually even just single apostrophe, press enter and see what happens. Okay, excellent. So it's actually not in the upper portion that it would work. It's inside the password field that it would work, because I just added a single apostrophe and we see that it added it to this piece right here. So in the single apostrophe right here, now I can actually do this. I can do space. There we go. We see that. We can see or. There we go. 1 equals 1. We can see that. Now we're going to do semicolon to imply that we've ended it. And then everything after the fact is going to be a comment. So the rest of this piece right here is all just commented out. And this is now the actual full query that we've gotten access to. So now we're just going to do login. And there we go. Now we're actually in level 2, SQL injection 3840. And that should be, excuse me. So now I need to click level 3 to get to level 3. There we go. So SQL injection 9581. And there it is, SQL injection 9581. So that one was super, super simple, right? It's just a very interesting misconfiguration that we take advantage of, and we were able to pull it off. And now we actually don't get to see a pre-made SQL query for level 3. So this is going to make it even a little bit harder for us. Boolean-based SQL injection, and this is still blind SQL injection, refers to the response that we receive. So a Boolean would be either a true or a false, yes or a no, on or off, 1 or a 0. So any response that can only really have 2 outcomes. And that outcome will confirm that the SQL injection payload was either successful or not. That's basically it. When we look at this, we'll see that the limitless responses can provide information still, right? Or these limited responses can provide information, but with these 2 responses, it's still possible to enumerate an entire database. So on level 3, this is what we're looking at, right? On the machine, we're presented with a mock browser with the following URL that we can see right here. Username equals admin, right? And it says what? True. So the username does equal admin in this case. The taken true API endpoint replicates a common feature that found on many sign-up forms, which checks whether a username has already been registered to prompt that the user should choose a different username. So if it says taken true, it means that that username is already taken. So that means that admin does exist, right? So we can assume that the username admin is already registered, and we can confirm this by changing the username from admin to admin123, and it will then change it from true to what? False, ideally, right? So it says taken false. So this username is not taken. That means that admin123 does not already exist, right? So this will be what the query is going to turn to be. So do we actually even have the query at the bottom? Oh, we do. So select everything from users where the username equals admin123 limit 1. So great. So we can actually see that. So selecting everything from the users where the admin is that specific username, right? So the only input that we have control over in the username query string, and we'll have to find this to perform the SQL injections. Keeping that the username is 123, admin123, we can start appending this to try and make the database confirm true things, changing the state of the taken field from false to true. So for example, if we do admin123, union select 1, right? So establishing the number of columns on the tables, which can be achieved by that union statement to see if it'll actually return true or false. If the web application responded with the value of taken as false, we can confirm that this is the incorrect value of columns. So we keep trying, and we can confirm that the answer is 3 by getting to 1, 2, and 3. Now that the number of columns has been established, we can work on the enumeration of the database. And the first task is to discover the database name, and we can do this by the built-in database method that we previously did before as well. So all of these things I'm going to actually start doing, because instead of just reading through it, this would be fun. This is much more fun if we actually start implementing all of these things. So it started with the admin123 portion, okay? So yes, admin123 is not taken, or no, it's not taken, I should say. So okay, so we have that, great. And we can see that the query at the bottom has changed into that. So let me see if I can kind of keep it so we can actually also see the query at the bottom. Okay, so the admin username is 123, so we can actually see that. So if I can go ahead and do this then, or let's see, if we do username equals admin123, and then if we do, let's see, nope, that's going to do that. So we'll do a comma, and then we'll do union, and then we'll do select, right, to keep the, there you go. So there you go, excellent. And now we'll do 1 and then semicolon 1 1, enter, and now it says taken false. Okay, so it doesn't have just 1, right? So now we'll do 1 2, enter, still. Okay, great. Let's do 1 3, comma 3, enter. Okay, now it says taken true. So now we know that, okay, the union to the next table that we're trying to get access to, or the next database, I should say, that we're trying to get access to is, okay, there's a 3-column table that would be the one that we can actually get access to. So now what we can do is we can try to pull the actual database name by following along with essentially everything that we've already established. So all of these things are still going to stay the same. So the admin 123 is going to stay the same. Union select 123 is going to stay the same. Then we're going to add some extra stuff where we have where, right? The database, database, there we go, empty parentheses, it's like, so the database name is like, and then it says S and percentage, right? Or actually, not even that. I should actually be doing the first one is the database name is just like this piece right here, where we just put percentage first. So we're going to still get true. We've gotten true so far, right? So if I do empty database and then just do percentage in there, press enter, it will also say true. So it says, okay, well, fine. There's also a database name in there. So now technically what you can do is you can go through all the different iterations, and this is going to take a lot of time. So I'm going to kind of skip around with this, but you would, again, just do all of the iterations to see what the name of the database would start with. So if I do a percentage, enter, it'll say, no, it's false. It's like, okay, so it doesn't start with an A. If I do B percentage, enter, it's false. Okay, it doesn't start with a B. You do C, false. D, false. E, oh, it starts with an E. Interesting. Okay, so we have a database name that actually starts with an E. You see? So just by doing it through trial and error, essentially, we can see that it starts with an E. Okay, I tried all of the other iterations. So I went through the EA and then I went through EB, etc. And it all came back false. But it's actually really interesting that E by itself, oh, you know what? E also just came back. Maybe that was the issue because E by itself came back as false. So I think I misread something maybe because I thought E by itself was true. So E is definitely not true. D would not be true. F would not be true, etc. And we can just move forward. And so based on just the documentation, they kind of did a lot of the work for us. So we can actually just go to S, and then we can see that S, a database name that starts with S, would end up being true, right? And then you can just continue forward and just keep doing the trial and error until you get the full database name. Now, to save time, again, so it would be like this, right? So you would do SA, and it would be false. SB, it would be false, etc. So if we do SQ, because we know that we're going to SQL, right? So SQ, it returns true. If I do SQA, it'll be false, right? If I do SQL, it'll return true. And we can then do SQLA, right? And keep going through those iterations until we find the appropriate one. Now, this particular one, the next character is actually supposed to be the underscore. So it would be SQL underscore, which would give us a true. And then so now it would be SQL underscore A, right? And that would be false. SQL underscore B, etc. So we would then go to T, which would end up being SQL underscore T. Now it's supposed to be, or excuse me, actually, SQL underscore by itself is true. But what we're looking for is not SQL underscore by itself. We're actually looking for SQLi underscore. There we go. That's the one that we're supposed to be kind of working our way towards. I kind of jumped the gun a little bit. So SQLi, SQL injection, that's kind of what we've been working on. So that's the one that is true. Then there's the underscore, which would also give us true. and then there's the letter tree, which 3 would give us true, and then if we went TA, it would be false, so we would end up with TH. Okay, so it's true. THA, it's false. Then we would keep going until we ended up with THR. Okay, so that's true. Then I could be like, okay, so maybe it's the word 3. Oh, we're looking for the word 3. Oh, okay, so there you go. SQLI 3 would end up being the database name that we're trying to find. So this specific one is more time intensive than anything else, because you have to actually go through every iteration of the characters that are available until you actually find some legitimate names. So SQLI 3 actually is the database name that we're interested in. SQLI 3 is the database name that we're interested in. And if we really want to test it, we can actually now move this last element off and just leave it as that. So we're just going to say we're looking for a database that has SQLI 3, and that should be giving us true by itself. So if that gives us true by itself, that means the database name actually is SQLI 3. There is no other characters or anything that we're missing. So now we have the database name, which is great. So now that we have the database name, we can move on to the information schema, where we pull the table names, and then where the information schema where we start pulling the column names. And again, we're still going based on the true and false responses that we can potentially find. So union select 1, 2, 3, it's going to stay. Where is going to stay. So actually, excuse me, where is now being moved. So we're getting rid of where. Sorry about that. And we're still leaving the last piece, right? But the semicolon dash dash, we're still leaving because we want to still comment out the rest of this. So now we're going to try to pull from the information schema. So it would be from information schema, and we want the table names first. So we're going to be getting tables where, right, the table schema, okay, equals the actual table name that we just found, which is the SQLI 3. So that's it. And the table name is like, so table schema being what? The actual database name is what we found. So we're pulling from SQLI 3. That's, we know what the database name is. And then now we have to go through the same exact process that we went through before to try to find the database name, which is what? You put the quote, you put the percentage sign, and then you close it out and you press enter. And you say, okay, cool, there's a table name in here. All right, so if there's a table name, does it start with an A? No, it doesn't. Okay, does it start with a B? No. C? No. D? No. And then you just go through all of the letters until you find the one that it actually starts with, right? So once we get to U, press enter. Oh, it's true. Okay, great. So UA, right? And then nope, that's false. UB, and then that's false. So you just keep cycling through that until you get to US. And it's like, oh, that's also true. Okay, great. So USA. Nope, that's false. USB, nope, that's false. And then you go through that until you find USE, and that ends up being true. Okay, great. USEA, right? It's false. And then you end up until you get to USER, so user. Okay, great. That's true. So, and then you again keep cycling until you get to the point where you end up with USER, let's say A, it's false, so we can do USERS, and that's true. So then we can confirm whether or not this is the official name, right? By deleting what? That percentage sign, and then checking that. Okay, great. So that's definitely in there. So what if I just did this? I remove like, and I do table name actually equals users. What if I did that? Press enter. Yep, that's also true. So, okay, great. The table name does equal users. So now we have table schema from the tables that we've pulled, that we know that the SQLI 3 is the actual name of the database. And then we also have the table name being users. So now we definitely know that we actually have the users in there. So now we need to start enumerating the columns in the users table so that we can properly search it for the credentials, and then we can use information schema. But now, since we're doing information schema columns, we're not doing tables anymore, right? So we're going to go all the way at the beginning of this, or not the beginning, I should say, like kind of towards the end. So let me just make sure that I can actually highlight this thing. For whatever reason, it's not. There we go. Okay, so information schema is what we're looking for now are the columns, right? Where the table schema information that we're pulling for is going to equal what? SQLi3, that's the database that we're searching through, and the table name, right, equals users, because we know that that's what our table name is, and, right, here we go again, because it starts again, the column name is like, and then start it again, a percentage, close it out, press enter. Nope, there's no column name that starts with an A. Okay, does it start with a B? Nope. C? Nope. So then you literally go through this. This is like very painstaking if you haven't already imagined, because you have to actually now do this for every single one of the columns. So you need to find, all right, column name number 1 is ID. Column name number 2 is whatever, name, I guess. And so it just keeps going and going until you actually find all of the column names. So we'll have to cycle through all the letters and the numbers and the characters until we actually find a match. Now, in this particular case, because we're actually looking for multiple results, every single time that we come up with one, we need to find the new column name and avoid discovering the old name. So for example, the one that we're looking for is obviously ID, right? So column name like I, it says false, which is silly because it's not supposed to be false. So column name, am I misspelling column name or something? Table name is users, schema is 3. Okay, so this is all good. So A, no, I should not be false. It should be true. Oh, because I have an extra quote at the end of this. So I'm going to do I percentage, enter. There you go. That's what it is. So there we go. I had an extra apostrophe at the end of it. So it does start with I. Great. So ID, does that work? Yep, we have ID. So we know that we actually have one column name that's at least ID, right? So now we can look at the full query. This is what the full query looks like, right? Everything after admin 123, this was false. So we added an extra apostrophe. Then we did union select 123 from information schema columns, where the table schema is SQLi3, so that's our database name, and the table name is users, and the column name now starts with ID. So that gave us a true response. So far, we're making decent progress here. So now that we know that the column name, there is actually a column name named ID, because we've established that. So I can even do this, right, just to, again, confirm. I can get rid of that percentage sign and then do column name equals ID. Do that, and it still gives me true. Okay, great. So now I know for a fact that there is actually a column name that's named ID. So what I need to do now is do the same thing, but at the end of it, we're going to add an extra addition where the column name is not equal ID. So I want to discover a new column name, okay, but I don't want it to discover the same column name as I did before. So the entire thing will stay the same. The entire query will end up staying exactly the same, but we're just adding an extra portion where we're searching for the second column, and we just don't want the column to be named ID. So we're going to go through this again, right? We're just going to start here again. And before the column name equals ID, before this part, we're going to do another one. So right after users, we're just going to start another one, and it says and column name, okay, is like, again, a percentage, close, enter. It's false. Okay, so the second column name doesn't start with an A. Does it start with a B? No. Does it start with a C? No. And then we'll just keep cycling through that, right, until we can find the next one specifically, which in our particular case, I think it's going to be username and password. So if it starts with a U, should be true. Great. So if it's username, right, so let's just skip to the end here. You should already have the pattern down by now. So if the column name equals username, but it does not equal ID, tell me if it's true. And it is true. Great. So now I'm going to move on to this one. close that one out. So column name does not equal username and it does not equal ID. So I want the next one to be column name, and then we need to find another one, right? So column name is like, and then we'll start it again. We'll do a percentage close apostrophe, and the column name is not username and it's not ID. So you can see the query is getting pretty crazy over here. So does it start with an A? Nope, it doesn't start with an A. Okay, so let's say we already know if there is a username, there needs to also be a password. So does it start with a P? Oh, it starts with a P. Okay, so password. Oh, that is also true. All right, so let me just make sure that column name itself actually does equal password. That is also true. So now we know for a fact that inside of the SQLi3 database, there is a table named users, and there's a password column, there's a username column, and there's an ID column. Because all of this whole thing returned true to us. So that's a very long query that we just created, but that statement, every element of it was true, meaning all of those things actually exist for us. So that's great. So now we know we have ID, we have users, we have the SQLi database, we have the users table, and then inside the users table, we have ID, username, and password. So now we can actually pull from that users table. So from here, so we can actually just delete all of this shit except that last piece with the comment. So we can come over here and we're going to go union select columns 1, 2, and 3. Okay, great. We're selecting it from the users table, right? Because we know that it exists. Where the username, now we need to go through again the same process, is like, right? A percentage close. Oh, cool. There is a username that starts with an A. Okay. Does it start with an AD? Yes, it does. Okay, great. Does it start with an ADM? Yes, it does. Oh, let me guess. There's a username called admin. Of course there is. All right. So let's remove that percentage at the end. And then instead of doing username like, we'll do username equals. Oh, there is an actual username that's named admin. Great. Okay, cool. Now we have the username admin. All right. So we're going to pull from the users where the username is admin and the password, right, is like a percentage, close it. Nope, password doesn't start with an A. Okay, B. Nope, okay. So we'll just go through this, and then what's going to end up happening is that towards the end of it, we'll have to go through all the numbers. So does the password start with a 3? Oh, the password starts with a 3. Okay, does it start with a 3, 4? No. Okay, does it start with a 3, 8? Oh, it starts with 3, 8. All right, so is it 3, 8, 4? Oh, it starts with 3, 8, 4. Is it 3, 8, 4, 1? No, it's not. Is it 3, 8, 4, 5? Oh, it is 3, 8, 4, 5. Okay, great. So now let's see. And then again, you'll run through all of these things. And this is what's really crazy, because then you'll be like, okay, so is it 3, 4, 5 A? No. All right, so is it 3, 4? And then you'll run through all of them. And then you'll get a false statement for everything else, which implies that, okay, it's not 3, 8, 4, 5, 7. It's not 3, 8, 4, 5 J, right? Like you'll run through all of the options and you'll get a false for everything else, which means that what? It actually is 3, 8, 4, 5. So we can then delete that percentage at the end. We can come over here and say the password equals 3, 8, 4, 5. Okay, great. So it is actually, the username is admin and the password equals 3, 8, 4, 5. So now I know for a fact that that's what my login is going to be. All right, so let's just log in as the admin user with the password 3845. And the login should actually be successful. And now we have gotten to level 4. So the flag for level 3 was the SQLi injection 1093, as we can see right here. So that one was like the most painstaking. Like if you're actually doing this in real life, if you're doing it in the real world, you literally will have to go through every single iteration until you actually find the answer. And this is where scripting comes in. This is where creating a script that can actually go through every single letter and every single character and all of those things, and then find the ones that finally gave you a true response, that's where it comes in. And very, very freaking useful if you know how to create Python scripts, or if you know how to create shell scripting or anything that can actually do these type of work for you. Because if you can imagine, it's going to take you a very long time to try to do this manually, letter by letter, sitting there one by one. Now, if you are forced to do it manually, now you know what you're doing. And the fact that you actually need to know that this is what the process is will allow you to create a successful script that will actually be able to find it for you. But if you didn't know what you were looking for, or if you didn't know what the process was, then you wouldn't be able to find the script. So that's where, or you wouldn't be able to create the script, excuse me. So that's where it actually comes very handy to actually go through the manual labor of this, so to speak, to be able to find what the process is, so that then you can go ahead and write a script that will create the automation for you, or at the very least go to your favorite AI and be like, hey, I want you to write a script that will do this, right? I want you to go write a script that will go ahead and find me the username, and then go ahead and find da-da-da-da-da-da, and then manually find, or, you know, quote unquote manually, the script will go ahead and find it for you. All right, so let's go to the blind SQLi that would be time-based. Time-based blind SQLi is similar to what we saw previously, because it's now, we're just essentially looking at a time as the indicator of whether or not we got something right. So the indicator of a correct query is based on the time that the query actually takes to complete it. The time delay is introduced to using a built-in method like sleep alongside the union statement. The sleep method will only ever get executed upon a successful union select statement. So for example, when we're trying to establish the number of columns in a table, if we use this, if there was no pause in the response time, we know that the query was unsuccessful. So like on the previous task, we add another column, so on and so forth. So if there is no pause, we know that it's unsuccessful. If there's a pause, that means it is successful. So let's actually go ahead and try these two out, these two that we have over here, that will hopefully kind of show us what it is. So if I go over here, the query is at the bottom right here, and so it'll even show us what the time is, right? So if I do admin, or what is it, refer is TryHackMe, and I guess I would do admin, and let's see what shows up at the bottom right here. And it does have that at the bottom. So admin, that kind of doesn't seem to be appropriate here though. If I do comma or apostrophe, I do admin, would that be the case? Because it seems like that's not the right thing to do. So when trying to establish it, you would use the following query: admin123 union select sleep 5, and then see if it'll actually work. So I'm just going to type it as they said it. So admin123 apostrophe, and then union select sleep, and we would do 5, and then close it out, and then we would do the 2 dashes. So this is what we see right here, but domain does not, it's not supposed to be domain admin TryHackMe. I don't think that's what it's supposed to be. So I don't think this is actually going to work. So if I do this, it will give me, yeah, it's not a pause. There's like no pause that's taking place. Okay, so if I do the next version of this where they're implementing that, they would say do a second column and press enter. Okay, I guess this works. So now the requested time was 5 seconds. So the sleep 5 worked, which is really odd because the way that the SQL query from the bottom works, it's kind of weird. It doesn't look right to me, but I guess that actually works. So the payload should have produced a 5-second delay, which it did, confirming the successful execution of the union statement. Now we can repeat the enumeration process from the Boolean-based injection, adding the sleep method to the union select statement. And if you're struggling to find it, this will help us get started. And this is insane to really think about, because we have to go ahead and iterate through all of these things, right? So we have to go through, iterate through all of these things to actually start from the very, very beginning. So it would be, okay, union select sleep 5, comma 2, where the database, right, is like, and this is what they're giving us as a starting point. So this is what the manual portion of this should be. So this is giving us the database is like, comma, u, which I guess it isn't, right? So database does not start with a u, I would say. And let me see if the rest of this, yeah, the rest of it is fine. So union select sleep 5 where the database starts with a u and it doesn't. So let me see if I can get, I'm obviously going to cut through this because there's no other hints that they're giving me here. They're literally just saying that this is where you should start with, and then see if you can find the database name and then go find the table schema and all of that, which is, my goodness, it's going to take a long time for me to do manually, but I have to do it. So I would very much like for you to also try this before you finally get to the portion where I give you the answer, because I'm going to go through every little step until I find the answer. But try to do it a little bit yourself. But I understand if you just want to skip and kind of find the answer to the end. But hopefully you will at least try it, because I want you to get the process under your belt. But anyways, by the time I'm going to pause, and then in 1 second, you're going to see me with the answer. Okay, so quick little update before we move forward. So the key element that I have changed here is, number one, there is something that they did mention, which I don't know if this actually really makes that big of a difference. Oh, it's still on this page. So right here, they did say that we can start it with refer equals admin123. So it doesn't actually say TryHackMe over here under the domain. So it actually just starts with admin123. So that's the one piece that it's like right after refer, I started with admin123. And then I ended up with users because I just kind of assumed that we're looking for the users table, because it says this is where we should help you on our way. Database starts like users. So, or it starts with a U. And so that's kind of where I immediately jumped to that conclusion, where I was like, okay, well, it's probably a users database that they're looking for. So union select sleep, I changed it from 5 to 3 because I don't want it to take 5 seconds each time that I go through it. It'll be a little bit faster for me. So it did update that, and the rest of it was, okay, so after this part, it's pretty much the same, standard, like very similar other ones. And now it says from users, because now I guesstimated that it was users, where the username like A, and so we're starting with that now. So now we're going through the username starting with an A. So if it is admin, all right, so there you go. Now it's going to lag another 3 seconds for me. There you go. So it did take 3 seconds. So the username is most likely admin. So we can go ahead and remove the percentage. And then from here, we can just say where the username equals admin. And it should take 3 seconds again, which it is. So great. So the username definitely does equal admin. And then we can just go here and then say and password, right? Password equals, or I should say is like. And then from here, we'll start from scratch. And so we'll do, a percentage and then close that. And then it'll take 0 seconds. So this, now I need to go ahead and kind of work through the password itself to try to find what the password would be, and just run through whatever password options we might have. I think it might be easier if we start with numbers, because the last one, the password was actually numbers. So if we go here, oh, there you go. So there's an actual lag right there. So, okay, so the password does start with a number. So it starts with a 4, and then we can now just go through all the numbers to try to find what the potential password would be for this guy, for this admin person. And hopefully it won't take forever. Oh, there you go. So it starts with the 49. Okay, there you go. I'm just going to go through the iterations real quick, and then we'll find the password, hopefully soon. Okay, so we got a 4-digit password so far, and it's 4961. So let's see if it actually is 4961. And it looks like it is. So the username is admin, password is 4961. This is what the full query is. If you want to actually kind of pause and look at that. So let's see if we try to log in with admin with the username 49 or the password 4961 and correct login. Okay, great. So it actually worked, and there we go. So that's the last flag, the SQL Injection Master. This one, they really didn't give us much to go with apart from this piece where they're like, okay, you can start it with this. The sleep I just changed into 3 just to make it a little bit faster. And the database, this part I skipped this piece because if it starts with you, because they said this would help us. So if it starts with you, I was like, okay, we're probably looking for users because we're looking for a username and password to be able to log in. So I was like, all right, so we're looking for users. So I just changed the rest of it where, okay, the database or where the, from here where he said from users, right? So that's where we went to. And then from users, we then went, okay, where the username equals, and then I started working to that. And then again, it's like guesstimation, right? I'm trying to find most likely an admin user, and then most likely the hardest, like the longest part of it ended up being the actual going through all of the numbers to try to find the numerical 4-digit password for the admin user. So let's talk about out-of-band SQLI now. Out-of-band SQLI is not as common as everything else that we've talked about so far, and it depends on specific features that are enabled on the database server or the web application's business logic, which makes some kind of external network call based on the results from the SQL query. So it's going to reach outside of its internal server. It's trying to connect to something externally outside of itself, right? The out-of-band attack is classified by having 2 different communication channels. One launches the attack and the other gathers the results. So the attack channel could be a web request, and the data gathering channel could be monitoring the HTTP DNS request made to a service that you control. So this could be potentially Netcat. It could be running Wireshark and just capturing traffic, or TCP dump to capture traffic. So the attacker makes a request to a website that's vulnerable to SQL injection with an injection payload. The website makes an SQL query to the database, which also passes the hacker's payload. And the payload contains a request which forces an HTTP request back to the hacker's machine containing data from the database. So this is what it looks like. This is the hacker. This is the lowest quality graphic they've created so far in TryHackMe. So this is the hacker. Step 1, they make the request to the website. The website tries to connect to the database, and the database reconnects to the hacker. This is the lowest quality image that they have created by far so far. But essentially, the request that's being submitted is where that injection payload would actually exist, so that when the website passes the injection payload to the database, inside of that is where the remote connection back to the hacker's machine or his server would end up being. So this is what's called an out-of-band attack, where it's outside of the internal web server, and we need to have some kind of a HTTP connection or a DNS connection to actually receive the response from the SQL server. So name a protocol beginning with D that can be used to exfiltrate data, and that would be DNS for the domain name system, the domain name service. So let's talk about remediation. Very similar to everything we talked about with the previous injection techniques and everything else in general when it comes down to injection. The key things that developers can do is to have input validation, also known as sanitization. We can have prepared statements, and this is more specific to SQL. So in a prepared query, the first thing that a developer writes is the actual query, and then any user inputs are added as parameters to the query. So writing prepared statements ensures that the SQL code structure doesn't change, and the database can distinguish between the query and the data. And as a benefit, it also makes your code look much cleaner and easier to read if you are interested to actually go into coding. But the key element here is that all of the statements that would be made to the database are prepared in advance, and then the only thing that's modified inside of those statements are the potential inputs that are added by the user. Now, as long as there are no error messages or anything that can be displayed on the screen that would give the user some kind of a hint on what type of statements are being sent out, they shouldn't be able to modify the statements, right? So input validation would be the next piece that would be attached to this. So it's like you would do all of these things. You wouldn't just do one or the other. Input validation can go a long way to protecting what gets put into an SQL query. Employing an allow list can restrict inputs to only certain strings, or a string replacement method in the programming language can filter the characters that you wish to allow or disallow. Basically, this is sanitization. This is saying that this is what's allowed, this is what's not allowed, and we validate every single input that goes into the server by running it through a pre-approved list of what can and cannot be sent. That's kind of the name of that game. And then escaping user input that contains characters like the apostrophes or the double, the quotation, or the $sign or the backslash. These can cause SQL queries to break, or even worse, open them up for injection attacks. So removing those actually being available or being usable is what's important here. So prepending a backslash to these characters, which then causes them to be parsed just as regular string and not a special character. So this is what that escaping means when you actually do a backslash. And this is also, I think it's very similar to what happens inside of regular expressions as well. Like regular expression patterns, you can escape special characters so that they can be input as literal characters. So instead of when somebody tries to do the single apostrophe, or they try to do the semicolon, for example, if they try to do a semicolon, if we prepend that semicolon with this backslash, then it'll be treated as a literal semicolon, not a character that would end the statement for SQL requests, right? And that's the thing. So it would be a combination of all of these things that you would end up using as your remediation tactics, so that you can make sure that your SQL database and just your server in general is as secure as it can possibly be. And a method of protecting yourself from SQL injection, one of the methods would be known as prepared statements. And that's pretty much all we got. That's all she wrote. I would say this, out of everything that we've talked about so far with web hacking, this is probably the most complex video that we did for web hacking in Junior PenTester. And it's appropriate because this is the last portion of the web hacking module inside of the Junior PenTester training series. So hopefully it didn't drive you insane. Hopefully you were able to gather some of the information and kind of wrap your head around it a little bit. Most of the complicated stuff, they gave us a step-by-step walkthrough. So if you just went through these processes and actually input these commands piece by piece, letter by letter, you should have been able to achieve the same results, whether or not I even gave you any kind of instruction or kind of displayed anything for you. The hardest part was the last one, where we actually kind of had to be like, all right, so I think we're going to be dealing with the users table, and then from the users table, I think what we're going to try to pull is the username and the password. And that was also like, I kind of cheated because I'm like, oh, they're probably looking for the admin, so I skipped to the admin user, and then they're kind of looking for a password, so all we really need to figure out is the password of the admin user. And then thankfully it was just a 4-digit number, it made life a little bit easier. So I would say this is kind of the most complicated. It definitely was the most complicated out of everything that we've talked about so far. This was the most complicated. So be patient with yourself as you go through this. You don't have to understand it the first time around. This is not something, especially if you've never dealt with SQL before, this is not something that you're going to get the first time around. It took me some time to understand what SQL was. And I think it's important for you to give yourself that grace and to be patient as you go through this, because if you expect yourself to understand it on your first try when you've never been exposed to something like this before, it's unfair and it's going to discourage you and you're not going to want to continue. So this is not meant to be something that you understand on your first exposure to this information, because SQL just by itself is a language that you need to learn how to do and how to interact with databases. And what we're trying to do here is we're trying to hack into an SQL database. So it's like an advanced version of doing SQL. And again, it's not fair if you expect yourself to get it like this, like the very first time around. So that's the big thing that I'm going to tell you about this something. And I should have probably said this at the very, very beginning of the video, but if you've gotten to this point of the video and you're watching this and you're hearing this message, I really hope that you will be kind to yourself and you will be patient with yourself as you go through this process, and don't be critical, don't judge yourself for not getting it immediately right away. But that's pretty much it. We are officially wrapped with Intro to Web Hacking module for the Junior PenTester pathway, and now we can move on to the next module, which is for Burp Suite, and hopefully you'll join us for that as well. If you got any value out of this video, and if you'd like to get more videos like this one, I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. I'm sure you will have questions for this, so if you have any questions, please drop your questions in the comment section below, and I'll try to get to them, or I'll try to give you as detailed of a response as I possibly can in a comment. But hopefully the video itself helped you kind of wrap your head around what was going on. We have a lot of other videos that are going to be coming out in the future weeks and months as we go along. I am going to wrap up the Pentest Plus series of trainings, which is part of the CompTIA Pentest Plus playlist. We have all the other CompTIA resources that are available, and these are all complete. People have taken them to pass their certification exams. Their CySec 101 playlist, if you haven't seen that, that's a very important playlist because it helps you with your foundations. And every Friday, a new video will come out for CompTIA Pentest Plus until we're wrapped with that. And I think it should be wrapped in probably like a month or two. So I think there's like maybe 6 to 8 videos that are left for that specific playlist, and it will be completely done with that. And then there is, of course, the exclusives for Hackaholics Anonymous. We have SOC Level 1, SOC Level 2, Security Engineering. There's hundreds of videos on this channel, and there will be continuing to come out. So this is meant to be an all-inclusive resource for anybody who's interested in security engineering, engineering in general, cybersecurity, and penetration testing, ethical hacking. So this is kind of what my intention is for this channel, and I hope that it ends up being more valuable to you as well. So if you have any comments, drop them in the comment section. If you have any questions, drop them in the questions or comment section below, and make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, especially for Junior PenTester and PenTest Plus. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later.